Hey guys, welcome to Programming Knowledge. In this video, we will be looking at some basic concepts of computer programming and we will also be installing tools to help us code in C++. This video is going to be the first video in the tutorial series on C++ for beginners. Let's get started. The first thing we need to address before learning how to program is what is programming. So programming is basically a way to instruct the computer to perform specific tasks. And by specific tasks, I mean those tasks which a typical human will find it difficult to perform within a limited time frame. So these tasks are generally huge scientific computations or monitoring minute changes in the data, but we can make the computer perform any task of our choice by programming it to do so. So we need a way to communicate with the computer, right? We need to communicate with the computer to make it perform the task. So we do that by using special languages known as programming languages. You might have heard of famous programming languages like C, C++, Java, Python. So there are tons of languages out there, and in this tutorial series, we will be exploring C++. The next question comes is, why learn programming? So the first obvious reason is that computers are extremely fast. If you know how to utilize the power of computer programming, you can do wonders with it. For a typical computer of today's time, an addition of two numbers which could be as big as a billion is just going to take a nanosecond. So just imagine how fast a computer is. It can perform billions of additions in 1 second. That's the power of computers, and it is extremely fast in performing the task. Next thing is that computers are cheap. So nowadays any electronic gadget which is released in our market comes with an embedded CPU. So everything is basically a computer in itself. You have microcontrollers also. So you can basically turn anything, any electronic gadget into a computing device, and you can make it perform the task. Next thing is that computers can work 24/7. So if you have a big enough task, you can without any worries delegate it to a computer, and then computer is going to finish the task for you and keep it ready. So next question which comes is, why out of all the languages should we learn C++? So C++ is very close to the hardware. By learning C++, we can actually relate the concept to the hardware programming. So it's really a plus point for beginners who are willing to take up application development directly from scratch. Next thing is that C++ gives a clear understanding of object-oriented programming for beginners. We will discuss about object-oriented programming at a later stage, but for now, you can understand object-oriented programming is an essential computer programming concept which C++ will make it easier to understand. Next thing is that C++ has a huge fan base. If you have any query, there are tons of people out there to help you with it. Next thing, it is used in application and system programming, as I told. So if you are a software engineer, you can choose your career between application and system programming. Next thing is that it teaches you the difference between compiler, linker, loader, and other programming concepts. This is the main reason C++ is recommended for a beginner. I do agree that Python is much easier to learn and it can perform way more tasks than C++, but in C++ we will be dealing with everything from scratch. Even though there are libraries, there is a way to actually implement each and every concept from scratch. By using that methodology, we can actually learn everything to the core. If you are a person who is interested in the core concept and the origin of every algorithm or any other concept, C++ is the best language for you. Next thing is that it is widely used in applications. C++ can be found in many applications like games, animations, web browsers. You have databases and compilers, operating systems run on C++. C++ has a wide scope. Next thing is that it is extremely fast. So if you have an idea of competitive programming, it is basically a competition where our programming skills are tested within a limited time frame, and there is a constraint. So at that point, many programmers use C++. 99% use C++ as their language in competitive programming because C++ is extremely fast in parsing the data and working with the data. So if you're a person who needs immediate results, C++ is the language for you. These are some of the reasons for learning C++. So now we'll start by installing the tools which we will require to code in C++. The first thing we require is a software which can make the computer understand our C++ code. That software is called a compiler. So there is a difference between interpreter and compiler. We will be talking about that in a later video. But for now, we can understand compiler as a software which can convert C++ code into binary code so that the computer can understand. So some of the available C++ compilers are Apple Xcode. Xcode is an IDE. It comes with an integrated C++ compiler. You have Dev C++, CLang, Cygwin, and MinGW, GNU C++. If you are on Linux, you have the GNU C++ pre-installed with it. In any distribution of Linux, you can type G++ -- version, and you'll see the version of the compiler which came with your distribution. And if you're on Windows, you can directly go to Control Panel. You can go to the Programs and Features, and here, if you scroll down, you will see something called Microsoft Visual C++. So this is actually a C++ compiler provided by the Microsoft itself. If you are a gamer and if you have installed any heavy game before, you might have noticed that the game asks you to install the latest version of Visual C++ or update the Microsoft Visual C++ component in your computer. That is because, as I told you, C++ is used for building games, and then those games require the latest version of the C++ compiler to be installed in a computer. So Microsoft Visual C++ acts as both a platform and a compiler. And to use it, we need Microsoft products. You cannot directly use this Visual C++ compiler. These are open source compilers. Okay, some of these, the MinGW, Cygwin, and GNU are all open source compilers. Next thing we need is an IDE. So what an IDE is basically? IDE is an integrated development environment. So if we go by the definition of Wikipedia, it says an integrated development environment is a software application that provides comprehensive facilities to computer programmers. Basically, what it means is that IDE is a tool which is going to help you write your program. You can actually write your programs in Notepad also. For writing C++ codes, you just need a compiler, and you can even use your Notepad to write C++ code. What you need to do is just type your code in, and then you save it with a .cpp extension. So C++ files go by the extension .cpp, and then when you run it through the compiler, the binary file will be generated and the computer is going to execute it. But why we need an IDE is IDEs know what our code is. IDEs know our language. So while coding, what we need to do is we need to concentrate more on the logic than the syntax and semantics of the language. We need to concentrate on the logic than the grammar. So IDEs are a great tool because they have a feature of correcting the grammatical mistakes you make, the syntactical errors, which we call technically. Those errors are identified by the IDE, and IDEs actually sometimes they correct it. Some IDEs correct it basically, and some IDEs ask you to correct it before compilation itself. That's a great feature in IDE, and it also contains many other features like it provides you a debugging environment. We'll look at debugging when we are testing our application. The best IDE for Microsoft is Visual Studio. So you might have heard about this. Visual Studio is the best IDE you can find on for Windows development. You also get it with game development, and maybe Visual Studio is the best IDE for Microsoft. It's also available for Mac, but Xcode is better for Mac. So Visual Studio, you can actually download it. You can download the community version. It is free, but this IDE is actually a heavy software. Okay? It is going to take about 10 GB of space. So if you are running low on computer specs, you need to consider other IDEs. There are a couple of other IDEs as well. There are famous IDEs like Eclipse, NetBeans, etc. But for a beginner, I would recommend CodeBlocks as your IDE. So CodeBlocks is a lightweight IDE. You can search CodeBlocks on your favorite browser and open the first link, which is codeblocks.org. So this is the website here for CodeBlocks. This is an open source IDE, and it is really a lightweight IDE. You can make intermediate projects in CodeBlocks. You cannot use it for heavy projects, but for learning the language and working on intermediate level projects, CodeBlocks works the best for you. And it is not even big. It just takes about 500 MB of space. In our tutorial series, we'll be using the CodeBlocks IDE. You can download the source code or download the binary. Source code is for the people who are in Linux environment. If you are familiar with Linux, you will be finding yourself compiling everything from scratch. For that, the source code is also provided. But if you just need a straightforward installation, you can go to the download the binary list. Here you will find different files for different platforms. So in Windows, I'm here, and then you find it for Linux and Mac as well. You can download your version, and here we need to understand something. So code blocks is just an IDE. Okay, the IDE software is only going to be installed. We need a compiler. As I told you, compiler is first required. Then only we can compile our code. With an IDE, we can only write the code. You can download any of these compilers out here. You have Cygwin or Dev C++ or MinGW, but the thing is, it is going to be a bit complicated. Once you download the compiler, you need to actually integrate it with the integrated development environment, that is the IDE. Then only our code will be compiled and run by the IDE. For that, you can actually go to a favorite browser and then type for Cygwin, or you can even install MinGW separately as a compiler. These are some of the compilers, and you have TCC, GNU. The problem here is that once you download the compiler, you need to add it to the path. This is a complicated process, and for a beginner, I would not recommend adding compilers to the path and then integrating it with the IDE. So what I recommend is just directly download this file which says codeblocks 17.12 MinGW setup.exe. What this is codeblocks provides a inbuilt MinGW compiler along with the environment. This setup will contain the MinGW compiler, and then by installing itself, you install the compiler also in the environment. So the compiler is not set to work in the path. I mean, the compiler won't work in the whole computer, but it will only work in the environment in which codeblocks is installed. So once you download this setup file, you will be having a compiler, but that compiler will work only in the codeblocks environment. So that is actually recommended for a beginner, but if you like to explore more, we'll have a separate video on how to download external compilers and link it with our IDE. So Visual Studio doesn't need a linking because it directly uses the Microsoft Visual C++ compiler. So other compilers, we need to integrate it with the IDE. So for now, we are directly going to download this one. You can choose any of these mirrors. I'm going to go with FOSS-Hub. So once you are in FOSS-Hub, you need to wait for a few seconds download gets started, and you need to start the download. So I'm going to pause the video till it gets downloaded. Okay guys, so my download is completed, so I'm going to close it. I'm going to open the downloads folder, and in the programs I'm going to find the code block setup file. So this is a very straightforward installation in Windows. You just have to click next, and then you need to agree the terms and conditions. Leave it as it is. We need all these plugins, and you can actually change the destination folder. I'm going to leave it as default. I'm just going to click on install. So this extraction process is going to take about a minute, and once it's ready, we can launch our CodeBlocks IDE. So it is basically extracting the files and the compiler. So the compiler comes with the IDE itself. So you can just click on yes, and then it's going to open. And we can close this wizard. We can just click finish and finish over here. And here it says that a compiler is detected. The GNU GCC compiler, that is the MinGW compiler. You need to just click on this and then click OK. Now that is inside the code block, so it just comes with it. So you can, once you hover over the mouse, you can see the path of the MinGW compiler. It's inside the code blocks environment. So you can click OK. So you can just click OK. And this is the interface of code blocks. For now, we are just going to go create a simple application. Just click on create a new project, go to the console application. So all these are different kinds of applications we can develop with C++, but for now we are going to just go with console applications. So you can just click on go, and then we can skip this page. We need to select the language, so just select C++, click next, and then we need to give a project title. So I'm just going to say CPP1, and then the folder to create project in, I'm going to browse it. I'm just going to put it in my desktop. You can choose any location of your choice, and then just click OK. So here the file name will be created. So the .cbp extension stands for code blocks per project file. That file is directly accessed by the code blocks IDE, and inside that you will find a sources folder in which your CPP file will be there. CPP is the C++ file and CBP is a code blocks file. You can just click on next, and then you can leave everything as it is. It is just a compiler configuration, and then you are ready to code. So here in the left hand side you can see in the workspace you have CPP, and then inside that you have a subfolder known as sources. You can just click on plus, and inside that you will find a main.cpp file. So if you double click it, you will have the basic program over here. So this program just prints hello world to the console. If you want to run it, you can just press F9 or this button over here which says build and run. If you just click on this, it is going to build the application, it is going to run it, and here on the console we see hello world. So congratulations guys, we just compiled our first C++ program. So as I told you, these are some of the lines provided by the by the IDE. So it just returns it with the return code, and then there's the execution time. It just took 0.022 seconds to execute this code, and these are some of the features of the IDE. So what we wrote is just this thing. You can actually tinker around with this. You can actually change this line. You can make it as welcome to programming knowledge. And if we build and run it, we are going to see the output as welcome to programming knowledge.
In this video, we'll discuss about how a program actually runs, what compilers and interpreters do, and what are the differences between them. For a recap, this is the program provided by the code blocks IDE. I just changed the default hello world statement to this statement, and then once you press this button or the F9 button, you're going to execute this code and the console is going to pop, which is going to print welcome to programming knowledge or whatever statement you typed inside the double quote, and then it is going to return the execution time and all these things. Let us see what is actually happening in the background. Understand that first we need to understand what are the types of languages in computer programming. There are three major kinds of languages, that are machine language, assembly language, and the high level language. Machine language is the fundamental language of the computer's processor. Computer is not going to understand any other language than the machine language. All programs are converted into machine language before they can be executed, and machine language is just a series of zeros and ones that represents low and high voltage. Coming to assembly language, it is also a low level language that is similar to machine language, but the difference is that assembly languages use symbolic operation code to represent the machine operation code. Both the assembly language and the machine language are almost similar to C, but the only difference is that assembly language are a bit human readable than the machine language. High level languages are what we are learning: C++, Java, Python. All these are high level languages. They use English like statements, and every statement in a high level language consists of set of low level statements which are running in the background. Let's look at an example. So this is a simple program to do a mathematical computation. Let's not get into the details of it. The only thing we need to understand is that the computation which is going to be performed is b into h by 2. That is, the contents of b is going to be multiplied with the content of h, and then the result is going to be divided by 2, and that is the value we are going to get. So what happens in the background is that first memory location with the size of memory required for this particular object is loaded into the memory, and then the contents of B are transferred into the location R1. Same thing happens with R2. Then R1 and R2 are multiplied, the contents of R1 and R2 are multiplied, and then the result is stored back in R1. Next statement here divides the contents of R1 by the number 2, and then the result is given back to the memory location which is requesting the computation. All these temporary memory locations which have been created are then unloaded from the memory to be used in a different process. So this is what happens in the background of this simple computation. So in case of our hello world program here, or the welcome to programming knowledge, this one, what happens is that first a link is established between the console and our program, and then there is a process which will generate machine code from this particular code, and then that is going to be executed, and what we see as a result is this statement on our console. So there's a lot of process going behind. Let's see what a compiler is. So as I told you, compiler is a piece of software that translates the high level language to the machine level code. The compiler basically takes the source code and then it converts it into the executable code. This step is known as a pre-processing step, and then the executable code, which is the zeros and ones or sometimes assembly code, are converted into the machine code, which is purely zeros and ones, and then this code is executed by the machine. So compilation step consists of two steps: pre-processing and the processing. So a compiler takes a lot of pre-processing time. It is going to go through the whole of your program. It is going to read each and every statement. It is going to list all the errors, and then it is going to ask you to correct the errors. It is again going to review your program, and then it is going to finally generate the executable code once it finds out that there are no grammatical or syntactical errors in your program. So this is how a compiler works. Once the source file is loaded into the compiler, this is a case of generating multiple object files, that is compiling multiple source files. But in our case, we only have one source file, that is this main.cpp file. This is a source file. So if we try to compile more than one source file, that is also possible. We will be doing that at a later stage. So once it's loaded into the compiler, it is going to generate the low level code, that is the object code. Object code goes by the extension .obj in C++, and then this obj file is loaded into the linker, and then it's a runtime library. We will discuss about these things at a later stage, and then these linkers and libraries help to convert the object file into the executable program, which we get as a .exe file, which we can run by double clicking it on our computer. So what an interpreter is same as a compiler. There is not much difference. The only thing is that in interpreter the pre-processing step is faster than the case of compiler. In interpreter, the interpreter is going to go through each and every line of the code. It is going to execute that particular line in a virtual environment. And then once it encounters an error, it is going to stop right there, and then it is going to ask the programmer to correct the error. So once you correct the error, the interpretation process continues from that particular point to the end. That's why interpreter is faster at pre-processing, and then it doesn't generate an object file. Object files are generated in the runtime itself. That is why the processing time is big, because while executing the same program multiple times, every time at every execution, an object file needs to be generated on the runtime. Unlike the case of compiler, where only one object file is generated at the first time of compilation, and the same object file is used to run the program. That's why if we see this, if we change anything here, if I make welcome to programming knowledge as the default hello world, and if I just run this program, I'm just going to get welcome to programming knowledge. Why did this happen? Because the object file is the same in this case. In case of an interpreter, that is going to change. If you directly change this code here and then run the program, you are going to get hello world in place of welcome to programming knowledge. To get the hello world, we again need to generate the object file, which is clicking this button which says build and run. That is why we click F9 or build and run, because every time we change the code, we need to generate the object file, then only it is going to give the desired output. Or else it is going to work on the previously generated object file. So once we create this build and run, click on this build and run button, we are going to get hello world here. And now again, if we click on this button which just says run, you will get hello world, because the object file has been replaced now. And then if we make any changes wrong, if we just type hello here and then again click on run, it is just going to say hello world. That's how the object file works. Compile time and runtime. These are some of the confused terms. Compile time is the time taken to compile a program. Compile time is hardware dependent. Runtime is just the time taken for executing a program, and it is not hardware dependent. So if we are checking the efficiency of a program, we need to check the runtime of the program, not the compile time, because in a computer with higher specifications, compile time will be much faster than a computer with low specification, but the runtime of both the programs is going to be same. Next thing is that the source code and the object code are often confused. Source code is the code which we write. Source code is the .cpp file which we wrote here. This is the source code, and then the .obj file which is generated, or the object code which is sometimes generated in some language and sometimes is generated in the runtime. They are the machine code, and that is low level language. We cannot directly read the code unless we have an assembly language editor. The differences between interpreter and compiler, they are almost the same thing, just the working of the both differ. First thing is that as I told you, compiler translates the entire programming statements and then executes it later. It forms the OBJ file, and then interpreter first takes the code line by line, and then it is going to execute it in a virtual environment immediately. It is going to look at the result, and only if that particular line is correct, it is going to go for the compilation. Next thing, object code is generated in compiler, whereas in interpreter is not generated. It is generated during the runtime itself. Third thing, which is the most important thing, is that the runtime of compiled languages are much faster than interpreted languages. This is because compile code makes only one OBJ file, only one object code, which is used to compile it again and again. In case of an interpreter, is generated during the runtime. So every time an interpreted code is run, an object file is generated in the runtime, and that is going to be executed. So we are comparing the performance of C++ and Python. Python is an interpreted language. C++ will perform much faster than Python because of the OBJ file which it is going to save on the disk. Python is not going to save the OBJ file. It is going to generate the OBJ file every time it is executed. So that is the difference between interpreter and compiler.
In this video, we'll be looking at this template code which CodeBlocks had provided us while creating a project, and also we'll be learning how to perform simple output in C++. Let's get started. So the first line here says #include IOStream. #include is known as a preprocessor directive. So #include is used to load files which are already present in the compiler. C++ compiler comes with many files which have predefined functions to help us code with. So IOStream is one of them, and by using this preprocessor directive, by using #include, we are actually invoking this file from the compiler. So without this file, you cannot perform any input or output in C++. There are many other header files we will be coming across in the run, but for now, let us explore IOStream. IOStream contains all the functions which we need to perform console input or output. So IOStream basically stands for input and output stream. So by name itself, we can say every function we need for performing input or output is present in IOStream. Next is this line. It says using namespace std. So std is known as a scope. Scope we can understand like a region. So every function inside this IOStream works only in a certain region. So for now, we are not going to deal with any other scopes other than the standard scope, but just for information, there are other scopes also that we will be learning when we are pretty good in C++. That comes at an advanced stage, but for now we can see only use the standard scope. Standard scope is nothing but the console. So if I just remove this line, you will be seeing that all these functions go out of the scope. So now if I build and run this by hitting F9, so now you can see that it shows an error. What does the error say? It says that cout was not declared in the scope. This just means that this line or this particular function cannot be executed because it is out of the scope. Scope is nothing but the standard scope. The way we define standard scope is by using the scope resolution operation. Scope resolution is nothing but you just write the scope and then the function, and in between the scope and the function you just specify the scope by putting 2 colons. So this is how you specify the scope. So if I now execute it, yeah, I'm getting another error because this endl is also from the IO stream, so it does not have that scope. So I need to provide the scope for this also. Now if I build and run this, I'll be getting the output. So here you can see welcome to programming knowledge. So that is the importance of scope. Then why do we need using namespace also? Well, you cannot do this for every statement, right? It is going to be it is going to take a lot of time to actually do this, and sometimes you may also forget to do this. So suppose I'm writing 10 cout statements. This is a cout statement. Cout is nothing but the output statement. This one, what I'm printing onto the console, is known as a cout statement. So this statement, if I'm writing 10 times, I need to specify the scope 10 times. So every time I use this function, or not only this function, if I use any function from this IOStream library, I need to actually specify this particular standard scope. That is why, to avoid that, C++ provides a way to globalize that by using the namespace statement. So by writing using namespace std, you are actually globalizing this statement, and it is going to take care of any other standard. So if you don't write the standard, it is automatically taken care of by the compiler because it just encountered this line. This line just means that wherever standard scope needs to be used, you just use it. That is what this line means. So the next line says int main. Main is actually a function. Every program has a main function. Main is like a triggering function. So every program has this. Without main, there is no program, because all the execution starts only from the main function. So suppose you write 100 file program, or even say 1000 file program. They may contain n number of functions, but there is only one main function, and that main function cannot be replaced. And without this main function, this program is not going to run. So if I simply just type a capital M over here, well, C++ is case sensitive, so capital M main and a small m main are different. So now if I try to build and run this, I'll be getting an error. It says undefined reference to this win main @16. This is actually something which is inside the compiler. It is a compiler issue. That is because it did not encounter the main function. So only if you write the main function, you are going to execute it. So first thing any C++ program looks for is this, for this function. It needs to be main and with a small m, and it should be empty. You can actually put void over here, so that also doesn't matter, but it just makes it look complex. So it's best to leave it empty. So if you put like this, and then it has to be int. The reason we'll be looking at it later, and the meaning of this int and this return 0 we'll be understanding only when we are dealing with functions. So for now we can ignore them. So just remember that you need to write int main. Any other main doesn't work. So suppose if I put void or some int, let's say float main, all these are not going to work. Only int main is going to work. And for now you can actually remove this return 0. So without this also the program is going to run, and it's going to give you the output. There is a lot of significance for the return statement, and we'll be discussing about that when we are discussing functions. So this, as I told you, is the cout statement. Just stands for the console output. So cout stands for console output, and whatever you write here goes to the screen. And this operator is known as the stream operator. Stream operators are very important. We will be looking at it while we are dealing with other streams also, like file stream or something like that. But for now, while we are using the IO stream, that is the console stream, we need to have these two functions in a pair. So this is the stream function, that is the cout, and this is the stream operator, and this is the stream operand. This is a statement, but technically in computer programming, this is called a string. String is nothing but a collection of characters. It is called a string. So that is a data type. We'll be talking about that in the next video. So for now, this is what the program was. And yeah, I forgot to tell you this one. This is actually appending another function in the same cout. So cout actually operates on only one operand. So if you want to operate on multiple operands, you need to separate that with this stream operator. So see, this is a string and this is a function. Endl is actually a function. So the way it works is it is going to first operate on this, and then it is going to encounter this, and then it is like adding another cout statement. That's it. So if I just put a semicolon here and then put a cout over here, it is going to work the same way. Just that it is not to get you confused. These are two separate search statements. If you're wanting to put multiple statements in a single statement, then that is how this is how you do it. You just put a operator in between and then put the next operand over here. And this semicolon is very important. You might have noticed a semicolon over here also. Semicolon is known as a terminator. So in C++, you can write multiple commands in the same line. So terminator, what it does is it is going to separate each and every command so that the compiler knows what command to execute after executing the previous command. So that is why we use a terminator. It is very important. So if you remove this, it is going to result to an error because it doesn't terminate and it says expected the semicolon before this particular token, that is this one. It expected a end of a statement before this one. That is why we put a semicolon, and this curly braces just signify the body of the main. So whatever code you write, you are going to write between these two braces for some time until we get familiar with functions. So once we are familiar with functions, we will be writing multiple functions and we will be invoking the functions within this main method. We will be looking at that later, but for now, let us talk about the output. So we all know how to put output, right? This is how we put output. We just put them inside two double quotes. Well, this is a string. We can also put numbers also. So for numbers, you can either put it as a string. So you can put something like this, right? And then execute it, you'll be getting 5 over there. Or integers are separate in programming. So even if you put a 5 like this, you're directly going to see 5 in the console. So here you can see. And now comes the major difference. If I put 5 plus 5 over here and then execute it, I'll be getting 10 over here. That is the value of 5 plus 5. But if I just enclose it within a quote, within a double quote, what will I get? I'll just get the same thing. I'll just get 5 plus 5 because this is treated as a constant string. What this double quote means is that whatever you put inside this double quotes is just going to be replicated as it is on the screen. And if you don't put a double quote, it has to be either a memory location or some operand. So memory location or variable we'll be looking at the next video while we are discussing input. But for now, and output, we need not bother about memory location. Let's just talk about the integer part of it. So if I just put let's say let's try another one. Let's put something like this, 5 plus 5. Let us try this one. These are two different strings and I have used a plus operator between these things. So what we expect is actually 10, but let us now execute this and look at that. It says invalid operands of types const char and const char. What this means is you cannot add two constant characters or constant string. What const char and this square bracket is? Square bracket is actually called an array. Okay, so we'll be looking all of these things when we are discussing data types. But for now, we can you can understand that you cannot add two strings. You can only add two numbers. So if I just put 5 plus 5, I'm going to get the answer. So here, so this is same with real numbers also. You can even put 0.5 plus 1.5, so that makes it 2. So here you will be getting 2.2 over here. So, and you can even work with decimals also. Even if I put 1.45, you're going to get the answer. So you will be getting 1.95. So that is the major difference between strings and numbers. So if you are working with numbers, you can directly add them, you can multiply, you can divide. Multiply here is the star symbol, which you will be finding on the 8 on number 8 on your keyboard. So that is the multiply symbol, and then divide is the normal forward slash symbol. So this is the divide and multiply. And there is another one also. There is another operator that is called the modulo operator. What this does is it gives the remainder of the two numbers, right? So what it means is if you just put 5 modulo 2, what this does is it gives a remainder. So if you divide 5 with 2, what is the remainder you are going to get? You are going to get 1, because well, it is 2 into 2 plus 1, which makes it 5, right? So this is the operation. So that is why, so 2 goes 2 times in 5, and then 1 is the remainder. That is why you are getting 1. So you can verify that. You can do that by simply putting 2 in, well, you can directly put 5 more 2, right? You're going to get 1 over here. So if I just run this, here you can see 1. There are many other operators. We'll be looking at them later. These are the this is how you can perform output in C++. Well, there are other things also, like instead of using this, we have something called escape sequences. Let me talk about them quickly. It is escape sequences. What these are is basically there are some keyboard strokes which we cannot perform during runtime, right? So suppose we wanted to perform a backspace during the runtime, it is not possible. I'm talking about the runtime. So suppose I wanted to hello world over here, suppose, and then I wanted to perform a backspace for this extra space I have provided over here. I cannot do that in the runtime, right? Now I can do anything. I can even put this, I can change this character, I can do anything I want. But what about during the runtime? For that, there are some special keystrokes that are actually treated as escape sequences. So the way we define escape sequences are, you actually put a backslash and then a special character. So here there will be a special character, and then this is going to actually give you a special meaning. So this is going to execute that particular keystroke. So there are some of the escape sequences, like slash a, it's going to ring you a bell. So you might have noticed that there will be a notification bell that will come, and then there is a slash b, which is for backspace, and then slash t and slash n, we'll be using these things more often. Slash t is for a horizontal tab, and then slash n is for a new line. Wait, we did see this one somewhere, right? This one. So endl is actually a function. There is actually a significant difference between using slash and an endl. So I'm just going to delete these things. Let us first try slash a. So first slash a, I'm going to run this. So you might have heard that sound, right? That bell sound. That is the function of slash a. So let us look at slash t. That is just, it's going to put a tab. So let me put a tab between hello and world. So if I put slash t over here and then execute it, here you will be seeing hello and then this space and then a word. So this is what the function of slash t, and then slash n is what going to do the same thing what this function does. It is just going to put the contents in the next line. So if I just execute it, there will be a new line. So hello and then a new line and then the word. So that is the function of slash n. In this video, we'll be looking more about the escape sequences, which we had talked about in the previous video, and we'll be learning how to perform input in C++. So before getting started with the input, let's talk more about the escape sequences. So the escape sequences which I talked about in the previous video are slash a, slash b, you have slash t, and then once again slash t, slash n, right? There are actually many other escape sequences also. You do have a slash v, but all these things we won't be using much. Slash v is for a vertical tab. We won't use that much, but you can always go up into the internet and then check for the list of escape sequences there. So what do we need escape sequences for? Is it just to perform these actions, or do they have other purpose also? So let us say I wanted to print something like this. So let us say I wanted to print escape sequences. Let me just put it without a brace, so that this is the exact sentence I will be needing on the screen, right? So just try to print this. Escape sequences start with a slash and have a character and have a let's say single quote single, or have a single character in them, something like this. I wanted to print this particular statement as it is onto the console. You might think it's very easy, right? Just cut it. Well, I'm just going to cut it and then put it in pair of double quotes and then paste it over there, and then let's just run it. It says it's an error. Why? It is expecting a semicolon before single. Well, we do have a semicolon, right? What's the problem with this? Well, the problem is when you are putting a backslash in a string, it is going to consider a backslash and the subsequent character as a escape sequence itself. And here, once you put a double quote over here, it means that this is a separate string and then this is a separate string and this is actually something in between, right? So it doesn't have any meaning at all. So what we actually wanted was we wanted this double quote to appear onto the screen, right? But we cannot do that. Do we have a way? Yes, we do. That is by using escape sequences itself. So here I wanted a backslash to appear, right? So how do we make a backslash appear? Backslash itself is an escape character. When the workaround is you put another backslash. So this what it means is it means that this is an escape sequence and this particular escape sequence just means that you need to put a backslash on screen. So that is why you were getting an error back then, and now you will be getting a backslash perfectly as you wanted it. And here, instead of these quotes, you actually put a backslash before the quote, right? So what this is if you put an escape quote over here, if you put a quote as an escape sequence, it means that this quote is not a part of this quote, which is actually indicating the start or end of a string, but it's an escape character itself and it needs to be printed onto the screen. That is what means if we use a quote with a escape sequence. So the same thing goes over here also. If I just put a backslash, it is going to go away. This is now entirely highlighted in blue. That just means that this entire thing is now a string. And now if I execute it, I'll be getting the output. So here you can see escape sequences start with a backslash and have a single character in them, and single is enclosed within double quotes. Now exactly what we wanted. So that is the importance of escape sequences. So there are many places where you will be needing them. So something like you wanted to enclose something using double quotes, or you wanted to put a backslash over some place, or suppose you wanted backslash n to appear, but you can't directly print like this, right? You know what this is. Backslash n is actually a new line. So if you put something like this and if you try to execute it, you will be getting something like this thing. Escape sequences start with a and then a new line and then a space and then have a single character in them. So that becomes a problem. How do we do that? Same thing, you just put double backslashes and then so now this backslash and this backslash n are now different. This backslash only corresponds to this backslash and then this n is now treated as a separate character. So now if you run this, you will be getting your output. So escape sequences start with a backslash n, you just got what you wanted and have a single character in them. So this is how you use escape sequences in your strings. Now let us talk about the input. Before talking about input, let us talk about something called data types. Let me write it down here. Data types. Why do we need to know about this? Well, you can't just take input, right? You need to store the input at some place so that you can use it at a later stage. So where we store the data is actually defined by the memory location. And how we allocate memory, that depends on the type of data we are going to get. So we need to know what kind of data we are going to get as an input so that we can store that data. So what kind of data can we get? We can either get numbers or characters, right? We can't get anything else. Well, we do have other types of data also, something like you have graphs or you have images, videos, but all that are ultimately broken down into numbers only. That's a different story. We're not going to talk about that at this stage. But for now, we can say that data is fundamentally consists of only numbers and characters. We can't get anything else other than that. So the way data types are broken down as to satisfy either numbers or characters. So in numbers, what do we have? We have integers, or we do have real numbers. So real numbers are nothing but decimals, fraction, all these things. So the way we take integers is by int. So int is the data type which is for integers. So this is the data type and this is what it means. So integers it's going to take. So anything, any integer it's going to take -12 or 20 or 20,000. All these are integers only. So can it take anything? Can it take even infinity? Well, no. Integer do have a range value, and that ranges. So let me write it separately here. That ranges from -2 power 31 to 2 power 31 minus 1. Well, it's not 2 into 31, it's 2 power 31 minus 1. So this is the range of the integers. It is going to take up to this big numbers. So you do have something called short and unsigned, signed ends, all these things. We will be talking about that at a later stage. For now, this is the range of integers. So you can store as small as -2 power 31 and as big as 2 power 31. 2 power 31 is nothing but it's around 4 billion. So that is the number you can store in int. So what if we need a bigger number than 4 billion? Let's say 6 billion or 8 billion. For that, we do have a solution. We are going to use long. So long is another data type. So long is actually a type modifier. It is not a data type. Long, you can use it with int. So this actually makes it pretty readable. So it is nothing but a big integer. So what it does is it's going to store bigger numbers than int. So this will take about 8 bytes of memory. This is going to take only 4 bytes. So this is 4 bytes of memory. We'll be looking at how this 4 bytes right now. There's actually a way to check how much memory this takes. So this is going to take 8 bytes of memory, and its range is approximately up to 64, 2 power 64. Approximately it goes up to this. So this is a huge number, right? You don't practically need much bigger than this. 2 power 64 is very big. 2 power 32 itself is big, right? 2 power 31, 2 power 32, they almost go up to 4 billion. So you don't need bigger numbers than that, but in case you need, you have long integers. Same goes with the real numbers also. If you are working with smaller decimals or real-time decimals which are not so big, you have float, which is for decimal numbers. So you got -2 or sorry 0.2, or you got something like 0.0003 or all these things. So 12.0 also, if you just put a 0.0, it becomes a float, and these are all floats. And then if you want bigger floats, you do have double. Double is for bigger floats. This again is for 8 bytes, and this is the range of double. So in C++, if you did not specify the data type, if it is if just a number, if it's just an integer, it is always going to default to integer only. And if it is a decimal number, it is always going to default to double. So what I did here is just added a comment. So comments are those statements which are not executed by the compiler. I'll be showing a demo shortly. So for regarding data types, these are the data types for storing numbers. And for characters, you don't need much. You have only 2 types of character inputs. That is, you get only one character or you get a collection of characters. So for one character, you have char, that is for one character. And for multiple characters, you have strings. So strings is actually more than just collection of characters. There's much more to talk about strings. We'll be doing that at a later video. So now for characters, the way we define characters is by using single quotes. So you have, if you put anything inside a single quote, something like A, or if you put B over here, or exclamation mark, anything inside a single quote, but only one character, strictly only one character. You cannot put multiple characters inside a single quote. That will cause an error. And the fun fact is, if you put something like this will also become, even though one is an integer, if you put it inside a single quote, it becomes a character. The same goes with decimals also. You cannot put decimals inside single quotes because it contains more than one character, right? So even if we put 1.0 something like that, 1 is a character, this period is a character, and then 0 is also a character. So you cannot put more than one character inside string. So that will come under strings. So strings, how do we define? Like we did here. So using double quotes. String is just a collection of characters. Collection of characters. That's it. And it is going to be enclosed within double quotes. So anything you put inside double, even if you don't put anything inside double quotes, this is also a string. This is called a null string. We'll talk about null and all these things at a later stage, but for now, just for your information purpose, I'm just telling about the null string. And you do, even if you put something like this is going to be a string. It is just a space, and even one character also it is going to be considered as a string. So this is also a string. And now you can put something like 1.0 or 1.0002. All these are now considered as strings. The way you represent data is very important. If just take numbers, if you just put 1, it is going to be int. If you put 1.0, it is going to be double. Remember that here. If you put if you do not specify the data type, it is going to be defaulted to double only in C++. And if you want the data type to be float, you can just add an F over there. So if you just put F over here, it is going to be float. The same goes here also. If you want this one to be considered as long, you just put an L over there. So this is considered as long. And how do you define a character? Put like this. This is going to be a char. And if you put it like this, this is going to be a string. So see how differently it is interpreted if we type the data in a different way. So this is the importance of data types. Anything we get from the character is categorized only into these data types. So we don't have to worry about any other data. Whatever we type is just going to be a subset of all of these things. Now let us work on some real input. Yeah, forgot to mention about the comments. So let us know, well, we can actually show the comment over here only. So suppose I want this data, but this is something for you to understand, right? So these are not part of C++ comments. These are something I typed, right? So these don't make any sense in C++. But I don't want to delete it because I'll be using it to explain to you guys. So how can I do that without, and also run this program without actually going into an error? I cannot write another program and use a separate file, right? I don't want to do that. I can, but I don't want to do that. Well, for that, we have something called comments. I need this data, but I don't want the computer to execute it. So what I do is I'm going to hide this data from the compiler. So the way we do that is by using these lines as comments. So comments are actually used to explain some lines of code, and also they are generally used to actually debug the program. So if you are developing a big program and you don't want some of the lines to execute and you directly want to see what is the result of 2 or 3 lines, you can actually comment out the other lines and you can see the result. That is going to be very useful when you're testing the program. So for that, comments are there. So there are 2 types of comments. One is a single line comment, which I did over here. So this is just going to comment on this entire line. So whatever I write after this pair of forward slashes is considered a comment. So all these are commented out. And then if I need to comment out multiple lines, the way I do that is by putting a forward slash and putting a star over there. So you can see all these are grayed out now. And the thing is, it is completely graying out my program. So even this thing is grayed out. And now if I try to execute, I will be getting an error. It says that this unterminated comment is there. That is this one. See, this one has been started, but it is not terminated at any point. So I want to terminate my comment over this line because these are the lines I don't want the compiler to execute, right? So to terminate, I'm just going to do the reverse of it. I'm going to put a star and then a slash. So this is actually going to comment out all these lines. These lines stay in my program code. These are not going to be executed by the compiler. So now I can run my program without any issues and I'm going to get the output. So that is the importance of comments. We will be commenting out many things at a later stage when we are working with bigger programs. Comments are very important. So now let us write some useful code. Let us now write a program to add two numbers. So it is always wise to actually put a comment on what you're doing, and also put some authorization. So you can put something like @author or something like that. You can do all those things. But for now, I'm just going to write the name of the program. What I'm going to do is I'm going to write a program to add two numbers. It is always advised to put comments before your program code. You don't have to put it over there only. I'm just putting it there. You can put it anywhere you like. I can put it inside here also. I can put comments anywhere I like. Now let us write a program to add two numbers. So first thing is I need to ask the user to enter, because obviously we need to ask the user something, then only is going to know what your program is doing. So let us say enter the first number. Simple. Enter the first number. And now how do we now we need to create a memory location. I told you, right? We need to create a memory location to actually store our input. The way we do that is we need to first specify what kind of data we are going to get. What we can, because it's a number, it is actually going to be floats or doubles, right? We can add any number, but for simplicity purpose I'm just going to go with int. You can actually go with floats or doubles also. It is completely up to you. I'm just going to go with int in this tutorial. So I'm just going to type int, and then I need to name the location. We need to give some meaningful name. So this is also known as a variable declaration. We are just creating a variable to store something. So this can be understood as a mathematical function, right? So we are just going to put x equal to 5. It just means that variable x is storing the value 5. But in computer, this is what is happening. If you are declaring a variable, it means that you are actually creating a memory block and then assigning a name to that. So it's just like an alias for the memory block. So here I'm just going to name it num1 just to keep it simple. And here you can do two things. You can either specify the value which is going to go inside the memory location, or else you can even skip that. So here, since I don't know what is going to go inside this location, I'm just going to skip it and enter a semicolon. This means that this command is terminated. So while executing this command, the compiler will know that it has to just create a memory location. And now, how do we get the input? It is just the reverse of it. You guessed it right. If it is C out, it is going to be C in. And then if it is this side, this is going to be on the opposite side. Well, this is how we take input. And then in where do we need to store the input? We need to store it in this location. So just write num1 and then put a semicolon. So we got our input inside num1 location. Same thing we need to do for the next number also. So I'm just going to copy paste that, and here instead of first number I'm just going to write second number, and then instead of num2 I'm just going to store instead of number I'm going to store it in num2 location. Now I need the sum of these two numbers, right? So remember that I can directly put numbers, so you can directly show the sum like this. So you can write sum is, and this one, and then what was that, num1 plus num2. You can directly put like this, but this actually makes it a little bit confusing, and it is always advised to keep your code very understandable. So if somebody is reading your code, they should understand what is going on. So this is not always a best practice unless you're into competitive programming. You need to consider all memory and all those things, but we are now learning, so it is always advised to use as many variables we want. So for storing the sum, I'm just going to go with an integer. So because if you add two integers, you're only going to get an integer, right? Well, I'm not talking about the border cases where you go with very big numbers like 2 power 32 plus 2 power 32. That is obviously going to go out of the range of integers. But I'm just talking about normal cases. So I'm just going to store it inside this location sum. And what it is going to store, it is going to store the value of num1 plus num2. And then I'm going to invoke the sum over here. So remember in the previous video I told that memory locations and numbers can be accessed without this double quotes. That is why I put sum without double quote. And now if I execute it, here we have our first program of addition. This is our first useful program. It is not just printing something onto the screen. It is actually doing something for us. So here I'm going to enter the first number, it is 12. Second number, let's say something like 24, and then if I enter it, the sum is 36. Perfect. 12 plus 24 is 36. We got our answer. Yeah, I forgot to mention the way we check size of the data type is by an operator called size of. So how we do that? We just put size and then put an of, and inside the brackets you're going to name your data type. You can either put the data type or you can put the data itself. So if I just put 1 over here, and let me put an endl so that you don't get confused with that compiler statements. So here you are going to get 4. Why? Because 1 is an integer. As I told you, it is going to be treated as an integer only. And if I just put 1.0, as I told you, it is going to be defaulted to double. That is why the size is 8. And now if I put 1.0f, it is going to be treated as a float, and you will be getting only 4 bytes. So that is how size of works. And now if I just put a character, it is going to take only 1 byte. So if I just put like this, you're going to see 1 over here. And then even for a null character, that is, I'm not putting any character, these are just two codes side by side. Even if I run this, I'll be getting an error. It says empty character constant. That cannot be done. Another thing is, if you just put one character inside double quotes, let's see what happens. In single quote, this written 1, right? So what will happen in the double quote? Well, as I told you, string is nothing but a collection of characters. So maybe it will be the count of the characters, right? So something like hello, if I just put hello, then this is actually 5 characters, right? HELLO makes 5 characters, so the size should be 5, right? But you'll be surprised that the size will be 6. So that is why I told you strings are something more than just collection of characters. There is something called a concept of terminating character or a null character. We'll be talking about that when we are discussing strings. So that's all for this video. In the next video, we'll be talking about strings and how to use them in our program. So till then, I would like you to actually meddle around with the code. I would like you to do as many errors as possible and try to read these errors. Errors are very important. So you just try to do something like this and then compile. You know that this is going to result in an error, but what is important is this message, because every time it is not going to give you a perfect message for your error. So something, if I have something like this, if I just forgot a semicolon over here and then put something like uh, let's say hi over here and then put a semicolon, and if I try to compile it, it is going to show an error in this line. It says in line number 8 it is expected it expected a semicolon before cout statement, but there is a semicolon statement. Where is the error? It is actually in the previous line. I forgot to put a semicolon in this line. So that is why you make as many errors as possible and try to understand these lines. These are very important. It is going to help you to write better code. You won't find yourself trying to figure out where the error happened. In this video, we'll be talking about ASCII, or American Standard Code for Information Exchange. So what is this? This is basically a number which is associated with every character. Let me give you an example. The previous video we wrote a program for adding two numbers, right? So same thing we are going to repeat over here. So let's say enter first number, and I'm going to create a memory location and take an input inside that location. Let's say A, right? So instead of A1, I'm just going to name it A, and same thing is going to happen. Enter second number. Okay, let me give a space over here so that it looks nice. And int B, CNB, and int sum equal to A plus B, and we are going to just say the sum is, and the sum, right? We wrote this program in the previous video, right? So you all know what it is going to do. It is just going to ask for two numbers. We are going to input that, and it's going to process those two numbers. It's going to add those two numbers, and then it's going to store the value inside this memory location, that is sum. And then here the memory location is invoked, and the value inside that memory location is going to be displayed onto the screen. Here now, what if I just change this int to some other data type, let's say char, and here also let us say char. Now let us run and check this out. So here it did not show any error and it is working perfectly. So now if I just say 1 over here, enter first number, that is 1, enter second number 2, and now the sum is going to be something different. So you might think it's going to throw an error because we are trying to add 2 characters, but as I told you, characters are actually a form of integers only. Computer stores character in form of integers. So this addition is completely valid, and the value the sum is going to store is actually the sum of the ASCII values of those characters. So 1 holds the ASCII value of 49 and 2 holds the ASCII value of 50. So once you press enter, you are going to get the sum as 99. That is 49 plus 50, that is 99, right? That is why I told you that representing data in different forms is very important. So if you write 1 like this, it is going to be, let me write separately somewhere in the bottom. So if I just type 1, this is an integer. And if I put it like this is a character. So that is why I told you the way you represent data is very important. So instead of size, that is 4 bytes and one byte, so that is also there, but here this integer is actually processed as 1 only. So it is processed as 1, and this thing, it is processed as 49. So this is the number it is going to process when you just say a character 1, right? So every character in your keyboard has a ASCII value. So to look at that, just go into your favorite browser and check for ASCII over there. And here you might see many links, so just click any of them. So they are going to give you a table of ASCII values. So this is the ASCII value, and this is actually the decimal, and this is the hexadecimal representation. You don't need to bother about the hexadecimal representation. What is important is this decimal representation and the symbol associated with it. So you can see the null is associated with the ASCII value 0, and there are many other characters. So 13 is actually the carriage return, that is the enter key, and 27 is the escape key. So here you can see 27 is the escape key. So what is important is our numbers and characters. So those ASCII ranges are only very important to us. We'll be using them interchangeably while dealing with data, right? So mostly data consists of only numbers and characters. That is why we need to remember the range of numbers and characters ASCII values. So here number starts from 48. So here you can see 48 is 0. So it starts from 0 and goes up to 57, that is 9. So this is the range of ASCII values. So 48 to 57, that is the range of numbers. And capital A starts from 65 and goes up to 90. 90 is capital Z. Likewise, small a starts at 97 and then it goes up to 122. So 122 is small z. So these are the ranges. So let me write that down here. So let me put a comment. So this is a multi-line comment. So 0 starts at 48 and 1 is 49 and likewise, right? Okay, I put an underscore here. Same way, capital A is 65, capital B is 66, likewise, and small a is 97, small b is 98, and it goes on. So these are some of the important ASCII ranges. We will be dealing with this while we are working with the conditions and all those things. We will be looking at that in a later video. But these are some of the ASCII values which we will be using very frequently. So it is better that you remember the starting value, because the other values you can directly derive from the first value. So 0 is 48, capital A is 65, and small a is 97. So these are some of the values that would be very helpful if you remember these things. So now you know how to predict the output, right? So let us try with some other characters also. Let's just put this as a character only. So instead of int, I'm just putting it as char. Now if I try to build and run this, so here it is asking for the first number. Let's say some random character. I'm just putting this question mark and this apostrophe. So let us look at the table. So question mark is 39 is the apostrophe and 63 is question mark. So 63 plus 39. So now if I just put it, the sum is f, that is over here 102, right? So that is how ASCII ranges work. So they work just like numbers, just that the character is associated with a special number and you need to know the number to actually correctly predict the output. So sometimes you may miss it out, right? So sometimes you may put a character and try to add two characters and see absurd answers. Those are not absurd, just that your logic is wrong. So here, if I just put an int and character, sometimes this happens. So if I just put an int over here and char over here and then try to build and run this. So first I will put 1 and then put an A. So now the output is going to be B because 65 plus 1, that is 66, and the character value of 66 is B. So you can check that from this table. So here you can see capital B is 66, right? So ASCII values are just like numbers. So you're just going to operate them as you're going to operate on numbers. So you can put, you can add one or you can multiply it so into 2. That is also possible. So it is only character. So let's just make character. And then once I try to run this, here it is 1 and 2. So here the sum is B because 48 into 2, that is 49 into 2, that is small b, right? That is 98. So here you can check that out. So 49 into 2, that is 98. So 98 is b. So you can do that. You can divide those things. In this video, we will be looking at conditional statements. So what are conditional statements? What are conditions basically? Conditions are those set of rules which define a particular procedure to be followed. So what do I mean by that? Let's take an example. Suppose you want to sort out all those files which you created yesterday from the C drive or from the desktop. So the way we do that is we take all the files, we look at the date when it was created, and then if it matches yesterday's date, we put that inside a separate folder. Or else you leave it or you put it inside another folder, that doesn't matter. Our only focus is we are putting those files which were created yesterday into a separate folder. So when you're checking whether the date matches or not, you're actually performing a conditional operation. So that is what conditional operators or conditional statements do. So conditional operators work like if something is there and you need to follow some procedure, or else you need to follow some other procedure which may or may not be defined. If it is not defined, you need not do anything. If it is defined, you need to follow that procedure. So it is like if something, then you do something. So do procedure 1, suppose, and then else what you need to do procedure 2, or you can leave it, right? This does not need to be defined. So this is not important. What is important is this condition. This condition, if that something is satisfied, then only you need to do procedure 1, or else you need not do anything, or you need to do some other set of statements which are defined. So that is how conditional statement work, and the same goes with C++ also. So the way you define conditional statement is you put an if, and then inside a pair of parentheses you put a conditional statement, and here you have a block. So this block is different from this block. Here I'm writing it. So this is if block. So this executes only when that condition is satisfied. And then if this condition fails, in our example, suppose some other file came up which was created 1 year ago. So what you need to do, you need not do anything, or else if you want, you can put it inside another block. That is up to you. So do that as else. If that condition fails, you have another block, you need to follow this particular procedure. So this set of statements or this set of rules execute only when this rule is true, or this conditional statements evaluate to true, or else it follows this else block. So the way you define conditions is by using operators called relational operator. Relational operators just give the relation between two operands. So these are same as the mathematical relations. You have a greater than, you have a less than, you have a greater than or equal to, less than or equal to, and then you have an is equal to. This is equal to. So do not get confused with the single equal to sign we use. So by declaring variables, I told that int a equal to 10 means a holds the value of 10. So this single equal to operator is known as the assignment operator, and this double equal to is the is equal to operator. So the difference is when you tell a equal to 10 and a equal to 10, this means that assign the value 10 to a. So this is what this statement means, and this statement means compare a and 10 and check its equality. So this is what it means. So this double equal to means that you will take the value of a, you will take 10, you will compare it, and if they both are equal, then you say it's true, or else you tell that it's false. So this single equal to operator just means that you put this 10 inside this memory location a. That's what it means. Here, another point to notice, 10 equal to a is an error. So here, even though mathematically both the statements are same, 10 equal to a cannot be processed because the computer always wants the left hand side to be memory location. Whatever the right hand side is, it can be a memory location, it can be a constant value, it can be anything. So whatever it is, it has to go into the left hand memory location by using this operator, which is the assignment operator, and this double equal to operator can work either way. So even if you put 10 equal to a, this is the same meaning. It takes 10, it takes a value of a, it compares it, and if they are equal, it's going to tell yes, or else it's going to tell no. So these are the operators, and you have another operator. This is double equal to, which is equal to, and then you have a not equal to. Not is basically this exclamation mark over here. This is not equal to. So these are the operators you use to check the conditions. So let us look at a quick program. Let us make some program, let's say, to check whether the person is eligible to, let's say, drive a vehicle or not. So for the legal age for driving vehicles is 18 years. So let's check whether a person is eligible to drive the vehicle or not, or else uh, put an vote or not, whether he's an eligible voter or not. We can do that. So let's start by writing the input statements. So first we ask the name, enter the name. He's going to enter the name. You know, name is going to be a string. So string name, I don't know the name. That's why I'm going to leave it blank, and I'm going to take in the name over here. So cn name. And now I'm going to take the age of that person. So let's say cout enter, okay, enter your age over here. Now I'm going to take the age as years. So let us mention that also over here in years, something like that. So I'm going to get the age in years. The number of years is going to be in integers. So I'm just going to take an int age, and then I'm going to get the age also, right? So now I need to check in condition. So what is going to be the condition? I want to tell that the user can drive the vehicle or put the oath only if it's above 18 years of age. So way we do it is you put an if, and then inside this pair of brackets you put the condition. So the condition is if his age is greater than or equal to 18 or not. You are going to check that. And then if his age is greater than 18, then you put the statement, right? Let's say you are eligible to vote or drive a car, something like that, right? He's eligible. If he's greater than or equal to 18, he's eligible. Else, you can just print sorry. Okay, sorry, you are not eligible, something like that. What we have done, we have just taken the name, we have taken the age, we have compared the age, and we are checking whether the age is greater than or equal to 18 or not. So if he is greater than or equal to 18, or if he is a major, you are going to tell that he is eligible to vote or drive a car or any vehicle, or else you are going to say that you are not eligible. So that's how you do that. Let's try and execute this program. So here, let's say enter the name something like John and enter your age 12. So here it says sorry, you're not eligible. Let me put a new line after this else statement so that you don't get confused with the compiler's output. And here, so let's say some other name, let's say Harry, and enter your age. He is going to be 21. So here you can see you are eligible to vote or drive a car, right? So this is a simple program we have written. So here you can also do another check, right? So suppose the person who is using a program is a naughty fellow, he wants to check the validity of your program. Suppose he wants to uh, do something like he wants to put negative integers or something. So age is always positive, right? The way you do that is first you check whether the age is positive or not. So the way you do that is if age is greater than 0, if it is a positive number, then only check it. So all these statements go inside this, right? If his particular age is legal, then only you can check that, right? If he is providing some negative number, you cannot check that. So here I'm just going to indent this thing so that it looks nice. You also try to indent your program so that you can understand what you're writing. So this if is this from this block to this block, this is another if, this is else inside this if block. So all these statements are inside this statement. Or else you say cout please enter a valid age, right? So it is not valid. -5 is not a valid age, right? So you take only positive integers as ages and you're checking whether that age is 18 or not. So if it is equal to or greater than 18, you're saying that you're eligible to vote or drive a car, or else you're telling that you're not eligible. So here now you can execute and try out this program. It is better to execute after every condition you write, right? Because when you're writing a bigger program, it will be a good practice to actually check when you're putting a condition, so that validates your program even more faster and you will be able to easily debug your program. So here let's say enter the name, let's think of some other name, let's say Jack, and enter the age. Let's try something naughty now. Let's type -120 and enter. So here it says please enter a valid age. So you can have many checks like that. So you can have so maybe he's going to enter some weird age like 1,000 years or 2,000 years. You can check that also. The age should be less than 1,000 or less than 2,000, something like that. For that we are going to need another set of operators which I'll be talking in the next video, but you can do that inside this if also. So I can check over here also if age is less than let's say what's the maximum age, 100, right? So let's say 105 or 102, maximum 102. So if it is less than 102, then only you need to execute these statements. So control X and it goes inside this. And let me indent this properly. Right? So if age is less than 102, this, or else you're again going to say the same thing. So just control C and then over here inside this if you're putting is this else. So that is how simple conditional statements are. You're just going to play with conditions. So here I'm checking if it is a positive number, and here I'm checking whether it's too big. If it is too big, I'm telling that please enter a valid age, and if it's too small also, I'm telling that please enter a valid age. And here if it lies between the range of 1 to 101, because 102 is the maximum, right? So I put less than 102 which goes up to 101, and greater than 0 starts from 1. So from 1 to 101 it's going to check, and if that age is greater than or equal to 18, it's going to say that you're eligible to vote, or else it's going to say you are not eligible. So that is how you perform a conditional check. So this statements which are written inside an if. So I have written a if inside if. So this if is the main if. Inside this I have written this, and inside this I have written this if else statement. So this concept is actually known as let me write somewhere over here. Okay, on the top I'll write. This is known as nested if. So nested conditional statements. So this is what this is called as. Now, if I enter a bigger value than 101, let's say 105 or 200, so that will say you're not entering a valid age. And even if I enter some negative numbers also, it's going to tell that you're not entering a valid age. So that is how you play with conditional statements. You try writing a program which will segregate whether a number is odd or even or not. I know this is a very simple program, you'll find it in the internet, but just try it on your own. So let me give you a hint. An even number when divided by 2 gives remainder 0. And that's it. You don't need another condition. So this is the only condition you're going to give. You're going to take a number and then you're going to determine whether it's an even number or an odd number. And this is the hint. So if an even number is divided by 2, it will give a remainder as 0. And then if it is an odd number, it's going to be some other remainder. Remainder is going to be 1. So you can try that. You can try writing that program. In this video, we will be talking about logical operators. In the previous video, we wrote a program to validate the age the user enters, right? So we are giving a condition like if it's check whether it's a positive number or not, and if it's a positive number, we were again checking whether it's too great or not. If it was too great, we were telling something like your age is not valid. And if it was okay, if it was in the range, then we were checking whether he's 18 years or younger. We were considering that the age was valid, or else we were telling that it was a not valid age, right? Here, if you observe, this condition and this condition go together. So if a number is positive and if a number is too great, then it's not a valid number. Or if you look at the larger scope, here you can combine these three statements. If a number is positive and it's too great, or if a number is negative, then it's not valid age, or else it's going to be valid. So the way you group these conditions are by using logical operators. These are just like the connecting words are used in the English statement. So here, if I talk about the condition when the age is not going to be valid, let me write it down here. A number is a valid age or a number is not a valid age if it is positive and if it is too great or the number is negative. So this was the condition, right? So if a number is positive and too great, so these two conditions go together, or the number is negative, then the age is not valid. So this was the condition. If you write it down in this manner, it is much easier to write it down than these group of nested if and else statements. So the way to achieve these things, to validate these conditions and to join the result of these two conditions, these results are joined, right? You need to check whether the number is positive and whether it's too great, and you need to combine these two results and you are going to get a result. Also, you are going to check whether the number is negative or not. What if it's not positive? You need to check whether it's negative or not, and then you are going to check these two conditions. If one of them is true, then you're going to say it is not valid. So this is basically the function of logical operators. So there are three logical operators in C++ or in any language. These are same as the logical gates in physics. You might have come across it. So these are and, you have an or and a not. So not symbol you might have guessed it. While I was talking about the relational operators, I was talking about this operator, right? So this one stands for not equal to. So this exclamation stands for the not. So this is not, and for or you are going to put two vertical bars which you will see on top of the enter key. And here for and you have two ampersands. The very important point to note here is that you need to use two ampersand symbols for and two vertical bars for or, because a single version also exists. So in C++, there is also an operator which is this one, which is a single and a single or. So these are actually bitwise operators. We need not dig deep into these operators because they deal with the binary representation of the data. but just for your information, I'm telling these things. We will talk about that in a later video. For now, we don't need these bitwise operators or bit manipulators. We are only going to need the logical operators, which are just going to tell the relation between two conditions. So AND is basically if two or any number of condition, if all are true, then the result is true. So AND is basically if all the conditions are true, then it's going to be true. And for OR, you have if any one of the condition is true, right? If any one of the condition is true, then the result is going to be true. That is the specialty of OR. So if you have n number of conditions, even if one condition validates to true, then the result is going to be true. And for AND, if n number of conditions are there, all n number of conditions should be satisfied, then only you are going to get the true value, or else you're going to get false. So this is the basically the and OR operator. Not is just it's going to turn the value. So not is it is going to change true to false and vice versa. So the function of not is just to change true to false and false to true, or checks n number of conditions, and if any one of the condition is true, then the result is true. And for AND, it is going to check all n number of conditions, and if any one of them is false, then the result is false. Every condition should be true, then only AND is going to give you a true. So that is basically the logical operators. So here another thing is that if you're writing a logical operator, let's say some condition 1 and condition 2, that's how you represent AND. For OR, it is the same thing. If condition 1 or condition 2, and not basically doesn't need two conditions, just going to reverse the condition. So first you put an exclamation mark and you put the condition. So here if you're using an AND operator, if this condition evaluates to true, this first condition, then only it's going to check the second condition. So even if the second condition is true, if the first condition is false, it is not going to check the second condition at all. It's not going to perform anything over here. So the thing with OR is it is going to check every condition, and here if this one is true, it is not going to check other conditions. So the condition for OR is that if any one of them is true, right? So if it finds any one of the condition is true, then it's going to evaluate it as true, and this whole condition becomes a true condition. So this part is going to be executed. That is with the OR. So those are the logical operators. Let's take a quick example. We are going to deal with the same example we took yesterday. So here I'm directly going to take the age. So enter your age, and I'm going to take that inside a variable. So int age, c in age, and here I'm going to validate the age. So if age is greater than 0 and age is greater than 102, right? So this was the condition we gave yesterday, or 101, something like that. So let's take with 102 now. And if this condition, if this age is greater than 0 and the age is greater than 102, so this condition is basically not required, because if it is greater than 0, then only it's going to be greater than 102, right? So I'm just going to take out this particular condition. So if the age is greater than 102, or if the age is less than 0, right? So if an age is greater than 100, something like 101, 102, something like that, or if the age is less than 0, what we are going to say? You have not entered a valid age, right? And or else we are just going to perform the check. So if age is greater than or equal to 18, we're just let me tell you over here, I forgot. Yesterday we were talking about the block, right? So here if you have only one statement to execute, then you need not use a block. So here I have only one statement to execute. This is going to be the same thing as this one. Here, if I put a block inside this and then put a cout statement, it's going to be the same thing, but block is generally used to hold two or more statements. If I'm going to use only one statement, I don't need a block, so I can just directly put the statement beside the if condition itself. So this is also valid, but if you write any other statement over here, so let's say statement 2, if I write something over here, this is actually not considered a part of this if statement unless and until I have a block, something like this. So here inside this block, whatever I write inside this block, all these statements belong to this else statement. But here, since I have not put a block over here, this particular statement goes to the if. This statement stays to the else part only unless and until I specify another block and mention these two things over here. So if I put these two things over here, now these two have become a part of this if statement, and this whole if statement becomes a part of the else statement. And here I have put only one statement, that is why I don't need a block. And here, if an age is greater than or equal to 18, I am going to say that you are eligible. So whatever, eligible to vote, something like that. Or else we are going to say sorry, you are not eligible, something like that. So this is the program we have written. This is going to do the same thing which we had done in the previous video, but see how small the program now looks. So if you consider taking out these braces, then it's going to look much smaller because you have only one statement execute inside the if block. But because many people tend to forget putting these braces for multiple statements also, it is always advisable to put the braces for even one condition. But generally I don't do that. I just, if there is only one condition, I put it beside the condition itself. Sorry, one statement execute, I put it beside the condition itself. It's up to you, either way it's going to work. So here now let us execute it. We are going to get the same output. So here it's going to ask for the age, so enter your age, let's say 12. So here it says sorry, you are not eligible, and that's it. We have created the same program, but here it's a much smaller program than the previous program. In this video, we will be talking about switch case statements. So before talking about the switch case statement, I would like to talk about the if else ladder. So that is nothing but a simple implementation of the if else ladder itself. So let me give you an example. Suppose you have, let me comment it down here. You have a question like in the MCQ kind of thing. So you have a question and you have 4 options like this, and you have a choice. So I just say your choice, and here the user can enter whatever number he wants, and you can check whether his answer is correct or not. So you just check whether the choice is 1, or else you again go for another check. You check whether the choice is 2 or not, right? And if it is not 2, you go and check for another set of conditions. So if choice is equal to 3, you have something to do, or else again you check whether his choice is 4 or not. So if choice equal to 4, and if none of these are true, then you say that it is an invalid option. So you do something like this, right? So this is the kind of implementation where you are not using the if else ladder. So here you are using the if else ladder. So how do I make it as an if else ladder? So what is else if? Basically it is the same implementation, just that it is using a rule that the else statement always goes with the innermost if. So let me write it down here. It's a very important rule. So the rule is always the else statement goes with the innermost if. So this is a rule you need to remember. Always, this is always true that the else statement goes with the innermost if. So if you write a program like if, and then you have an else for that, and you have an if, you have another if, and you have an else. So the hierarchy of this particular program is there is an if condition, and for that you have an else condition. So these three statements belong to this else condition. So let me write it down neatly. So if you have an if condition like this, and suppose this fails, the else is there, right? So inside this else actually, so even if you write something like if and else, so what is going to happen is these three statements go with this else statement, and this else, if and this else are what are the actual if and else, the actual contrary part, that is this one. So if choice equal to 1, or else you are going to perform any of these operations, right? Or else you are not even going to look at them. If choice equal to 1, you won't consider these options. So here again, so here if you observe there are two ifs, right? So this if is evaluated. So this else always will go with the innermost if. So what is the innermost if? This if, right? So here if I have a condition 1 and here if I have condition 2, condition 1 is evaluated and condition 2 is also evaluated, and only if the condition 2 fails. So if this fails, then this else is activated, right? So this else always goes with this particular if, not the condition 2 one, but always with the innermost if. So this is a rule that is what is used while using the if else ladder. The thing you do is you don't actually put the braces, but you just put a word like else if. So that has the same meaning. Instead of these braces, you are just minimizing it. So it increases the readability. So here if I put else if, and here also the same thing. So this if I just remove this and this else goes here, and you have final else. So you see, I did not add any word, just that the same program, the same braces, I just removed the braces. So now the program is much more readable, right? So if choice equal to 1, or else if choice equal to 2, or else if choice equal to 3, or else if choice equal to 4, or else if none of these are true, it's an invalid option. That is the use of else if statement. So now let us talk about the switch case statement. So switch case statements are not always used for all kinds of comparison. They are actually a kind of alternative for the conditional statements, but they are always not used. Switch cases are used only when we need to compare the equality of two operands. So let me write it down here. Switch cases. Okay, sorry. Switch cases only compare equality. So you cannot compare whether something is greater than or less than equal to or something like that. You can just compare whether they are equal to or not equal to. So the way you define switch case statement is for the same thing I'm going to do. So let us write a complete program. We'll understand like that. So let me put this here. So let us ask by asking something. So see out. Let's just say enter your choice for now. You can add any kind of input for of your choice. So I'm just saying enter your choice, and I'm going to enter put my choices one down the other. So I'll start with number one, and again another one. So let's say 2, and you have 3, and you have 4, and you have a new line, and here I'll just put enter your choice. So let me give another new line so that we can differentiate between our choice and the question. So now our choice is going to be an int. So in choice and C in choice. So we got our choice. Now in the previous case, how we did that, we just checked whether the choice is 1 or 2 or 3. You can do that actually, if, else if, else if, else if, and else. So suppose there are 10 conditions, you have 9 else ifs and 1 if, and then you have an else part where it is none of the choices. So that's how it works. In case of switch case, it becomes much more easier. So the way you do that is, you just switch, sorry, the spelling was wrong, switch, you put your variable in there. So what is our variable? It's choice, right? So switch choice, you have a brace, and here you are just going to define your cases. So you have a case, and then this is just like comparing choice equal to some number. So I just say case 1, and then you need to do something. So let's just print you chose one, something like that. And then the most important thing in switch case is that you need to do something called break. So we'll talk about this keyword. This break is a keyword. We'll talk about that in the next video. But for now, you just remember after every case, after performing every statement for a case, you need to break out of that case. So I generally do that without the braces, but you can even put a brace over here. So this is also correct, but I generally don't use a brace. It's okay if even if you don't. So this is the same thing we are going to do for every case. So case 1, case 2, case 3, case 4. That's all right. So we have only 4 choices. And then let me first do that. Afterwards we'll look at the other condition. So you chose 2, you chose 3, you chose 4. Now let's suppose he did not choose any one of them. So what is going to happen is you are going to use something called the default case. So the way you do that is you put a default and then you just print the invalid, whatever the exception you wanted to print. So invalid choice, something like that. So that is how you use switch case. It is very easy to read, and this is mostly used in case of such menu based programs. So you have menus or you want to choose something or something like that. So generally we use switch cases because they are much easier to implement than the if else. So you need to write if else again and again and again. So this one is much more easier than writing the if else ladder. So you can even compare strings, you can compare characters. So characters are nothing but integers, and you can compare Boolean values also. You cannot compare something relational, right? So you cannot compare whether it's in some range or not. If you want to compare that, you need to go with the if else statement, or else switch case is going to work for you. So let us quickly execute this program. So F9. So here it's asking enter your choice. Let me just put 2 and enter. So here it says you chose 2. So let us now look at what will happen if I just remove this break. So let me just remove these 3 breaks. Right now, once I try to execute it, just see what happens. Now it's again asking for my choice. Now if I enter something like let's say 1, what it should print? It should print you choose 1, right? It was working in the previous time. So now if I just put enter, it says you chose 1, you chose 2, you chose 3, you chose 4. Why did that happen? Because of the break statement. So now if I don't have the break statement, what is going to happen is it is going to evaluate from this order only. It is going to from top to bottom. So now if first it checks the first case, and then if this fails it goes to the second one, if this fails it goes to the third one, and whenever it finds a match it is just going to drop down just like that. So the break prevents the drop down. If you don't have a break, it's going to print everything in that order. So if I just remove this break also, and suppose I try to execute this again, so now here if I put some case like let's say some arbitrary number, so 3. So here if I press 3, now observe that there's no break, right? So it is going to go from 3, 4 and invalid choice. There's no break in between. So it's just going to drop down to the whole switch statements. So just press enter, it's going to say you chose 3, you chose 4 and then invalid choice. So that is why you need to put the break statement. So that's all for the switch case. In this video, we'll be looking at loops. So what are loops? Let's take an example. So here I have a sample program. This does nothing but just take name and age of a person and then prints it onto the console. So what if I ask you to take the data of 10 people? So what you will do is you either execute it 10 times or you just copy the whole thing and then paste it 10 times and just change the name like name 1, name 2, name 3 and so on. So that those are two ways. So what happens when the user decides how many number of times you need to ask him? So what if in the runtime I'm the user and I tell you that I want to store the data of let's say 100 people and you just wrote the program for 10 people. So at that time your program fails, right? So to counter such type of situations and to counter such redundant code, so you are not doing anything practically useful, right? You're just copying and pasting the whole code again and again. So to counter those type of limitations, we have something called loops. So today we are going to look at for loops. So for loops work like a counter based loop. So you have a counter, you have a starting value, and then you have an ending value. So the loop goes from the starting value to the ending value. That's how for loop works. So the syntax is you write for, and then you have a starting value of a counter, and then you put a semicolon, and in between you put a condition. So this condition is actually the loop condition. So what happens is the counter is actually checked with a condition before going ahead. So for every time the counter value is checked, is compared with some value so that it stays true. So this condition should stay true for the whole loop to execute. If it fails, the loop is going to break, and then the control goes over to the next statement which is out of the loop. So for the loop to execute, this condition needs to be true, and the way you grow this starting condition, you cannot stay over there, right? So if you just put the starting condition in the loop, this is also a for loop only, but what happens is there is no growth condition, right? So the starting value stays the same, and this condition also is always true, so this loop will be going on forever. So that type of loop is called an infinite loop. So the easiest way to create an infinite loop is you just put two semicolons, this becomes an infinite loop. So because there is no starting value, there is no condition, so this becomes an infinite. What you do is you just define some value over here, so this makes it as an infinite loop. So infinite loops are bad. You don't want your program to keep executing the same set of statements again and again and again. The user gets bored, right? So you want to end it after a certain number of times. So what you do is you put a counter, and then you put a condition, and you put an increment value. So you increment the counter, or you basically increase the value of the counter so that at some point this condition becomes false and the loop breaks. So that's what you're going to do. So let me write a small for loop over here. So what you're going to do is for, and then for the counter variable, I'm going to initialize it inside this. So there is something called a scope. So what happens is I can even do like this also. I can put an I over here, and I put I equal to 0, something like that. That also works. But what happens is this particular I will be used in the whole program. I mean, in the whole scope of the main. So we'll talk about scope in a separate video. For now, it is best to use counters inside the loops itself, because once the loop ends, the counter gets out of the scope and it is deleted automatically from the memory. So it's best to use counters as a local variable. We'll talk about what are local variables, global variables when we're talking about scope. We'll definitely do that in another video. So for now, we are just going to write for I equal to 0. So that is the starting value, and I want to execute it 10 times, right? So for 10 times I'm going to check. So let me start from 1, that becomes easier. So many times you will be starting your counter from 0. There's a reason for that, that we will understand when we are dealing with arrays or something. Generally computer counting starts from 0. So for now we'll start from 1, and then suppose we want to go till 10. So when will the condition fail? When we go for a number, we are growing this number, right? So let me not write a condition right now. I'll just put the growth rate. So I equal to 1, so I'll just do an I plus plus. I talked about this increment operator, right? So what this does is it just increments the value of I from by 1 unit. So if it is 1, it becomes 2, and then it becomes 3, and so on. So now this I will go on incrementing. It will go till the range of the integer, that is some 2 power 32, something like that. And then it again cycles back. It again goes to minus 2 power something. So this loop won't end at all because there's no ending condition for this. So to end this loop, I want to execute it 10 times. So that condition will fail only if I becomes greater than 10. So till the value of I is less than or equal to 10, execute this loop. Once it is greater, just break out of it. So here you put a brace. So these braces, as I told you, signify a block of commands. So this block represents the for block. Inside this, whatever you write is going to be executed these many number of times. It depends on this condition, in this set of conditions. So here, instead of writing all this, I'm just going to put the number itself. So let's just put an I over there, because we don't want the whole set of statements getting confused us. So let's just put I over here, and then I'll just put a new line. So end L and a semicolon. So let's now execute this F9. So here, if you see, you have all the numbers from 1 to 10. So that is because of this. So what if I put less than 10? Less than 10 is when it goes to 10, it's going to break, right? So now you know the output, it's going to come till 9. So F9. So here you have numbers from 1 to 9. What happens if I remove this condition? As I told you, you will be going into an infinite loop. So what it feels like, it feels like something like this. So you can see it's just going on increasing. It went to 4,000, 5,000, 6,000. It won't stop. It's just going on, just printing the numbers. Just because I don't have a stopping condition, it doesn't know where to stop. It's just going on, going on. It goes up to that whatever that value is. It's 2 into 10 power 9 or something, and then it's eventually going to cycle back, and this process will continue. It's never going to stop. So to stop such a loop, you can either directly close this or press Ctrl C. It's going to stop. So this is how you use for loop in C++. There are other type of usages as well. So instead of putting the counter here, as I told you, you can put it over here. So if int I equal to 0, and then here I'll just put a semicolon, and then I'll just put the condition over here, and then I plus plus. So what this will do is, it is automatically understood that I'm using I as my counter, and once it goes up to 10, it's going to stop. So it's just going to give me the same output. It's going to give me 1 to 10. And what if you cannot remove this condition, because once you remove this condition, the loop is going to be infinite. And another thing you can do is, you can put this thing inside here. So this also does the same thing. Only thing is that this statement becomes the statement of the loop. These statements are executed in an order. So what happens is, first this statement is executed. Let me number them down. So first this statement is executed, then this statement is executed. So all these statements, whatever is inside the block, then this statement is executed. Let me number it as 3, and then it is checked over here. So this check is performed at the last. So once if it is true, it is going to again go there, and again this condition, this statement will execute, then this check will happen, and then again if it is true, this loop will continue. That's how it goes. Another thing you can do is, you can actually omit the condition also. There is a way to actually stop the loop without the condition also. What you do is, you just put 2 blank semicolons, and then to stop, I will write if that particular I is greater than or equal to 10. So, or sorry, greater than 10, because once it is greater than 10, I mean once the I goes to the value of 11, the loop should stop, right? So what you do is, you just break. Remember this break we use in switch case statements? That's the same break. This is actually a jump statement. So this is how it is used for breaking out of an infinite loop, for breaking out of a loop at a particular point of time. So we will be talking about these jump statements in our next video. So this is how break works. You also have continue, so that we will be talking about in the next video. And now I'll just increment the value. So here this is the same exact loop. So if you just execute it, you will be getting the output. So here you have 1 to 10 numbers. So here see, because I have 0 over here, if I just change it to 1, here you have numbers from 1 to 11. Now why did this happen? That's because I checked after printing this. So that's a logical mistake. That's not the fault of the loop. I just forgot to put it before printing it. So once it goes to the value of 11, it should break, right? So if it is less than if it is less than or equal to 10, then only I should print. So first I need to check if it is not greater than 10. If it is less than or equal to 10, then only I need to print. So this loop will execute as expected. In this video, we'll be looking at while loops, And also we'll be learning how to work on patterns. So by patterns, I mean we'll be printing some text in some fancy way, like we'll be making shapes like squares or rectangles. So we will be taking those shapes from the internet and we will try to replicate the same onto our console. So first, let's look at while loops. In the previous video, we saw for loops, right? So the only difference between for loop and while loop is the condition. So in while loop, the condition is must. In for loop, if you skip the condition, it goes as an infinite loop. But in while loop, you cannot skip the condition. The way you write a while loop is you put while and inside a pair of parentheses, you define the condition. And then you have a body where the body is defined by the two curly braces, and inside the body whatever statements you write belong to the while loop. Again, if you want to execute only one condition, you can skip these braces and you can directly write the statement beside this loop. So now, how do we make an infinite loop if the condition is must? Either you can put a condition which always stays true, so something like 1 equal to 1. So this condition will always stay true and this will become an infinite loop, or you can either use the boolean true, that is true, the word true, or you can use directly integers also. So this is possible only in languages like C, C++, Python and all. So in Java, integers and booleans are separate, so you need to be sure whether the particular programming language supports integers as booleans. So in C++, integers are supported as booleans. So 0 is considered to be boolean false and any other number except 0 is true. So you can pick any number from the integer range, but generally people tend to use 1 as true because 0 and 1 make the binary numbers. So generally people use 1 as true since 0 is false, but you can basically use any number except 0 for making it as true. So let me give you an example over here. So let me put some number, so minus 120, which is not 0, and if I try to print some message like welcome to programming knowledge, and let me put an end line after that statement. So now if I try to execute it, if I print F9, so here you see it's going as an infinite loop. So you can put any number over here, but if I put 0 and try to execute it, you will see that nothing happened because 0 is false, so this whole loop is not executed. So to make it execute a finite number of times, what you do is you put a value over here, something like int, let's say steps equal to 10, or you can start the steps from 1. You can go either way. You can go from bottom to up or from top to bottom. You can do it either way. And inside the condition, let us print it 10 times. So while step is less than or equal to 10, that is while this particular value stays less than or equal to 10, that is I want it to print 10 times, and then I'll increase the value of steps every time. So steps plus plus, or you can either do steps equal to steps plus 1. So both are same, you are going to do either of them. So now this will increase the value of the steps one by one, so I'll be getting this message 10 times. So here you can see the message has been printed 10 times. You can do this the either other way also. So that is basically a common approach used by competitive programmers. So in competitive programming, the number of test cases are defined. So they will tell the number of test cases, like they will be telling that I'll be asking 10 queries and your program needs to answer those 10 queries. Generally people tend to use that. So let's say this is the 10 queries. So what I will do is I'll just write step minus minus. So here this operation is getting performed right over here, and since this is an integer which is not 0, it is going to be considered as true. So this a shortcut kind of thing. So this will also make the loop run 10 times. So generally while loops are used at places where you don't know how many times the loop needs to be executed. So generally people use this kind of statements to run the loop till the condition stays true. Or you can do it with a for loop also. You put an infinite loop and then break out of the loop when time comes. So either way you can do it. So that's all for while loops. Let's now talk about the patterns. So let me go into my browser and search for some patterns. Let's say C programming patterns. Let's go to images. Let's pick up some simple ones first. So here you have this half pyramid. So the way it goes is 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So first let us replace these numbers with just stars. So first we'll be making this particular triangle with all stars over there. So you have 1 star, 2 stars, 3 stars, 4 stars, 5 stars, and this will continue up to how many ever rows the user wants. So this is the first row, second row, third row, fourth row, fifth row. So now let us try to code this one. So let me just put what we are going to do here. So we don't need this. Let me put a multi-line comment, and we'll be printing something like this. We'll have 1 and then 2 stars, 3 stars, 4 stars, and then 5 stars. So first we'll try to print this, and then the user can decide how many stars he wants to print. So now if you consider this one, what we will be doing is first we will be talking about this one. So here if you observe, we are going for first row, we are going to print only 1 star. For the second row we are going to print 2 stars. For the third row 3 stars, and so on. So here the way you identify the row and the column, you need to identify a relation between the row and the column. So here the relation between the rows and the columns is, so columns is basically the number of stars. The relation is that the number of stars in every row is equal to the row number itself. So the way you do that is we will be using nested loops. So nested loops are nothing but a loop inside loop. So let me show you as an example. So here let's first take the number of rows. So let me call the variable as row itself. So int row equal to, let's say 1, and then row is less than or equal to 5. Let's first make it for 5 rows, and then we will extend it for n rows. Row is less than or equal to 5, and then row plus plus. So now you know that this particular loop is going to run n times. So whatever is there inside this block, it's going to run for n times. So now what I'm going to do is I'm going to run another loop inside this loop. So now I have the loop, right? So now I will be printing 1 line, 2 line, 3 lines. So just consider this as every separate line. So now I need to determine how many stars I want to print. So those number of stars are going to depend on the row number, right? So I'll give another loop. So for int, let's say stars equal to, let's start from 1, and then the number of stars is going to be the row number, right? So stars is less than or equal to row, right? So if we are in the third row, we are going to print 1, 2, and 3, right? So less than or equal to row, and then you are going to give stars plus plus or stars equal to stars plus 1, whatever is convenient for you. Then what we are going to do is inside this particular loop, we are going to print the stars, right? So see out, we need to print the star, and yeah, we don't need the space or any new line, right? So the number of stars will be printed one beside the other. So what this will happen, when the first row is 1, we will start from 1, and then we will check the condition 1 is less than or equal to 1, that is true. So it will print 1 star. Again this will get activated, so 1 will become 2 now, and this condition will be checked. So 2 is not less than or equal to 1, so because the row is 1, so this particular loop will break, and then it will go to the next row. So before going to the next row, let us just print an end line so that we get to the next line. So now what is happening, when this particular first iteration is finished, it will just go to the next line, and then the row will become 2 because of this condition. So 2 is less than or equal to 5, that condition is checked. And then here it will start from 1. So 1 is less than or equal to 2, 1 star is printed. Again it will go, so 2 is less than or equal to 2, so again another star is printed. And then this condition will make it 3. So 3 is not less than or equal to 2. So this particular loop is broken, and it will go to the next line. So if you just execute it, you will be getting your output. So here you have 1 star, 2 stars, 3 stars, 4 stars, 5 stars. For n stars, you are just going to ask the user. So that's pretty simple, right? So you can just ask enter how many rows you want, something like that. So the user will enter. So int let's say number of rows, and then c in number of rows. So here I have the number of rows. So here what will happen for row 1, to row file. Now I'll just print number of rows. Now let's execute this program. It's asking how many rows you want. I want 10 rows. So if I just print it, so here I have row 10 where there are 10 stars. So this is what is a basic pattern thing. Now we'll extend the pattern. We'll extend the difficulty. So let us try to print this one. So what is happening over here? You're getting 1, 1, 2, 1, 2, 3, something like that, right? So why is that happening? That is because of this particular loop, right? As I told you, the number of stars which are getting printed in each row is because of this inner for loop. So outer for loop just manages the rows. So this particular rows, which is 1, 2, 3, 4, 5, these rows are managed by the outer for loop, and then the content inside each row, like this 1, 2, and 3. So these contents are printed by the inner for loop. So for printing these things, what we need to do here, we just need to print, instead of star, we just have to print stars over here, because stars is directly an integer, so we're directly printing the integers. We don't have to do anything. So first the stars is 1, so it will print 1, then it will print 2, it will print 3. Let's look at that. I want 5 rows. So here you have the outputs, right? So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. That's just the number of iterations we're just printing. That is why it came like that. So let me close this. So let's try the second one now. So it is going from 5 to 1. It is just a reverse of it. So what we need to do is we need to go from 5 to 1. So what we are going to do, we are going to start the row at 5, right? So let's start it at 5, or let's make it generic. Let's just print number of rows over here, and row is greater than or equal to 1. That is, I'm going from 5 to 1. Well, the first loop doesn't make any difference, because from 1 to 5 or 5 to 1, there are only 5 iterations. So these are, as I told you, for number of rows. So inside the rows, you need to manage the content, right? So because of this statement I wrote, because if it was something like 5, 4, 3, 2, 1, the inner loop should start from the highest number, right? So since it is 1, 2, 3, 4, 5, I'm starting from 1. So if it was 5, 4, 3, 2, 1, this particular loop would have started from 5, because it just the value which is getting printed over here only depends on this particular inner for loop. So here this remains the same, and now if I just try to execute it, I'm getting an error. What is that? Okay, it is not star, it is stars, and F9. So enter how many rows you want. I want 5 rows. So here you have that output. You have 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. So this is how you print basic patterns. Let's take one difficult one. Let's say this one, right? So this one is, you can try out this one. This is nothing but just printing spaces till the next number. So suppose this is a second row, so you have no space over here, and then you got the third row, so there are 2 spaces, and then fourth row, so you have 3 spaces, and the fifth row you don't have anything. For the last row, you are just going to print all the numbers as it is. So you can try this one, and this one is a similar one as this one. So we'll be talking about this one. So here what is happening is there is a space actually. So what you do is, for any kind of pattern, you're just going to divide it into a matrix kind of a thing. So if you just put a matrix, or what I mean is you can divide these things into rows and columns. So if you just put rows and columns, you will be seeing that just first row, there are let's say 1, 2, 3, 4 spaces, right? So after 4 spaces, the number is getting printed. That is, if there are 5 rows, so there are 1, 2, 3, 4, 5 rows, right? So if there are 5 rows, what is happening is, after 5 rows, for every 5 rows, there are n minus 1 spaces before the first element, right? So if n is 5, you have 4 spaces before the first element, and then the number of spaces are decreasing. So n minus 2 spaces, that is 3 spaces for the second element, 2 spaces for the first element, 1 space for the fourth element, and then 0 spaces for the fifth element. So fifth element is directly starting from the edge. So let's first manage the spaces. So here we won't be requiring this. So okay, we need the 2 loops, but this particular logic will change. So what will happen is, let's first deal with the spaces. So let me name it as spaces. So now when I have the first row, my spaces should be 4, right? So I need to start from the highest number. That is, I need to start from the number of rows, and this row number, it could be either way. So I would prefer going from the least to the highest. So less than number of rows, and then row plus plus. So for the spaces, what we are going to do is, let me clear this down here. For the first row, we have 4 spaces. That is for taking n as 5. That is number of rows as 5. We are going to take 5 rows as an example. So we will be printing the same thing, and then you can extend it. So what is going to happen is, for number of rows, you are going to give number of rows minus 1 spaces. So if it is 5 rows, you are going to give 4 spaces for the first element. If it was 7 rows, you would have given 6 spaces for the first element, something like that. So now let us print this thing. What we are going to do is, for number of rows, so we need to run a loop from 1 to number of rows minus 1. So here for int spaces equal to 1, and then spaces is less than or equal to number of rows minus 1, and then spaces plus plus, and then since I have only one statement, I'm just going to write it over here. I'll just print a space without a new line, because once it's a new line, it's going to go to the next line. We don't want that to happen. We are just dealing with the values right now. And then after printing this, what do we need to print as the number? So here we are just starting with the row number, and then we are going till the so we are going till this middle value, right? So we are just going like 1, 2, 3, and then 3, 4, 5, and then 4, 5, 6, 7. Basically what is happening is the first and last values are similar, and then this middle value is just the progression of this. So for every row, this particular value, that is the maximum value these elements go up to and then decrease, will depend on the row number. So here if you see, for the first row, I'm not going any further. For the second row, I'm just going one number further. For the third row, I'm going 2 numbers further. For the fourth row, I'm going 3 numbers further. For the fifth row, I'm going 4 numbers. So 5 plus 4, 9, 4 plus 3 is 7, 3 plus 2 is 5, 2 plus 1 is 3, and then 1 plus 0 is 1. That's why I'm staying here. So for that, we again need a loop. So for, let's call it something else now. Let's say the number, right? So for int number equal to, let's start from the row number, because it's starting from the row number, right? So first row is starting from 1, second row is starting from 2, something like that. So for row number equal to the row number, and where should it go? It should go till row minus 1, right? So number is less than or equal to row minus 1, and then again number plus plus. And then here, since I have only one statement, I'm not using that curly braces. So see out what number, right? So till where did we do? We did till here, right? So we did not print these statements. So we did not print any of these statements. We just printed this particular triangle in this fashion. So we just have a space and then 1, then space and then 2 numbers, space, then 3 numbers, something like that. So now to deal with these numbers, we need to print these numbers also, right? We cannot just omit this. So we need to start from this particular number and go till there. So how do we know what is this number? We do know that, right? We know that it is row minus 1. So if it is, it is row plus row minus 1. What I'm saying is, this particular highest number till where it gets to is row plus row minus 1. So this particular equation, you can get that, right? It's just from observation that let's take this row. This is the 4th row. So that is row equal to 4. 4 plus 4 minus 1, that is 3. So 4 plus 3, that is 7. So this is the highest number we will get. So from there, we need to go till the row, right? So for first row, we are not going to go anywhere. So row plus row minus 1 is just 1. So we need to go from 1 to the highest number, 1 to the row number, which is 1. So we don't have to print anything over here. So we are already at 1. So we just break out of the loop. So here what we'll do, we'll be at 3. And then from 3, we need to go to the row number. So from 3, we need to go to 2. So we need to print this particular 2. And then again from 5, we need to go to 3. From 7, we need to go to 4. So we are just subtracting 1, 1 over here. So we'll write that loop. We'll call it back number, something like that. So let's say that second triangle. Let's just call it second triangle. Let's start it from that highest number. What is that highest number? Let's start it from highest number -1, because you don't have to print that highest number again, right? So if we are at 3, you need to start from 2. We are going in this fashion. We don't have to print this 5 again, right? So we have already printed this 13579 already. We just need to print these lines. So how do we do that? We just start from, as I told you, the equation for that, row plus row -1 and -1, right? So this is this. So if you can actually simplify it, it comes as 2 into row -2. So you can write that also, or 2 into row -1, that is also correct. So you can directly write it as 2 into row -1, or I'll leave it just like that so that you understand. So this row into row -1 is actually the highest number we'll get to at every row. So row into row -1, and then the second triangle goes up to that particular row number, right? So greater than or equal to row, and then second triangle minus minus. And since I'm writing only one statement, I don't have to use that loop or that braces. So I'm just going to print that second triangle element, whatever it is. And then I'm going to go to the next line. So these 3 loops inside this particular loop is just makes a complex kind of a loop, but it isn't complex if we just break this down. So let me comment it down here. These are for the spaces, or for the starting spaces, and these are for the starting n numbers, right? For every row there are, if you take the nth row, there are n numbers, right? So here for the first row there are only 1 number, and then for second row you have 2 numbers, third row you have 3 numbers. So I'm talking about this particular triangle. So this let me just call it the n numbers, or n row numbers, something like that. And this will make the last n minus 1 numbers. So here if you see, for the first row you have only one, for the second row you have only 1 element, for the third row you have 2 elements. I'm talking about this particular triangle now. So this should give us the expected output. Let's run and see this. So till where did he go? He went up to 5, right? So he took 5 rows. Let's type with 5 rows. And okay, something is wrong over here. We did not get the output as expected. So what happened? Yeah, so here what happened is I just took row -1, so this particular loop never ran. What I should have taken is I should have taken this particular expression. So that's a mistake I did. So it is not row -1, it is row plus row -1. And then now if you execute it, you will be getting the output. Okay, I did not close this. So 5, and then here you have the output. So it is 1 2 3 2 3 4 5 4 3 5 4 5 6 7 6 5 4. Now the numbers are correct, but if you see, the placement is wrong. That is, we messed up the spaces. So let's see where we messed it up. When the row is 1, it will go from number of rows -1 to 1. So now what is happening is, if the row is 1, only then this condition is satisfied. What about the next row and the next row? So this should be number of rows minus row, and then spaces should be greater than or equal to 1. What I did is, if number of rows is 5 and I'm in the first row, so 5 minus 1 is 4, I'll be going from 4 to 1. And if I go to the next row, that is second row, so 5 minus 2, that is 3, I'll be going from 3 to 1. That makes it 3 spaces. So likewise it will continue. So now we should be getting our expected output. If I just put 5, yes. So here you can see the exact same output we got over here. So this one we made 1 2 3 2 3 4 5 4 3. So there's a space between the numbers. We can do that very easily. What we are going to do is, we are just going to add a space between over here and over here also. Wherever we are printing the numbers, we are just going to add one space over here. And if we execute this 5, so here you are going to get the output as expected. So here you are having the same thing. So 1 2 3 2 3 4 5 4 3. So now this one looks better than this. That is because of the spacing over here. Since I gave spaces over here, I need to give 2 spaces over here for every thing. So what I mean is, since there's a space between the numbers also, so for every row, suppose I'm going for the first row, I should give 2 into those number of spaces. So suppose there are 4 spaces in between, if I give 8 spaces, it would have been better. So let me show that. There's only one slight modification to make it look like that. What we need to do is, instead of number of rows minus row, I am going to just go from 2 into this particular value, number of rows minus row. And now if I execute it, let's say 5. So here you are getting that particular equilateral triangle kind of a thing. So here if you see, so what I meant was, in the last last time when we did not have a space between these numbers, what was happening was, since there are no spaces, it was looking good. But once we have spaces, we are having a space between every number, right? So we need to increase the number of spaces over here also. So I just made it 2 times so that it looks exactly like this. So you can try these ones also. This is just the implementation of this. What is that is, for every row you're just omitting the middle numbers. You're going from the 1 to that particular the highest number of the row, that is the row number, and you're just omitting the in between numbers on this one also. So, and for complex patterns such as this one, so this solid diamond, or you can try this one also, that is this number printing. So 1 1 2 1 2 3 1 2 3 4. So this one is just a implementation of these two triangles. So what it did was, this particular triangle is first printed, so like 1 1 2 3 1 2 3 4, something like that, and then this whole loop is just inverted again. So you need to break the problem down into simpler problems. So here if you see this particular diamond, you can break it down into this particular triangle, that is the upper triangle, and then the lower triangle. If you just see it, you will be able to understand, you will be able to differentiate between those two shapes. So you need to break down the complex shapes into simpler ones, and simpler ones you pretty much can try all these shapes. So these are just implementations, so you can try it just like this. So these are number of so this is how you work with patterns. So again, for a review, this particular first for loop, that is the outer for loop, let me write it down here, or let me write it above. So outer for loop controls number of lines or rows. So the number of lines or rows are controlled by this outer for loop, and the content is always controlled by the inner for loop or loops. It depends. Like in this one, it took 3 loops for controlling the data, but if it was a simpler loop such as the first one, it was only 1 loop. So whatever it is, the inner or loops always control the data, and the outer loop will control the row or the number of lines. So here if you will need to actually kind of form a relation between the row number and the data. So every time there will be a relation. So that is why it's called a pattern. Every time there is a relation between the row and data, you need to identify that particular one, and you need to work upon your logic to form such patterns. In this video, we'll be looking at do while loop and also the jump statements in C++. Let's get started. In the previous video, we looked at for loops and while loops, right? So let me just write down their basic structure. So you have a counter, you have a condition, and then you have a growth rate for the counter, so that this particular condition becomes false at some point of time, right? And for while loop, you define the condition inside a pair of parentheses, and then you have the body of the loop where you define the growth rate of that particular counter, right? So now if you observe, if this particular condition is false at the beginning itself, this whole loop is not going to run, right? So what I'm talking about is, if I declare some variable like int I equal to 0, and in place of this condition, if I give I is less than 0, and this growth can be anything. So let's say I equal to I plus 10, something like that. So now if you see, the starting value of I is 0. So once this condition is checked, it is false. So this whole loop is not going to execute itself. So if I write something like this is the for loop statement. So this whole statement is not going to be executed at all. Let me just add a new line also. So this is the escape sequence of the new line. So now the same will happen with the while loop also. So if I just say int j equal to 0, let me just write down the same set of conditions. So j is less than 0, and the growth will be j equal to j plus 10, right? and let me write on that particular statement. So cout, let me just copy this thing, right? And this one will be the while loop statement. So if I execute this particular program, I won't be getting anything. So now if I just try to execute it, you will be seeing that I have a blank output, right? I don't have anything over here. So what if I want to execute this particular statement, or what is a particular set of statements inside the loop at least once, right? So sometimes you are given a menu and then you are asked to choose something from that, right? So you have something like this, you have choose your option, and then you have first one, second one, third one, and so on. So this will continue, and then you will be given a choice where you can enter your choice. So in programs like this, these are called menu driven programs. And in programs like this, what happens is you need to execute this whole set of operations at least once. If I directly press 3 over here, let's say 3 means exit, right? So you have some functions in 1 and 2, and 3 is exit. So if I press 3, I should exit out of the program. But for that to happen, this whole set of code should execute at least once, right? So in this kind of loops, that doesn't happen. It will directly stop when this particular condition is false. So in the beginning itself, if the condition is false, it is going to break out of the loop. So in such kind of situations, what we are going to do is we are going to use the do while loop. Well, you can do that with these loops also by using the jump statements, but since I have not talked about the jump statements till now, I'll be talking about them shortly. So now we will be using the do while loop. Do while loop is relatively easier to use than jump statements. So what we are going to do is you are going to write do, and inside this you will be defining the body of the loop. So this is actually a loop, right? So here inside you will be defining the loop's body, and then you will write while and then the condition, right? So what happens here is first you check the condition and execute the statements in these loops, right? In this loop, what happens is first you execute the statements and then check for the condition. That is the only difference between these for and while loops and this do while loop. Let us execute this particular same program. So let's take int k equal to 0 and the same condition, which is k is less than 0. And let me just copy down this particular statement inside the loops body, right? And this is the do while loop. Now if I execute this particular program, you will be seeing that this has executed once. This is the do while loop. What happened is before checking for case less than 0, it first executed whatever is there inside this, and then it went for this particular condition check, which it turned out to be false. That's why it broke out of the loop. So in places where you need to execute the loop at least once, in such cases where you have this kind of menu kind of thing, you are going to use the do while loop. It is going to be very useful and very easy to use such. So let us quickly write a small menu driven program. I'll show you what I'm talking about. So this one is going to be a menu driven program for choosing between addition and subtraction. So let's say do, and then inside this I'm going to ask for a choice. So choose 1 for addition and 2 for subtraction, and I'll be getting a number. So int choice, let's call it, and then cint choice, and then now I can switch the choices as I told you. So I can use either switch case or if else. I'll go with if else because I have only 2 numbers to compare. So if choice equal to 1, then what you're going to do is you're going to ask for 2 numbers. So enter number 1, and I'll get a number int n1 cin n1, and the same thing goes for number 2 also, n2 n2, and over here number 2. Well, we can actually put this thing outside because for both addition and subtraction, since we are dealing with only 2 numbers, I'm just going to put these things outside because it really doesn't matter whether the choice is 1 or 2, right? We are anyway going to ask for the 2 numbers. for either for addition or for subtraction. Only thing is which is going to change is our print statement. So I'm just putting it outside the conditions over here. And then if choice equal to 1, what we need to print is we need to print the addition or the sum. So since I have only one statement, I'm going to skip those curly braces, and then the sum is we can directly print the sum, or you can even store it inside one of the variables and then print it. I'm not going to do that. And the same goes for the difference also, right? So if choice equal to 2, then you print the difference. So difference is n1 minus n2, and over here choice equal to 2, and you can use else if over here. So instead of checking, if you put 2 ifs, what will happen is it will first check for this and again check for this. But if you put an else if, what will happen is if this condition is satisfied, it won't check for this one. Or if you have a hierarchy of conditions, so if you have 10 conditions, if the second one is satisfied, it will directly skip to the next iteration. So what happens over here is if you put all ifs for all 10 ifs, even if the second condition is satisfied, it is going to check for all the 10 conditions. So else if is a better choice when you have two distinct choices, right? So now after printing this, what we are going to do is we are going to ask for the user whether he wants to continue or not. So do you want to continue? He's going to reply either yes or no. I'm just going to take one character. So now once you take the character, what will happen is it will be limited to the scope. So if I write something like char, let's say con, and then con stands for continue. I cannot use the word continue because it's a keyword. I'll be talking about that shortly. Let's just say con means continue, right? So now if I just take in con, what will happen is this particular variable will be limited only to this scope, the highlighted braces which you are seeing here. So if you want to compare that, that is not possible, right? Because the while which we are writing is outside this one, right? So while we write outside this body of the loop. So we need this variable to be accessible outside the body of the loop. So we don't want to access it outside everything else, right? We don't want to access this variable outside everything. So what we are going to do is we are just going to put this con over here inside the main function. So what will happen is it will be limited to this main function, but since we are not dealing with other functions, we are just using this particular one as a function variable, that is it belongs to this particular function, and then it can be accessed from anywhere in the function. Since this while also is inside the function, it can access this continue variable now. If you had written it over here, it could not have accessed it. So now we are going to do it until he says no or till he keeps saying yes. Both are equivalent statement. You can do either con is not equal to yes, or you can say, or sorry, con is not equal to no, till then you need to continue, or else you need to continue till he keeps saying yes. So both of them are right. You can do either one of them. And now if I execute this, so he's asking for the choice. I'm going to say 1, enter number 1, 12, 12. So the sum is 24. I want to continue, yes. If I put 2 and then 12, 12, so the difference is 0. And now if I press N, it is going to stop. So now you see how the do while loop can be used. So if you are using the for or while loop, that is also possible, but it's quite clumsy to implement as compared to this particular do while loop. So now let's talk about the jump statements. I clear this, we don't need this. So the first jump statement we are going to look at is continue. So what continue does is it will skip a particular iteration. So let me show you an example. So for int I equal to 1, I is less than or equal to 10, and I plus plus. And inside this loop, I'm going to print something. Let's say, let's just print I, right? And then a new line also. Now you know the output, right? It's just going to print all the numbers from 1 to 10. So now what I need is I don't want the value of 5 to be printed. In the output, I want all the numbers except 5. So one way you can do is you can do something like if I is not equal to 5, then you print all these things. So this is also one of the ways to get the output what I actually said. So here you can see all the numbers are getting printed except 5. But in some scenarios where what we need to do is, instead of writing everything in an if else loop, we can directly skip the statements if that number is not 5, right? Sorry, if the number is 5. What I mean is, if I have some set of statements over here, so let's say we have this one, statement 1, and then I have another statement over here, so statement 2. Let me add a new line over here so that you can differentiate. So after every I, there is going to be a statement 1 and statement 2. But if I want that all to be executed only when I is not equal to 5, what I need to do is I need to put everything inside inside the body of if loop, right? So I need to do something like this and then here. So inside this body of the if loop, I'm going to get all these statements printed only if the number is not 5. The easier way to do is, what we can do is, we can skip those statements, right? So if I is 5, we can skip those statements. So the way you skip the statements is, this stays as it is, but once I equal to 5, what I'm going to do is, I'm just going to hit continue. So what this will do is, if I is equal to 5, it won't care about the next statements. It won't care about any other statements inside. It is just going to skip the iteration and go over to the next one. So this is true with every loop. So even if you have the continue inside the if, and then you have some statement over here. Let's say continue is triggered, something like this. So this statement won't be executed at all. That once the continue is encountered, it is directly going to skip everything and just going to the next iteration. So now if I execute this, you will be getting the same output. Okay, I did not put this. Yeah, now if you see, I have 1, 2, 3, 4, and then 5 did not print anything at all, and then 6, 7, 8, 9, 10, right? So that is the use of continue statement. It's just going to skip the statements once it's not required. So every statement is skipped. So next thing we are going to learn about is break. Break is almost same like continue. What it does is just going to break out. Continue is just going to skip the iteration. It is just break is going to completely skip the loop itself. So once break is encountered, it's just going to come outside the loop. So if I write something like the loop has executed, this is outside the loop, right? So this particular statement is outside the loop, and now if I execute it, you will be seeing that all the statements are printed only up to 5. Once 5 is encoded, it has directly broken out of the loop, and then it says loop has executed. So that is the use of break statements. So you have encountered the break already, right? And switch case. So this is what happens. Once a case is satisfied, you are just going to break out of the whole switch case. If you don't break out, what is going to happen is it's going to follow all the statements which are associated with every switch case below that order. So the next statement we're going to learn is about the go-to statement. So what go-to is, it's basically a connecting kind of a thing. So you have a label. So let's call it label. And then you have a set of statements inside this label. So you have cout, hello, and then cout. So you have these two statements, right? Let me just add a space over here. So these two statements are going to be printed side by side. I don't have a new line over here. So now what will happen is, I want to execute these statements again and again when I press something. So remember the do while loop, we can do the same thing with the go to statement also. It's not exactly a loop, but it can act like a loop. So let's say I have some variable over here. Let's call it int I. So I'm going to take in I, and then if I is equal to, let's say, some number, let's say 12 or 7, something like this. So if I is this particular number, I want the whole thing to be executed again, right? So what I will do is go to this particular label. What this does is, it will directly switch the control from here to directly over here. It will directly go from here to here, or you can go from here to bottom also. It can go from this particular place to any place in the whole program or in the whole function. You can directly skip all the statements. You can either go backwards or even forwards. It completely depends upon your program. But here what will happen is till I press some other number except 7, this whole statements are going to be repeated again and again. So once I press enter, you are saying welcome to programming knowledge. I press 9, enter. So here you see it stopped. Now if I press 7, it's going to continue again and again. So let's say 7, enter. You see the same set of statements have executed 7, 7 till I press 7, it's going to repeat, and then if I press something else, it's going to stop. So that is about the go to statement. And then you have another statement called exit statement. So what exit does is it directly breaks the whole program. Your program is going to end, but it's not a function directly. So you need to have another header file to execute it. So that header file is known as the standard library header file. So it is stdlib, which stands for standard library, but it's a C header file. So it's name in C++ is cstdlib. So you need to type cstdlib. So this is a header file, and inside this you have the exit function. So let's say I want to exit right after this one. So I just press in exit. 1 means exit with an error, and exit 0 means it's just going to exit without any error. So let me show that. If I execute this, you can see it just ended with return 0. That is the exit code which I passed over here. So it went on without any errors. But now if I press 1 and exit, so here you can see process returned 1. That is the exit code. So 1 means some error, right? So here you can see it's terminated with a status 1, that is red color. It means that it terminated abnormally. From this video onwards, we will be looking at functions in C++. So till now we have been using only one function, right? That is this particular main function. Whatever we have been writing inside this function, and then we have been executing it. So from now onwards, we will be understanding how to work with multiple such functions and how they make your program much more efficient and readable. So first things first, what is a function? So if you remember your basic math classes, you have come across something like y equal to sine x or y equal to x cube, x square. So all these things are functions, right? So if you look at the mathematical definition of a function, what it says is it will take in a set of numbers and then it will map every element in that set with exactly one element in the other set. So if that is confusing, what it basically means is it can take n number of things inside this definition. That is, if I'm defining a function as y equal to some f, so inside this I can take as many elements as possible, but the y is going to be only one value. So it can only compute something, it can work on the mathematical operations, and then it will give you exactly one single output for y. So if you look over here, so y equal to sine x, there is a series of sine x, right? So it will be something like 1 minus 1 factorial, something like that. So that computation is done on this particular x, and then that only one value, which is in the range of -1 to 1, right? So -1 to 1 inclusive, that particular value is returned to y. So if you take an x square, it is going to take some number x, and then it is going to do some computation, that is it's going to multiply itself, and then it will return back you y. So this is again only a single number. So again, if you take the equation of a line, let's say y equal to mx plus c, where m is the slope. So here again I can define y in 2 or 3 different ways also. So first way is, let me write it down here. First way is that it is going to take only one input, that is y equal to f of x. So where let's say f of x is going to return mx plus c. And the other way is you can say y equal to f of, let's say, g of m comma x, where it's going to take in the value of m and x, where c is already defined inside the function, and it's going to return you mx plus c, right? The other way is y equal to h of, let's say, m comma x comma c. I'm going to take all the values and I'm just going to compute that. So that is where sorry, over here it is g of x, and h of this particular, sorry, this is m comma x, h of m comma x comma c is going to be mx plus c. So don't worry if it is really mathematical. What I'm trying to say is it can take multiple inputs, but it is going to give you exactly one output. So in this case, it's going to give you exactly one number, right? That is the y coordinate of this particular line. If you're given the x coordinate, it's going to give you the y coordinate, or vice versa. You can define it the other way too. So that is exactly how functions work in programming also. So let me write it down here. In programming, a function can take multiple inputs, but it can give you only one single output. Inputs is basically, it could be 0 as well as n number of inputs. You can either give it something or it can perform independently also. That will depend upon the function you are writing. So enough of the definition of the function. Now let us look at why do we need functions. So here I have a basic program. We don't need this. I'm just going to delete this. And here we have a basic program to add two numbers, right? So what if I say that I want to ask the user for, adding these two numbers, let's say some 10 times. At first you would say you need to copy and paste this thing 10 times. Now, as you are well versed with loops, what you are going to do is you will be putting these things inside the loop. But if you look at this is about, let's say it's a 9-liner code, right? So if you make a loop, the loop's body will contain 9 lines of code. So let's just imagine it's not such a simple program of adding two numbers. It's something more than that. And what if you are going to solve a particular problem which contains, let's say, 100 lines of code? So if you're giving that code to me, I won't understand what you're doing, right? So at a first glance, I won't understand what you're doing, and then I need to spend some time, and then I need to understand everything. I need to understand how you're using the variables and all, and then I will be able to develop on that. And the second thing is you will be writing a lot of redundant code. Let me put this inside a loop and explain you. So let's say I is less than 10 and I plus plus. And this is a loop body, right? So it starts from here and ends over here. So here these things are getting reinitialized again and again and again, highly inefficient, and then this particular computation is going on. So basically this looks clumsy and it decreases the readability, and then it will drastically increase the redundancy of the code. So by using functions, what you will be doing is you will be asking these 10 lines to be executed in a separate kind of environment, where once the job is done, you will return back to this particular environment. So it's not exactly an environment, but it's actually switching your control to some other thing, right? So it's like working in a team. So instead of doing everything by yourself, you will ask your team member to do something else for you, right? So that is how you use functions over here. So let's now talk about how to work with functions, how to define functions in C++. So in this video, we'll be just looking at one definition of a function. In the subsequent videos, we'll be exploring more on these things. So a very basic implementation of function is that it won't take any inputs and then it won't give any outputs, right? So that is a very basic implementation of function. So how you represent number of inputs and number of outputs and how you define a function is in this way. So first thing is you write the return type of the function. So what is a return type? Return type is basically what data it is going to give out after performing the job. So in case it's not giving anything, you have a data type for that also, right? So remember from the data type video, it is void. So if you don't have anything to return, you are just going to mention it as void. And if you have anything to return, you are going to put it as int. So here now, if you have a question why this particular main function is int, if you execute this code, you will be getting some code over there, right? So if you remember, let me just quickly execute this code. If I build and run this, so let's say 12, 12, and then 24. Okay, I'm executing this for 10 times. Let me just remove this particular loop and then this one also. So here if you see it returned with some code, right? That is 0. So that is from this particular main function. So that is why you were first writing return 0. Remember when the code block gave you the template code, it had this return 0 over here. So in case some anomaly happens while execution, it will give different return codes, that is -1 or something like that. So those codes mean that your program did not end correctly. If it successfully reached return 0, it means that your code ran successfully, and then 0 means no errors. So that is why we use this return 0. So even if we omit it from this particular main function, it does not matter, because main is designed to return 0 when it's successfully executed. For our functions, we need to definitely return something if we put some other variable type, I mean the return type except void. So if you write something like int, let's say add or float add or whatever it is, if you write some other data type over here, you need to return a data of that particular type to the function which is calling it, right? So that we'll be looking later. So first we'll understand how to work with functions which takes 0 inputs and then 0 outputs. So let me write it over here. It takes 0 inputs and then 0 inputs and 0 outputs, right? Output, I mean the returns. So it is going to give some output. I'm just going to put everything inside the function. So it is going to give you some output. Output is something on the screen. Return is something where you get back something, right? So like y equal to f of x, you are going to get some value of y, right? So what I'm doing here is I'm just calling f of x. I'm not giving any y to that. So I won't get any value back, but I'll get the job done over here. So here for 0 inputs, I need to put void, because I'm not going to, sorry, for 0 returns, I need to put void because I'm not going to give out anything to the function. And then for inputs, I'm just going to leave it blank, right? So you need to put the parenthesis. This parenthesis is exactly the same thing as your mathematical parenthesis. Inside that goes all the arguments you are going to pass in through, arguments or the inputs you are going to pass through the particular function for which you need a particular output, right? So I'm not going to pass in any input for now. And then the way you define function is you put this block, right? So notice that I'm writing the function outside this main function, because this is a separate function and this becomes another function. So if you can write inside this particular main function also, but that is a bit clumsier, and it has its own problems. So we'll be talking about that at a later stage. So for now, we are going to write all our functions outside the main function, right? So you need to give a meaningful name to the function, right? So I forgot to mention about this. This is the function name. So you need to give some name which says what the function is doing. You can't just give something like, let's say XYZ. So something like that. So you yourself won't understand what you're going to do with that particular function. So you need to give some value name so that you understand what that function is doing, and it has some meaning related to what it's actually doing, right? So now what I'm going to do is I'm going to just cut everything from here and then put it inside this, right? So what it means is if I call add, all this function, all these statements are going to get executed, right? So how do we call that function? We don't have any output, right? So I can't call something like y equal to add, right? Because I'm not giving any return types. I'm just putting it as void. Void means once the job is done, it will come back over here without returning anything. Returning is, it's just going to give you some value, right? So it's not going to do that. It is just going to continue with the flow. So I'm not going to mention anything over here, but just call add and then put a semicolon over here. So notice this is called the definition of the function. So that is, let me write it over here, function definition. And this one is called the function call, right? Let us look at the execution. It's going to do the same exact thing. It is going to ask for 2 numbers and then it's going to return me the output. So now if you look at the main function, it's much more readable, right? You understand that you are actually adding 2 numbers. So if you just look at this particular code, it will be easier for you to understand as well as debug. Let's say you were writing a very big program where a particular part had a mistake, and then instead of tracing the whole program, you could actually trace the only this particular part of the program, right? Suppose let's say I did not write the logic properly. I put minus over here. And once I execute, I will get to know that instead of adding, it is actually subtracting. So I'll come back over here. I'll just change this particular thing, and then the job is done. It is error free, right? So that is why we use functions, and this particular approach is actually called procedural programming. So what we are doing is we are dividing our particular problem into procedures. So procedures are nothing but functions, and then we are actually solving everything on its own, and then we are actually combining everything and then giving out the result. So that is what procedural programming is, and that is how we use functions in C++. So now if I just remove this particular thing and then put it over here, right, after the main function, now what will happen is if I try to execute it, you will be seeing that I have an error. So what is that? It says add was not declared in the scope. What it means is that this particular add, it doesn't know that there is something called add in the particular program, because add is defined by us, right? It is not a property of the compiler. It doesn't know what add is. We actually mentioned that we are going to use something called add, and add means you need to do all these things, right? So to actually tell something like that, you can either define the functions before the main. So that is as I executed right now. Another thing is that you have something called the prototype of a function. So what a prototype is you put the return type of the function and then the function name, and then inside a pair of parentheses the parameters list, whatever you're going to use as the parameters for the particular function, and then you put a semicolon. So it's just like copying this particular thing and then pasting it over here. So one thing is that in case of parameters, you don't have to write the variable names too, but since I've not discussed about the parameters, I will be discussing about them in the next video. So at that time, we will be seeing that in the prototype of a function, we don't have to actually put in the variable names too. We just have to put in the data type. So for now, we are not going to have any inputs, right? So we're just going to put this over here and then put a semicolon over here. So what this does is, it is called the prototype, and it will tell the compiler that, hey, I have a function called add. So whenever you have an add over here, you need to refer to this particular add function. So whenever I have something called add over here, I need to refer back to this particular function, which is actually the body of the add function, the definition of the add function. So whenever add is called, you need to execute all the statements line by line. If I now execute it, I'll be getting an error-free program. So I can write something and then I'll be getting the output. In the previous video, we saw how to create an independent function, right? So this add function right here, this is an independent function. What it means is it is not going to take any inputs and it is not going to return you anything. It just performs the task which it has to do when called. That's it. So in this video, we'll learn how to create dependent functions. Most of the time, we'll be using dependent functions. We will be using these kinds of functions also, but these are very rare. We will mostly use dependent functions. We just pass it some parameters, we ask the function to do something and then get back the value which we intended to. So how to make this particular function dependent? That is, I need to pass in some parameters over here, let's say 2, 3, and then it should only add these two numbers. It should not ask the user to enter two numbers and then only work on those two numbers. I want to work on these two numbers which I passed in as parameters. So how do we get these two numbers inside this function? So the way we do that is we define the parameters. The way we define parameters is we first put the data type of the parameter and then the name, right? So in this case, the data type would be int and then the name of the parameter, let's just say num1, right? And then we have another integer. So if you do like this, like you declare variables, sometimes you do this, right? So int a comma b, Well, this is going to work only if you're declaring variables. Here you're not declaring variables. Here you are specifying the parameters, right? So while specifying the parameters, it is compulsory that every parameter be mentioned along with its data type. So you need to mention the data type of the second parameter also, even though both the parameters belong to the same data type. You cannot omit the data type of the second because it's just a continuation of the variable declaration. Now what we're going to do is we got the two numbers inside this and we don't need any of this, right? I'm just going to take out these things, and then here instead of a plus b, those two numbers are num1 and num2. So you take num1 over here and then num2 over here, and then it is just going to print out the sum. So let us execute this and see. So 2 plus 3 is 5, so we should be getting the sum is 5 as our output. So here you can see the sum is 5, right? So another thing you can do is, if you want to save this particular value, that is if I want to add these two numbers and then keep the result, there is no way to keep the result, right? Well, C contains the result of num1 plus num2, but C is not accessible outside this function, right? Add is one function and then main is another function. Well, if you want to access this particular variable, you need to make it global. That is, you have to put it outside all the functions and then access it. If you remove this, then now C is accessible over here. You could just say C out C over here, and then if you execute it, here you can see it has printed the value of C. But what happens is we don't prefer this kind of global variables. The reason is that whenever the program is getting executed, everything is inside the RAM, that is the random access memory. So once variables are out of scope, they are automatically deleted and then again created whenever the time comes. You need to free up the memory so that other tasks can go on, right? You cannot just keep this particular variable in the memory all the time. So if it is compulsory that you need to keep it, then you can, but if there are other ways to do that without occupying that particular memory, you need not do this because it takes up memory, right? So the way we do that is we return this particular value back to the calling function. So what is return? How do you return something to the calling function? Well, the way you do that is you just need to put the return statement over here. So you just say return C. Now instead of creating a global variable like I did before, you don't have to actually create something and put it in the memory. Once you have executed it, you can just return that particular value over here. So that is the main objective of this add function, right? You need to take in two numbers, add it, and you're going to get one integer. You need to just return it. So if I say something like a equal to, or let's say sum equal to add 2 comma 3, what they expect is these two numbers are added and the sum is coming to this particular variable, that is sum, right? So here if I return it, I'll be getting a problem. So if I now execute it, you will see that I have got a problem. It says okay, C is not, that's because I have written over here. Now let's again run it. So here you can see that it says return statement with a value in a function containing void, right? Returning void. So as I told you before, if you're not returning anything, then only you need to use the void keyword, or else you have to specify the data type what you're going to return. So since I'm returning something, I need to specify the data type, and in my case it's going to be int, because if you add two integers it's going to be integer, right? So I'm just going to return that particular integer, and then here I need to capture that value. So let's say int sum equal to 2 comma 3, and then now I can do this thing inside the main function also. So here I will just paste it, and sum is in my case sum, right? Now if I execute it, we'll be getting the output as the sum is 5. So another thing is, what if we want to make one of the variable optional? So let's say I have another field also, let's say int num3. This is another parameter. So here if I just omit that parameter, I'll be getting an error. So here you can see that too few arguments to this function. That is because I have specified 3 arguments, and then here I'm giving only 2 arguments. So what you need to do is, if you're having an optional variable, you can just put a default value over there. So for addition, if the default value is 0, if you add those three numbers, there's not going to be any difference, right? So if we just put 0 over here and then I don't pass anything, so it will just do 6 plus 2. So let me just add the number over here also, so num3 also. So I'm just going to store c equal to num1 plus num2 plus num3, and then I'm going to return c. So now if I execute it, you won't be getting any error and you will be getting the sum perfectly. And if I want to use that variable, I don't have to do anything. I just pass the number and I will be getting the output. So 9 8 is 17. So here you can, this sum is 17. So that's how you use default parameters. And regarding the prototype, so what is a prototype? It is just mentioning the compiler that I do have a function like that in case you did not write the function's definition before calling it. So what I mean is I have already called this function over here. So if I write the definition after calling it, I need to specify it, or it says that this particular function does not exist. So to do that, for the prototype, as I told you, you can directly copy paste this thing. So Control C and Control V, and then put a semicolon. This is going to work, but what you can do is, in case of parameterized function, you don't have to write the variable names also, so you can just skip these things. Well, it's going to work with the variable names also, but you don't have to put them, and you should not put default values over here. So that is there in the function definition. In the prototype, you just need to define the structure of the function, and you don't have to put the default values and all. You just need to put what the function is and what it's going to take. And now if I execute it, I won't be getting that any error, and I'll be getting the output. So that's how you use dependent functions in C++. In the next video, we will talk about recursion and different types of passing arguments. So here I just pass some numbers, right? So these are direct numbers. So what if I want to pass some variables also? So let's say a equal to 2. Well, in this particular case, you can just pass it over here. It is going to work. Well, it's int a equal to 2. It is going to work, but actually there is a meaning for passing like this. There are two methods of passing variables, that is passing by value and passing by reference. In this video, we'll be looking at different methods to call functions in C++. So now the question is, why do we need different methods to call functions? Why calling functions simply like this won't work always? So to answer that question, let us take another problem. So let's say this time we need to write a function to swap the values of two numbers. So what I mean is, if I now print a and then b like this, what I'll be getting as my output is 2, 8, right? Because the value of a is 2 and value of b is 8. Now what you want to do is, I want to call a function. So let's call that function something, let's say swap nums. So I want to call this swap nums function by passing in a and b, and then here if I then print this particular a and b's value, what I should be getting is, I should be getting 8, 2. That is, a is holding the value of b now, and then b should be holding the value of a now. So let us first try to solve this without a function. So to do that, first of all, we need a temporary variable, because once we overwrite a value, it's gone, right? So I want to preserve both the values so that I can reassign them. So let's say int temp will hold the value of a, and then I'm going to reassign the value of a to b, and then now since I need the value of a, it is already stored in temp, the previous value of a, so that I can just put it inside the b, right? So now if I now execute this particular code, I will be getting my desired output. So now a has become 8 and then b has become 2. Now what if I want to define this as a function? So since we are not returning anything, it's going to be void, right? And then those two parameters remain the same. The name of the function is swap nums, so swap underscore nums, and then this is the logic which goes inside that. So control X and then return goes away, and then here we have that particular logic. So now if I now call this particular function and then try to execute this particular code, you will be surprised that nothing happened over here. It still is 2, 8. A's value did not change, neither did B's. So now why did that happen? That is because this A and B are not the same ones as this A and B. These two are different variables actually. Even though the name of the variable is same, but this particular variable which I have defined over here, all the set of variables, these belongs to this particular function. That is the swap nums function, and these two variables belong to this main function. So I cannot use this particular variable here or this particular variable here. So if I try to print the values inside this, that is if I print out a and b inside this particular function, it will be swapped over here. That is, these two a and b are actually swapped, not these a and b. So to differentiate that, let me just put a function over here so that we can differentiate the output of our function from the main, and then I will even add an end line over here. Now if I execute this code, so here you can see that inside the function a and b got swapped correctly. That a got the value of 8 and then b got the value of 2. But outside the function, in the main function, it did not happen. So how do we solve that particular problem? Well, to change these numbers directly, or one way is that we can declare these as global variables, that is outside all the function, so that this will be always present in the memory. But that is, as I told in the previous video, it is completely waste of memory. So another way is to do that is we can directly change this particular variable by referencing it, that is by going into the address of that variable. Every variable has an address in the memory, right? We are just creating a location inside the memory and then renaming it to a and b over here. So if we can access the address of this a and b, we can go to that particular address and then change that particular value. So in that way, we won't be actually copying down these values inside new values over here and then working on those new values. That is what is happening over here, right? Once we pass in two numbers, what is happening is these two variables are dynamically created in the memory, and then these values are getting copied inside these values, and whatever happens inside the functions happens on these particular local variables. So variables which are actually called from the main function are not going to be affected by this function. For whatever you do inside this function, that remains local to those two variables only, or those set of variables. So to actually access the address of a location, we need to understand a particular operator called the address operator, or the reference operator, or the ampersand operator. They are called in different ways. So what it is you just need to put an ampersand over here to access a address of a particular variable. So now if I just execute it, what you will be seeing is the address of that particular variable. So here you can see 0xcd, whatever it is, that is the hexadecimal address of this particular variable, that is a. Now b will have another address. So if I now put b over here, let me just close this, and then if I now execute it, so here you will be seeing 0x6d, whatever it is another address, right? Both are at different locations. So now what we are going to do is, instead of passing the values inside this, we are going to pass the address over here, so that it knows that it needs to work on those addresses only. So here, instead of declaring variables like int a and then int b, what I'm going to do is I'm going to specify that we are going to get the address of a and b, or any variable. You can put x and y over here, it doesn't matter. What it specifically means is that you are going to get a variable's address and you need to work on that particular address only. You don't have to create a new variable. That's what this particular and means. You can put any name over here, it doesn't matter. So now what happens is, if I now call the function, and then here if I just put this particular line over here, so let me just replace this line, and then let's say main, right? Now if I now execute this particular code, you will be seeing that in the function it got swapped, and now in the main function also it got swapped. Now a is holding the value of 8 and then b is holding the value of 2. So this is why we need different methods to call functions, and basically there are only two methods to call functions. One which we do always, that is simply passing the values, and then the other one is by passing the address. So those are the two methods to call functions, and they are actually named in that way only. So one is call by value, in which you just call using the normal method. That is, you just pass in the values over here, and then the values get copied, and then you get all the output which you required. So this particular method is used only when you don't really care about changing the values in the main method, or whatever it is, the main particular value which you are going to pass inside the function. If you don't want to change that particular value but only want to do some computation with that value, such functions are better to use, that is call by value functions. And when you want to change the value, what you do is call by reference. So reference means address, and the way you call by reference is in this way. So you need to pass the ampersand symbol to specify that you're going to work with the address of that particular variable and not with the value of that variable. So it knows that it doesn't have to create another variable and then copy that function, but what it will do is it will directly go to that address and then carry out all the operations which you specified, right? So now instead of putting b and b over here, I can even put b. You can use combinations. It totally depends upon the work of that particular function. So since I had to change both the variables, that is why I had to put and in both the variables. If I want to change only a and not b, now if you execute this function, you will be seeing that a has changed to 8 and then b remains 8 inside the main function. That is because I did not pass in b as an address, but I passed in b as a value. So that is how calling functions in different methods work, and those two methods are call by value and call by reference. In this video we'll be looking at recursion. So what is recursion? Well, recursion is nothing but a method which we use to solve problems, where if you manage to break that particular problem down into a set of simpler problems, what you will observe is that those set of simpler problems are nothing but a simplified version, or you can say a miniature version of the main problem itself. So let's take an example to understand it better. So recursion. So let's say we want to write a function called sum of n, which will return us, let's say, the sum of natural numbers up to n. So what you need is 1 plus 2 plus 3 up to n. So this is the value which we intend to return when sum of n is called. Now there are different methods to solve this problem. One is a pretty naive approach. So method one is nothing but by using looping, right? So everybody is familiar with this kind of approach. What we have is we have some variable to handle the overall sum, and then we will loop from the starting value till the ending value, that is from 1 to n, and while going through each value we'll just add that value to the overall sum, and in the end we'll just return the value of sum. So this is one of the method to solve this particular problem, and the other method is by using a concept of mathematics called arithmetic progression, or AP. Well, I'm not going to go into the details of arithmetic progression. That's a very beautiful concept, and I encourage you to look that up in the internet. But for now, what we're interested in is how we can get the sum of n terms in an arithmetic progression or an AP. Well, the formula for getting sum of n terms in an AP is n by 2 times 2 into a plus n minus 1 times d. So this is the formula for getting the sum of n terms in an AP. Again, I'm not going to go into the details of this formula. You can again go and look that up. Now, a is nothing but the first term of the series. So in here, the first term is nothing but 1. So 2 into 1, and then d is nothing but the common difference between two consecutive terms in the series. So any two consecutive terms you can take, and then you can see that the difference is 1. So we can just substitute it over here. And if you solve this, if you simplify this, you will be getting this particular result, n into n plus 1 over 2. So this is the result we will be getting after simplifying this equation. Now, if you just plug in the value of n and you can just return this particular value, you don't have to loop around and then keep another variable and all this stuff. This is the most efficient way to solve this particular problem. Now we'll be looking at another approach to solve this particular problem. Now let me just clear this thing. Let's say we want to calculate the sum of some number, let's say 10. So sum of 10. Now what is sum of 10? It is nothing but 1 plus 2 plus 3 all the way up to 10. Now we can also write this as 10 plus 9 plus 8 plus all the way up to 1. I just reverse this particular order. Now if you observe this particular value, what is this? This is nothing but sum of 9, because sum of 10, when it goes from 10 to 1, sum of 9 should go from 9 to 1. So this is nothing but 10 plus sum of 9. Now again, if you observe this particular value, this is nothing but sum of 8. So this is nothing but 10 plus 9 plus sum of 8. So in a nutshell, if you want to just generalize this, you can say that sum of n is nothing but n plus sum of n minus 1, right? And now this particular relation, if you observe, you have broken down this particular problem into a set of simpler problems, and this problem is nothing but a simplified version of this problem. So this is what is called recursion. Now, before trying to code this thing, we need to understand that recursion should have a limit. Now, if you reach 1, so what will happen is it will try to find the sum of 1, and then here when it goes, it will try to find the sum of 0, and it will go on up to negative infinity, right? It will just go on, and then once it reaches a stage where it has reached the extreme of the integer range or any data type you have kept over here, it's going to stop, and then it's going to throw you an error. So recursion should always have a limit. So that limit is called as the recursion limit, and it is really important that you should mention a recursion limit when you are using a recursive function. The recursion call, or what you're doing is, here you're just calling that function again, right? So this call should end somewhere, so that somewhere is nothing but the recursion limit. So now in this particular problem, when you reach 1, you don't have to again call this particular value, right? Because you have reached a saturation stage where sum of 1 is nothing but 1. So once you reach 1, you can just return 1 over there. So the recursion limit for this particular problem is nothing but 1. So now let us code this. So the return type is int, and then the function's name is sum, and then you have variable called n, and here what we need to return is return n plus sum of n minus 1, as I've just discussed before. And before that, we need to check whether we have reached the recursion limit or not. So what is the recursion limit? If n equal to 1, then what we need to do, we just need to return 1, or else we need to return this. So else return n plus sum of n minus 1. So that's all. Now we can just test this function cout sum of 10, and once you run this, you will be getting 55 as our output. So that is the correct value of sum of n, and that's how recursion works. Now this is a very bad example to actually explain recursion, because recursion is not generally used where it is not needed. So recursion actually takes up lots of memory. So here, if you observe, if I just call it with the value 10, it is going to again call this particular function with the value 9, and again 8, again 7, and so on. So every time it calls, a new value of n is created. So what is happening is, effectively, if you calculate the space required for running this particular problem, so for n equal to 10, it is taking 4 into 10 bytes, right? 4 is nothing but 4 bytes, which is the size of an integer, and then 10 is because it's getting called 10 times. So this is effectively 40 bytes of memory, right? And if you take the first case, let me write this. This is the third case, right? This is by using recursion. Now first case, if you observe, which is by using looping, what we are doing is, we have 3 variables, that is sum, n, and then I. So it is nothing but 3 into 4, which is 12 bytes. Now that has drastically reduced the size, right? And then if you now look at 2, it is nothing but only 4 bytes of memory, because we are not having any extra variable. We are just using n, and then we are just plugging it into an equation to get the result. So this is the most effective way, and this is a better way, and this is the worst way to solve this problem. But since this particular approach is easier to understand. I had taken this example. Mostly recursion is used where you can't figure out a generalized looping solution to solve a particular problem. So that particular example includes something like finding, let's say, paternal ancestor of a guy. So let's just take a family tree example. Just search for family trees in the internet, and then let's take an example. Let's say, okay, this one. So this one is like a tree. So here you can see that this is, let's say, Tom, and then Tom has a mother and a father, and his father again has a father and mother, and mother again has a father and mother, and again that hierarchy continues. Now if I want to find the paternal ancestor of this Tom, what I need to do is I need to find the father of father of father of father. That's what I need to find, right? Now to find that, what we can do is we can just reduce this problem to just look at this particular generation. That is only one generation. If you take this one generation, what we need to do is we just need to move to the father. So let's say we need to move to left side of this particular hierarchy, because right side is mother. Let's just assume like that for now. Right side is always mother, and then left side is always father. So here if we just take this particular generation, we need to move to the left side. And again, if you just break this problem down, here if you take this particular generation, we again need to move to left, and this particular generation we again need to move to left. And once we have reached a stage where that particular guy doesn't have a father, then he's the ancestor, right? So this fellow, let's say John, is the ancestor of Tim. So in such cases, recursion will be useful. So that's all for recursion. In this video, we'll be looking at arrays. So till now, we have been working with programs where we already knew the number of inputs, right? So we knew the space required for our programs to work and all the stuff. So let's consider a program where we don't know how many inputs we need to store. So something like this. This is a code snippet which is basically taking in records, let's say student records. So every student has a name and age, and then the user gets to enter how many records he wants to enter, and then we are going to take in the records. Now, if you run this program, you can see that the program doesn't crash, right? So if I say I want to enter three records, it's going to take in three records. So A1, B2, C3. So you can see that the records are taken successfully, but if you look at this more closely, you see that those records are not getting saved anywhere, right? Those things are just getting overwritten every time. Now, there is no way that we know how many records the user is going to enter, right? It completely depends on the user. So how are we actually going to store all the records? We can only store the last record in this way, but all the previous records are getting lost, right? So how can we store all the data so that no data is lost, and also we don't limit the number of records, and the user gets to enter as many records as he wants? So it turns out that you cannot define the number of variables or the space you want at runtime, but you can define a collection of space in runtime. So let me illustrate to you what I mean. So let's say the user wants to enter some number of records, let's say 5 records. So if you consider this white space as the computer's memory, so what we'll be effectively doing is we'll be creating collections of variables. So we have two variables over here, right? So we have one name, and then you have an age, right? So what you will be doing is, instead of creating different variables like name1, name2, and so on, we'll be creating a collection of variables, something like this. And then inside this collection, what we will be doing is we will be separating this collection. I mean, we'll be creating partitions inside this collection. So let's say the user wants to enter 5 records. So what we do is we create a collection and then make 5 partitions into it. So you have 5 partitions over here. So all of them are obviously they are of the same size, and then age also you will be giving 5 partitions. So like this, right? So now what happens is, once the user gets to enter the records, you will be entering into that particular area which is assigned for every particular record. So let's say for the first record you enter the data into the first box, and then for the second record you enter it into the second partition. For the third record you enter it into the third partition, so and so on. So this particular kind of process you will continue, so that you can enter all the records, and then you can also access these records by just accessing the partitions, right? So this is how arrays work. Well, arrays literally mean collection of objects, and that is what it means in programming too. So what you're basically doing is, instead of creating n number of variables, you will just create this memory space which is capable of holding n number of variables, and then create partitions into it. So once you create partitions, you can add data into it, and then you can retrieve it. You can perform operations on it just like variables. So basically, you can think of array as a collection of variables, but it's not actually a collection of variables. It's just a collection of memory. So if you take this particular array, if you take the size of this particular array, you will see that it is nothing but the number of elements inside it. So in this case 5 into the size of each element inside this. So the size of each integer is 4 bytes. So the size of this particular array is going to be 20 bytes. So you can see that array is nothing but just a collection of memory, or you can say collection of variables, and then you can add and retrieve it as you like. So let's see how to implement this particular ideology in programming. So to implement an array, what you need to do is you need to declare an array. So how do we declare an array in C++? We don't have to do anything. We just need to put square brackets so that this particular variable is addressed as an array by the compiler. And then inside this particular brackets, you need to specify the number of items the array should be capable of holding. So in our case, we are going to get the number of records, right? So if you give n records, you are going to have n names and n ages. So the size of our array is nothing but the number of records, right? So what you do is you just mention the size inside the square brackets. So for the age too, you are going to do the same thing. So age records, and then over here, what we'll be doing is, instead of name, we'll be accessing the partition. Now, how do we access the partition of an array? So for accessing the ith partition, or the ith segment of the array, or you can say the ith variable which is stored inside the collection, you need to access it as the name of the array, so array name, and then inside a pair of square brackets you need to specify the index, where this particular index is nothing but I minus 1. So let's say you want to access the first partition of the array. So for the first partition you need to give index as I minus 1, which is equal to 0. So for the second one you need to give the index as 1, and so on. So for the nth partition you will be effectively giving n minus 1 as your index. So that is why, if you remember, I generally start loops from 0, because it becomes easier to work with arrays if you are working with loops which are starting from 0, because of this particular rule, because the index of an array starts from 0. So I don't have to subtract 1 from the counter every time. I can directly access the partition by just calling the counter. Now to access that particular partition, you don't have to do anything. You just need to put the square bracket over here and then access the partition. So since I'm using a counter over here, I'm directly going to access it by the counter, and the same thing over here too, right? Now how do I retrieve it? Well, retrieving also follows the same rule. So you need to pass the array's name and then the index, which is nothing but I minus 1 if you want to access the ith partition. So let's say we ask the user to retrieve some record. Let's say, which record do you want to retrieve? And then the user enters some record. So let's say nth record. So he wants to retrieve the nth record. So we'll be getting the nth record as our input. And then what you need to do is you just need to access the nth record as nth minus 1. It's the same rule. And then for the name, and then that goes same for the age too. So you just need to access it by n minus 1. And then if you run it, so let me just put an n line over here. So here you can see that if I enter some records, let's say A1, B2, C3, and then if I want to retrieve the second record, you see that the name is B and then the age is 2. So that's how arrays work. As a recap, arrays are nothing but a collection of memory, or you can say a collection of variables where you can store and retrieve variables as you wish. So now what all variations can you do with an array? Well, it turns out that you not only can store collection of variables, but you can store collections of collections too. So that is basically the dimensions of an array. So dimension basically means collection of collections. So basically, if I am saying that an array is one dimension, so if I say that array is one dimension, it basically means this thing, that it holds a collection. Now, if I say that an array is two-dimensional, then what it means is it holds a collection of collections. So how do we define this? We just put another pair of square brackets over here and then define the second dimension. So this is nothing but a matrix if you observe. So if you are familiar with matrices, you have some array of numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you observe this, this whole thing is a collection, and three such collections form this particular matrix. So how can you define this? You can just define this as a 3 cross 3 array, right? So if you say this particular thing is a matrix, so let's say this is matrix M, which is equal to this thing. So if this particular matrix is this one, then it is nothing but a 3 cross 3 matrix, right? And the way it is defined in the memory is you have this particular collection where inside each collection you have three items. So 1, 2, 3 is one collection, 4, 5, 6 is another collection, and then 7, 8, 9 is another collection, and all three form the overall collection. So this is how your variable mat is actually defined in the memory. Well, you don't have to always take in input inside an array from the user. You can even define the inputs. So how do we define it? Well, to define inputs, you just need to put a pair of curly braces and then define your data. So let me just clear this and we'll take some generic examples. So let's say our array is a 3 cross 3 array. So let's just define that matrix which we talked about. So how do we define this? First we define an overall collection, and inside this collection there are going to be three collections. So one collection is 1, 2, 3, and then you have the second collection as 4, 5, 6, and then the third collection as 7, 8, 9. So this overall makes 3 by 3 matrix. So if you want to access it, you can access it using loops. So for int I equal to 0, I is less than 3, I plus plus, and then you need to run another loop for accessing the inner collection. So for int j equal to 0, j is less than 3, j plus plus, you can just show that element. So a of I comma j, right? Let's just give a space over here and then a new line after, so that it looks like a matrix. Now if I run this, oh, I forgot to put a comma over here. Yeah, so here you can see how the 3 cross 3 matrix is defined. Well, you can have collections of collections of collections, so that is basically a three-dimensional array. You can go up to any dimension in an array. There is no limit to that. You can have as many collections of collections, and it completely depends upon your problem. So mostly we tend to use this kind of collection, which is a matrix, and then the single dimensional array, which is nothing but just a collection of data. Well, another point to note that is these collections cannot contain mixed data. That is, you cannot have both integers and strings in one array. So in an array, what happens is that particular array will contain data, or will contain a collection of data of only that particular data type. You cannot change the data type, or you cannot have mixed data inside one particular collection. So that's how you work with arrays in C++. You can also pass in arrays to a function, but always arrays will be passed as a reference, not as a value. So if I create a function over here, let's say int func, which just takes in the array, so int a, and then you need not define the dimensions. If it's just a single dimension, you can just leave it as a square brace, and if it is multi-dimensional, then you need to define the last dimension of the array. So let's say you are passing a three-dimensional array, so then you need to define the last dimension, which is the third dimension, compulsorily. You cannot omit this dimension. And if you are passing this particular array, which is a two-dimensional array, you need to pass the second dimension, which is 3. You can leave this or you can define this, it really doesn't matter. But if you are passing some array which is not single dimensional, then you need to pass the last dimension of that particular array. So now let us just define this function. Let's say we don't have to do anything, we just uh, print the first element of the array. So a is 0 0, this is the first element, and then what we'll do is we will change that element. So we'll change a 0 0 equal to 5, right? And then I'll just return some things. Let's say we'll skip this return, we'll just make this void. So this is a void function, right? Now if I call this function, so if I just say func and then pass in a, and then we when print the first element after running this particular function, so let's just put end lines over here so that we can differentiate between the output. So one over here and then one over here. And now if I run this particular program, you will see that the value of array 0 0 was 1, which is nothing but this particular element. And then if I change that value over here, I could change it over here too. So in the main thing also it changed. So that explains that arrays are not passed by value, but they are passed by reference. So arrays don't get copied when you pass them to a function, but they are changed in the memory itself. So what you're essentially doing is you're just passing a pointer. We will be discussing pointer at a later stage, but what pointers basically mean is they are nothing but those are variables which carry addresses. We will discuss more about pointers at a later stage, but for now, this is how we use arrays in C++. In this video, we'll be making our first programming project, which is essentially going to be a console-based tic-tac-toe game. So in case you're not familiar with the game, let me just quickly walk you through the game. The game has a 3x3 board and two players who play alternatively. So the objective of the players is that they need to fill one of the rows or columns or the diagonals with their marker. So if I just start the game with a computer, you can see that we are playing alternatively, and our goal is to just fill up one of the rows or columns or diagonals with our marker. So here if you see, the computer has managed to fill the row with its marker, so it gets to win the game. So we're going to implement this game on the console, and well, we won't be implementing such a sophisticated system where the computer can play, although I will be giving the intuition required for building such a system towards the end. But what we'll be implementing is a two-player game. So if you go over here and then change this mode to play against a friend, you can see that you make both the moves by yourself. So we will be implementing this, but I will also be giving you the intuition required to implement a system which can think and then make moves towards the end. Right? So let's get started. So first, create a new project naming tic-tac-toe. So the project title is tic-tac-toe, and let me just save it in my desktop and then click next, finish. So now we have our project with our source file, right? So let me just make the text a little bit bigger. Now we'll start off by creating the board. So there are different ways to implement this board. You can think of this as an array of 9 elements, and then 3 of them are stacked together as a row, or you can even think of this as a 3x3 matrix. Well, I will be implementing this particular board as a 3x3 matrix because we can understand rows and columns better by looking at the indexes rather than the slots. But you're free to implement it as a 1D array also. That is by creating 9 elements and then stacking 3 vertically. Alright, so I have managed to draw this implementation over here. So what we'll be essentially building is a 3x3 array like this, and then these are the indexes, and since we cannot detect mouse clicks on our console, we will be numbering our slots. So let's say the user wants to enter his marker over here, so the user can press 5 and then we will remove this 5 and then put marker over here, let's say x. So the 5 goes and then we put x over here. So that's how we are going to implement it. But there are other libraries which I encourage you to look up, which support mouse clicks on consoles too. So in case you are interested to implement such a system where you can click on the area and then your marker appear, so you can check out those libraries. Well, discussing those libraries are well beyond the scope of this course, so we are not going to do that. So for now, we will be implementing this particular system, right? So let's start off by creating the board, which is a two-dimensional character array. So let's call this array as board, and then this is going to be two-dimensional, and every dimension will have three elements. So this is a 3 cross 3 board. Let me just put it over here. So even if you don't put it, it doesn't matter. I'm just putting it so that we be clear with our implementation. So let me just name the slot. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So notice that I am numbering the slots as characters, because if you put characters over there, it will take it as an ASCII value. I'm sure you know this, right? Now let us quickly make a function to draw the board. So let's say void draw board, and what this function is going to do is that it is going to draw the board neatly for us. So something like this. So these two vertical lines and then these two horizontal lines separate the rows and columns. We'll be drawing that over here. So you can use a loop, but since there are only 9 elements, let's just hard code it. So board 00, let us give a space before board 00 so that it doesn't get squashed up to the left. All right, board 00, and then we have a space vertical line, and then board 01 space vertical line, and then board 02, and then we have the next line because we just completed the row. What we did is we just printed this row with these two vertical bars. Now we need to put a horizontal bar. So let us just put that. See out horizontal bar is just going to be lines. This is all completely designing. You can do it as you want, right? And these steps continue for the next two rows too. So control C V B, and for the last row we don't need the horizontal lines. And here you just need to change the row number. So this becomes 2, this becomes 1, 1, 1 over here, 2, and 2. So now if we call this particular function, let's just remove this and call draw board. Now if you run this, we'll be getting our board. So well, the horizontal lines became extra. How many characters are these? 3 characters or more. So let us just remove those 3 characters over here and then over here. So this board looks much better, right? So we have our board ready. Now how do we put data inside this board? So let's make another function to do that. Let's say void place marker, which is going to take a slot number, right? Because the user is going to enter the slot number. Now our task is to convert the slot number into the row and column number, right? If you are using a one-dimensional array, that is pretty easy. You just need to do slot -1 to insert that into the particular position, right? So suppose you want to insert it into this particular position, and if you're using a one-dimensional array, this is the fourth position, right? Because array indexes start from 0, so 0, 1, 2, 3, 4, and you just need to do slot -1. But since we are using a two-dimensional array, we need to find out a way by which we can convert this slot number into a row and column number. So what we can do to find the row number is that we can use an observation that all the rows start from a number which is just one greater than the previous multiple of 3. So if you observe over here, 1 is nothing but 0 times 3 plus 1, 4 is 1 times 3 plus 1, and then 7 is 2 times 3 plus 1. So what you can do is you can get the row number by dividing the slot number by 3. But then again, if the slot number itself is a multiple of 3, then you need to subtract 1 from the slot number. That is, if you take example of 6, So if you do 6 over 3, it is 2, right? But we need it in slot number 1. So we need to subtract 1 from that. So what I mean is, if this particular slot percentile 3 equal to 0, that is if the slot is a multiple of 3, then slot equal to slot over 3. So this is this, and then minus 1. So this will give us the slot number, else slot is directly slot over 3. So this should give us the particular row number. Sorry, let us take a variable, just directly changing the slot. So if slot percentile 3 is 0, then row is going to be this particular value, or else row is going to be this value. Now let us just see whether our row works correctly or not, and let us just call it with place marker, let's say 8. Right, now if you run this, you should be getting 2, which is correct, right? Because 8 is in row number 2. Now to get the column number, you can do something similar to that. So to observe the columns, these are nothing but reminders which you get after dividing by 3, right? So you can do the same thing. So let's take another variable to store the column, and column is nothing but slot modulus 3. So this should give us the reminder. So if you look over here, let me just pull up that image. Now if you say 3, then our row is going to be 3 over 3, and since 3 is a multiple of 3, so it is going to be 3 over 3 minus 1, which is equal to 0. And then our column is going to be 3 modulus 3, which is going to be 0, but that is not our column, we need 2. So what essentially we need to do is, if it is a multiple of 3, if the slot is a multiple of 3, we need to put it in the end, or else that particular logic will work. Alright, so over here what you need to do is, if this particular slot is again a multiple of 3, then our column is going to be 2. Alright, or every time when the value is a multiple of 3, you're going to put that in the last column, and then you can divide this slot number by 3 and then get the remainder. That is going to be your column number. Alright, get the remainder and then subtract 1 from that. That is because we are not considering the multiples of 3, right? We are leaving the multiples of 3, so we need to subtract 1. Let's say 4, so 4 divided by 3, you get a remainder 1, and then 1 minus 0 is 0, which is the column number of 4. Right, so this is how you get the column number. So let us just quickly rewrite this with fewer conditions. So row is going to be this particular value, right? Irrespective of whether slot is going to be a multiple of 3 or not. If it is a multiple of 3, we can just subtract 1 from this value. So if slot modulus 3 is equal to 0, then row becomes row minus 1, and then column becomes 2. Right, this is only when the slot which you're giving is a multiple of 3, or else, or let us define the column before using it, or else what happens is columns become slot modulus 3 minus 1. So first we perform slot modulus 3, and then we subtract 1 from that. Alright, so this is how we can get the row and column from our slot number. If you now check out the row and put a comma over here and then column, and then let us call with 8, so we should be getting 2 comma 1, which is what we got, right? Because 8 is in the second row first column, we can try it with some multiple of 3, let's say 9, and then try to run this. We should be getting 2 comma minus 1. Now why did that happen? Well, that is because we are trying to modify the column even after it is getting modified over here, right? We are modifying the column when slot modulus 3 is equal to 0, and then again we are modifying it over here. So we need to put it in the else part. Alright, now it should work fine. Now let us just close this and try it again. If I press F9, so here you can see it gave us 2 comma 2, which is correct. So now we know that our logic for getting the row and column is correct, so we can proceed by putting our marker into the board. So how do we track which marker to put? So let us create a global variable for tracking the marker. Let's say current marker, and let us set this to some value, or else we'll set it while we are asking. We'll set it while we are asking the user to choose the marker, right? And we will also have a current player, right? So we need to even track the current player to check which player is playing, right? So we have one marker and one player. Now what we are going to do is we need to just put board of this particular row, and then this particular column is going to be the current marker. So now we have successfully placed it. Let's place a marker over here and then try to draw the board. We'll draw a board over here too. So draw board, and then we'll put a new line so that we don't get confused between the two boards. So let's just say that current marker is X for now. And if we try to run this, you will be seeing that in place of 9 now there is an X, right? So now we know that this particular function works. We can place our marker on the board. Now let us make a function to determine who won the game, right? So let's call this function win or winner, something like this, and we will put the data type to char. I will just explain why we are putting the data type to char right now. So this is not going to take anything. This is going to work on the global board variable, which is this, which is an array, right? So what we're going to do is we are going to check all the rows, the columns, and the diagonals, and see whether those have the same value of marker, right? So in case they are numbers, they are going to be different, so nobody won. And in case they have this x's or o's stacked up horizontally, vertically, or diagonally, it means that that particular player won, right? So now since we are getting the winner, we can either put it true or false to determine whether the game is won or not. But to determine who won the game, we need to again check whether that particular marker is an X or O, right? So what we are going to do in this function is, instead of checking twice, we will directly return the marker of the winner. So by marker we can identify which player won, and then we can congratulate him or her, right? That is pretty easy now. So to do that, let us quickly run a for loop. So int I equal to 0, I is less than 3, I plus plus. And inside this, we are going to check for rows first. So if this particular board of I and then 0 is equal to board I1, and board I1 is equal to board I2, then return the current marker, right? Because we are going to check whether the player wins immediately after he places the marker. So if this particular condition is satisfied, then it means that one of the rows has been occupied by this current player, so he's the winner. And you can also check for the columns in the same loop. So what you need to do for the columns is the same thing, but just the i's get shifted to the second dimension. So since I am checking the rows, I am just putting I in the first dimension. For columns, what we need to do is we need to remove the I and place it over here. So let me just cut and paste it, and this goes over here, and this goes over here. So now we have successfully checked whether the rows or columns are filled. For diagonals, you can just hard code it since there are only two diagonals. So if board of 0 0 is equal to board of 1 1, and board of 1 1 is equal to board of 1 2. So what we are doing is we are essentially checking whether this value is equal to this value, and then this value equal to this value. If these two conditions are true, it means that these three values are equal, and it means that the player has won. So if this condition turns out true, then the current player has won. Current player or marker. Oh, since I'm using the player as a integer, I need to return int, not char. So over here it is not current marker but current player. You can return either of them, right? You can return current marker or current player. It just depends upon you, right? So now we need to check this condition for the second diagonal. So this goes, and then for the second diagonal, the coordinate are 0 2 1 1 and 2 0. So 0 2 1 1 remains the same, and 1 1 is equal to 2 0. Then you return the current player, right? So now what if nobody won? So you need to return something. So what we'll return is we will just return 0. 0 means nobody won, and if it is either 1 or 2, it means that player 1 has won or player 2 has won. So now we have the winner. Let's just create an arbitrary board and then check who won, right? So let's place these markers, right? Place marker at 9, 8 and 7. So it means that X has won. So 9, 7 and then place marker at 8, and our current player is going to be 1. Right now if you run this, okay, the spelling is wrong, current player. And if I try to run this, so here you can see I have placed 3 x's over here. Now if I try to call this function, which is winner, and try to print the data over here, so you can see that it has outputted 1. 1 is the current player who has just put 3 x's in a row, so it works for row. Let's just check for column. Column is let's say 0, sorry, 1 and then 4 and 7. So this is the first column, and we'll run this. So it has returned 1 again, and let's check for the diagonal. So that is 159. So now you see that doesn't work for diagonal. That is because we messed up the logic somewhere. Let's check that out. Oh, it is not 1 2, it is 2 2 over this, right? So that's a small mistake I made. Now if you again run this, this should work now. So here you can see it has outputted 1, and let's keep some arbitrary place, let's say 169. So this shouldn't result in a win, so this should give us 0, which it gives. So now we can see that our winner function is pretty much validated and it works, right? So now let us quickly make the interface we need. So let's call this interface game. Alright, and in this let us define our current player and marker. So we will give a choice for the player 1 to choose his marker, and player 2 automatically gets the other marker. So what we are basically trying to do is, if the first player has a choice of playing X or an O, right? So that's what we are going to do. So player 1, let's say choose your marker. You can come up with your own sentences over here, it doesn't really matter. So this will enter our current marker, right? Or let's just keep a player 1 marker. Let's create a character which says marker of player 1. So we are going to get this particular marker, so marker player 1. Now our current player is going to be 1, and then the current marker is going to be the marker which the player 1 chose, right? Now if you observe this game, right, they can be at most 9 moves for this game to end up in a tie, right? So in case somebody wins, it's going to be less than 9 moves, but if it is going for a tie, it's going to be 9 moves in total. So what you can do is you can run a loop till 9 moves. So int I equal to 0, I is less than 9, and then I plus plus. And inside this, what you need to do is, let's first draw the board, or what we can do is we can first take input from the user and then draw the board. So for the first time, let us just draw the board outside loop, and then for the subsequent moves we'll draw the board after the slot is entered. So we'll ask the player to enter the slot. So see out it's player, and then which player is that? Current players, let's say turn. So enter your slot, and now we are going to get a slot. So in slot, see in slot, and you know what to do, you just need to place the marker. So place marker in this particular slot, and then we will draw the board. So draw board. So now if we run this particular board, we will just call the function game to play a game, right? So we'll just remove all this and then just say game over here. So now if you run this, what you will be getting is player 1 choose a marker, it's going to be X, and then it's my turn, so let's say 2. Now you see that the player is not changing. That's because we did not write code to change the player and the marker. We need to swap the players and markers, right? Because the players and markers are going to change alternatively. And here you can see that the slot has been accepted perfectly, and then the x has come in place of 2. So here you can see that it works, and then if I win somewhere, it is not going to stop, and then it's again going to continue, right? So this game is never going to stop. So we need to fix all these issues. So we'll do that one by one. First, let's take care of the issue where the player and markers are not changing. So let's create a function quickly which swaps the player and marker. So let's say void swap player and marker. So this is the name of our function. So what it does is pretty simple. If the current player, if the current marker is X, then change the marker to O. Current marker becomes O, or else you just change the current marker to X. Right? This is just swapping the markers, and the same goes with players too. So if the current player is 1, then current player becomes 2, or else current player remains 1. So here we have successfully swapped the player and marker. So once everything is done, what we do is before drawing the board, we just swap the player. Right, so swap player and marker, and this should do the job. Now let's test this. So if I run this, let's choose X. Now it's asking player 1's turn, enter your slot, let's say 1. And now player 2's turn, enter your slot. If I enter 2, you can see that 2 is occupied by an O now. So now we have successfully created a system where the players are changing and the markers are also changing. And now we need to take care of the issue that once we are winning, it is not stopping, right? So we need to check whether somebody won or not. So over here, what we can do is we can create a variable for storing the value which this particular function returns, right? This winner function returns. It's going to return a value in the range of 0, 1, 2, right? It's not going to return any other value. So let's just create a variable which stores the winners. So let's say player 1. This is the integer value, and what we need to do is after placing the marker we need to check whether he won or not. So player 1 equal to this particular winner, right? And now here, if this particular value, which is player 1, is equal to 1, which means that player 1 won, right? So see out player 1 won, and then let's say congratulations. And what you need to do is just break out of the loop, because we don't need to continue the game after somebody has won, right? So you can just break out of this loop. And over here the same thing goes with player 2 too, right? You, if player 1 is equal to 2, then you says see out the same message, just we need to change the player 2 and all these things remain the same. So control C and control V, and over here instead of 1 we just need to put 2. So in case nobody won, it either means that the game can go on, or if it has reached 9 moves, it means that it's a tie, right? Automatically, if you're playing for 9 moves and you make the ninth move and still nobody wins, it's going to be a tie. So what you need is, if this particular winner condition, which is player 1, is equal to 0 after completing this game, then we need to say that nobody wins, or let's say that is a tie game, right? So what this will do is, in case nobody wins even after 9 moves and this comes out of the loop, it will then say that it is a tie game, right? So suppose player 1 won and then it broke out of the loop, then if you just put this particular thing without this if condition, what will happen is it will print both the messages at once, right? So it will say player 1 won, and then again it will say that is a tie game. We don't want that to happen. That's why we have put a if condition to check whether it's a tie or not, and then we will say it was a tie game, right? That will take care of all the issues, hopefully. So let's just try with O this time. and it's player one's turn. So let's enter 1 2 3. So you can see it's filling alternatively, and 4 5 6 7, and it says player 1 1, congratulations, but we cannot see what happened over here. That is because we are not drawing the board immediately, right? So what we'll do is we'll shift this draw board function before this particular winning condition, right? So what will happen is once I place this marker, I will just draw the board. So now if I run this, let's say X and then 1 2 3 4 5 6 7, and now you see that player 1 has won. That is because this particular diagonal which I'm highlighting has been filled up by X's. So player 1 won. In case you fill it up with O, it means that player 2 has won. And in case you don't fill it up, let's take a draw case. Let's say we play for 9 moves. So X, let's just quickly put the numbers 1 2 3. So in case to draw, we need to put 5 and then 4 6 and 8 7 9, right? So now you can see that nobody has won even after 9 moves. So it says that it's a tie game and the board is filled up. So our game works perfectly for now, right? So there is a minor bug in this game. For what we did is, so let's say I put my marker in the first slot, right? And now it is player 2's turn, and what I will do is I will again press 1. So what will happen now is, if you observe, the X has gone and then O has taken its place. It means I'll just overwritten it, right? We don't want that to happen. We don't want to move the markers away from their places. So to fix that, what we need to do is we need to check whether that slot is empty or not. That is, if that slot contains some character which is not an integer, it means that it is a marker, right? And we don't want to change that marker. So what we do is, where we are placing the marker here, what we need to do is we need to put this only when that particular row and column is not filled up. So if that board and column, if board of this row and then column is not equal to an X, and it is also not equal to an O. So board of row and column is not equal to an O, then you will be filling it up with this particular marker, or else you won't fill it up, right? So let us return true or false over here, and then we'll print the message over there. So we'll make this boolean or bool, and over here, if this is the case, then you first place the marker and then return true, saying that this operation was completed successfully, or else what you need to do is you return false over here. And here, once we are placing the marker, where did we place it? We were placing it over here, right? So let's say boolean status, or you can directly put this in the if statement also, right? So if this particular condition is true, then we don't have to do anything. We have to print a message only when it's false. So let's put a not over here. So if not place marker of slot, that is, if this condition is not true, then we need to say something. So let's say that slot is occupied, and then try another slot. So this particular message will print, and then we need to decrease I by 1. That is because we need to give the player another chance, right? We can't just switch the players right there. So we just decrease I by 1, and then we just put continue, so that all these statements are skipped, and then it goes back to the execution. So let us just neatly arrange this, indent this code. So we print the message with decrease I, so that the value of I remains same once continuous encountered, right? Because if it is decreased over here, it will go back and it will increase over here. So effectively the value of I remains same, and it should work now. And another thing is, let's say the player entered some pretty big slot, right? Let's say 100 or something. So we need to take care of that too. So if slot is less than 9, less than 1, and if slot is, sorry, or if slot is greater than 9, we should not accept it. So we need to do the same thing, just the message changes. Control C and then Control V,
and here you need to say that is an invalid slot, right? So that slot is invalid, and then you try another slot, and we just put continue so that the player doesn't change. So this should do for us. Now if you execute this, you will be having a functional tic-tac-toe game over here. So it's asking player 1 choose your marker, it's going to be X, and now it's player 1's turn. So 1 2 3 4 5 6 7. So now player 1 won, that's because of this particular diagonal. And let's make player 2 also win. So let's try it once again. So let's say X again. So now it is going to be 1 2 3, and then 5 4, and then what is that, 8. Now you can see player 2 1, congratulations, that is because I have filled up this particular column with O's, right? So in case you wanted to implement a AI kind of a thing where the computer plays, you can do that. Well, we are just going to implement a pseudo AI, not the original one. So this is not going to think much, it is just going to randomly place it. So in case you want to generate random slot, what you need to do is you need to include another header file called stdlib, which is standard library. You can include this one or C stdlib, which is the C++ version of the C standard library. So these libraries are nothing but they are from C language. So in case using it in C++, you just add a C over here to indicate that that is a C library, right? Now to generate random numbers, what you have is you have a function called rand, which will directly give you a random number, right? Just print rand over here, and here you can see it just printed 41 onto the screen. Now if I execute it again, you will see that the same 41 is over here. If you close this whole program and then rerun it, it is going to give you a different number, but again till you don't remove this whole code from the memory, it's going to be the same number again and again and again. So to take care of that, what you have is something called as a seed. So for seeding the random function, seeding is basically you will be giving different starting points to that random function to generate different numbers every time you call it. So to seed the random number, you call the function srand, and inside this you put some number which constantly keeps changing, right? So let's say 1 over, so let's say 10 over here, and then if I try to run this, you will be getting some other number, let's say 71 over here. And if I put some other number, let's say 1 over here now, and then try to run it, you will be getting another number which is 41. But we can't change this again and again, right? We need a way to change this particular number which will generate different numbers every time. So to do that, we can use time, right? So time is constantly changing, it is not constant. So what you can do is if you pass in time over here as an integer, it will give you different random numbers without you having to change this manually. So to do that, we need to include another header file which is called time, right? So c time, right? So same reason why we are using over here, it is time.h or c time, both are same. And you go over here, and then what to do is instead of 1 you just pass in time and then pass in null as a parameter. We'll talk about this null when we're discussing pointers, but for now just remember this is the syntax. And this is how we call the function for time, right? For getting time as an integer. Now if we run this, you will be getting different numbers over here every time. So this is 9170. If I execute it again, you will be getting some other number, 9187, right? So to generate random numbers in a range, we want it in a range, right? We want random numbers between 1 and 9. So to do that, what you can do is you have to use a formula. There is no direct way to get random numbers in C++ in a particular range. But what you can do is you can use a formula which states that if you want random numbers in the range u to l, right, which is sorry, l to u, which is nothing but lower range to upper range. What if you want random numbers in this range, what you do is rand mod u minus l plus 1, and then the whole thing plus l. Well, this formula does look pretty clumsy, I know that, but if you try to reduce this, you will see that it mathematically means the same, that the lowest number will be L and then the highest number will be U, right? So you just remember this formula to generate random numbers within a range. So in our case, what it's going to be is upper range is 10 and then the lower range is 1, right? Upper range is not included. So sorry for this notation. It is mathematically this, which means that the last number is not included, but the number till the previous one is included. So it becomes 10 minus 1 plus 1, and over here the upper range is 1, right? So now if you do this over here, if I try to print this value over here, you will be getting numbers which are in the range of 1 to 9, right? Let us put a semicolon in the end, and we don't need this, so we'll just remove this. So every time we execute, we'll be getting some random numbers which is in the range of 1 to 9, right? So here you can see that it's giving us different numbers in the range of 1 to 9. So now what we can do is we can use this, and instead of the second player, what we'll do is we'll just ask the computer to generate some random slot number and then place our marker over there. And then instead of 9, now the loop will run only for 4 times. That is because the number of times the loop should run is halved, right? We are not going to take in inputs for 9 times. We are going to take in inputs for 4 times. So we need to just run it for 9 over 2 times, which is 4 as an integer division. If you want to implement a really sophisticated system like the one which Google uses, right? This one which can think. So if you take us this impossible level in this particular game and then try to play with Google, you can see that you can never win, right? It will either end up in a draw or you lose, right? Now, there is no other outcome in this particular. You cannot win, that is for sure. So to implement such a system, there is an algorithm called as min-max algorithm. So you can try to study about this min-max algorithm. So sorry, it is min-max algorithm, right? So you have this particular algorithm. So what this essentially does is it will take combinations of games, right? It will play the game with itself and it will score every game. So let's say we have an arbitrary game. So let us just clear this. Let's say we have an arbitrary board. So I have an X over here, an O over here, and then another X over here and O over here, and then the computer is playing X, so it has to make the next move. So what it will do is it will try out all the possible boxes which are unfilled, right? And there are different outcomes for that. So one of the outcomes is, let's say I start off with this board. So let's change the color. So let's say I put an X over here. Now there are different ways to put O. I can either put one over here, one over here. It is up to me, right? So every possibility will generate a new set of boards which the computer will play itself, right, in the memory, and then it will score its outcomes. So let's say in case it put X over here, and then for the first case you put O over here, and then it turns out that after playing such combinations, it turns out that if you put X over here, you have let's say 10 combinations, out of which you won 5 combinations, right? So this is one of the slots. Now what it will do is it will keep the statistics and again play it with the next slot which is empty. So what it will do is it will just remove these things and then it will play with let's say this particular column. So it will put an X over here and then again repeat the same process. It will see all the combinations possible, and then let's say in this particular column which I marked with red, there are again let's say 10 possible outcomes, and then it won 7 of them, right? And let's say it played over here. Let's take some other color. Let's say this one. So it played over here, and then in this again there are 10 possible outcomes, and out of which it could win only 2, right? And you have another possibility over here, or in which 10 possible outcomes it could not win anyone, right? It lost all of them, so it won 0. Now what it will do is it will see all the scores. So here it has 70% probability, right? So if you are winning 7 games out of 10, it means you have 70% probability of winning. and here you have 50, here you have 0% probability, and here you have 20% probability. So it will check the one with the most probability or the most score. So if you talk in terms of numbers, here you have 5, here you have 7, 0 and 2, right? So it will take the number which is maximum, that is this one. So it will say that if I put my marker in this particular place, I have more chances of winning. So it will place it over there. So for every move, it will calculate all the possibilities and then place the best move. And that is how this particular Google is using that particular algorithm to make its decision. So that algorithm, even though it is called something else, it is actually recursion. So if you look at the implementation, it is basically recursion which is being implemented, right? So tic-tac-toe, if you just search for that, you will have many different resources to check that out. So you check that from one of these resources. So what you will see is it is basically implementing recursion. It will just go over the boards and then try to implement, and then you have a scoring method. So I think they have used plus 10 as a score. We have used plus 1 over here, right? We have if you won, you just put 1 over here. If you don't win, you just put minus 1. It means that you won, and minus 1 means that you lose, and you don't want negative scores, right? We just want positive scores. So this is a bit of complicated stuff. If you don't understand, I don't expect you to understand at this stage, but I would definitely recommend you to check that out and try to implement. And this one you can try to implement by reducing the number of loops over here, and then creating another function so that the AI chooses what slot to put the marker in. In this video, we'll be looking at pointers. So now, what are pointers? Well, as I had mentioned before, pointers are variables that store addresses. Now, why do we need a variable to store an address? Well, if you have looked at the address by using the ampersand symbol, let's say we have a variable called var, and if we want to check the address of this variable, then we do an ampersand var so that we get the address, and once you run this you will be seeing some hexadecimal value, right? So this doesn't really make sense. And why do we actually need to store these addresses? What is the point of that? So to answer this question, let us take the problem which we were solving while discussing arrays, right? So the user has some records, let's say n records, and then the user gets to enter these records, and we need to store all these records. Now let's say the user doesn't really know how many records he has. Now our program will terminate after taking number of records, right? So that number depends on the user. If he says he's going to enter 10 records, we will create a collection, something like this, in a memory, which will have the capacity to hold only 10 records. We cannot increase the number of records once memory space is defined. So how do we solve this kind of a problem where the user is going to enter data and he doesn't know how much data is going to enter, but we are expected to store that? So to solve this issue, what we use is called dynamic memory. So what we do to solve this problem is we have a special data type defined, and this data type does not belong to any one of the primitive data types, right? This is not an int, float, char or something. This is a collection of data types combined as one data type. We'll discuss about how to generate these kind of data types in the upcoming videos. But for now, let's just focus on how this works. So you have a data type like this, where one of the data which this data type holds is a pointer. Now what we do is we will put data, or we will generate a data which contains the records, and then we'll just randomly throw it in the memory. So let's say this is one of them, and we just randomly put all the data somewhere in the memory. And to keep a track of the records, what we do is we will just keep a track of this particular record or this particular data. Now what we do is we will just link all this data with the pointers. Now this pointer will hold the address of this particular data, and this will hold the address of the next one, and this will hold the address of next one, and so on. So what I've discussed till now is nothing but an implementation of something called as a linked list, right? So or more specifically, this is called a single linked list. So we won't be implementing this particular data type in our programming right now because you don't have the intuition to define such a data structure which can hold multiple data types. We'll be discussing about them later, but I will definitely show you how to implement a pre-implemented data structure called list in C++ in this video. So first let's discuss about pointers and how to use them, and then we'll look at this particular implementation. The implementation doesn't really have anything to do with pointers, but this is how this particular data type is working in the memory. So if you want to implement something like this from scratch, you need to understand how pointers work, right? So let's get back to pointers. So to create pointers, what we do is we just name the data type of the pointer, and then the name of the pointer, let's say PTR, and then before the pointer we put a star. So the star indicates this particular variable doesn't hold a value but will hold an address. So this is how we declare a pointer, and we can just store the address of this particular variable over here. So you can either do it like this. So you can say ptr equal to and where. So ptr is the pointer, and then and where is going to be the address. So you can store the value of and where inside ptr, or what you can do is you can even directly do it from here. So note that this thing, it is not equal to something like star ptr. You just did int star ptr, and then in the next line you did star ptr equal to and where. This is incorrect. Why? See, int star ptr is going to be a pointer, and a pointer can only hold addresses. So now star ptr, what it does is, if you say star before accessing something, it means that this value is a address, and then star means it will reference to that address. That means you will get the value to this. So star ptr is actually the value which is stored inside the address which is pointed by ptr, and here you are trying to store an address. So this is incorrect. So what you do is you either do ptr equal to and where to get the address of where inside ptr, or if you want the value of where inside ptr, what you do is star ptr equal to where. So you do either of this, but not something like star ptr equal to and where. That is incorrect, right? So now if you want to check what we have inside ptr, you can just do cout ptr, and we'll see that, yeah, that is because I did not put an ampersand over here. Now you can see that this shows okay, these are essentially the same addresses, just that it is not separated with a new line. So if I separate them with a new line, you will see that both the addresses are same. So let me just close this and open this again. So here you can see the address of where and then the value of ptr are same. Now if you want the value which is stored inside ptr, what you do is you put a star before ptr and you will get back the value. So if I run this now, so here you can see that 10 is the value which is stored inside ptr. Now what happens if you change a value inside ptr? So let's say star ptr equal to 20. Now what happens is, since this ptr holds the value of this particular variable called var, what happens is if we change the value which is inside this particular address, it changes everywhere, right? So if you change it over here, this value is going to be overwritten with 20. It will change over there too. That is because you're not using a copy, but you're directly changing the value inside this particular address. Now if you try to print the value of var, and we don't need this, so here you see that the value of var has become 20 now. That is because of this particular statement. And you can have multiple pointers and pointers to pointers also. Let's say we have another pointer int ptr, which is pointer to ptr, and for defining a pointer to pointer, you just put two stars. So this part means that this is a pointer, and the whole part means that this is a pointer to pointer. You can essentially have as many pointer to pointers as you want, but for now we'll just go with two. And To access this, what you do is, so ptr is going to be the address of ptr. So if you do and ptr, you will get the address of ptr inside this pointer to pointer. So let's call it something else. This is pptr is pretty confusing. Let's say um, pointer ptr. So this is pretty good. So pointer ptr will have the address of ptr. So now if we try to run this, what we'll be getting is the address of PTR. So this is not the address of this var, but it is the address of PTR. So if we try to print this, so we'll just print all the things at once so that we can compare them. See out var first, and then we have the address of var and var, and then we'll put a new line over here so that we can differentiate the output. So and and then we have the pointer, which is ptr, the value of ptr, and we have the value which is stored inside ptr, so star ptr, right? And we have this pointer ptr, we have the star pointer ptr and star pointer ptr, and I forgot the end lines over here, so endl, endl, and endl. So here you can see the value of var is 20, the address of var is this thing. Now the value inside ptr is this, and the value which is inside this particular address is 20, and the value inside pointer ptr is this, which is nothing but the address of this particular value, which is ptr, and this is nothing but the value which is inside this address. So now this address is a pointer, right? This address will contain another address which is nothing but this one. So essentially, if you are doing a star ptr, which is to a pointer to pointer, it just means that you are accessing the value which is stored inside the value of another thing. So star ptr is nothing but this thing, which is the address stored in this particular address. Now star ptr is nothing but the value which is stored inside the address which is stored inside this particular address. So that is basically the hierarchy. So if you don't understand, let me just put it as a image so that you can understand better. We'll just clear these things. So now let's say this is ptr, which will hold the address of some variable called var. So now this is this variable called var, which is nothing but a memory location, and this will hold the address of this. Now pointer to PTR, what it will do is, when you define pointer to PTR as a pointer to pointer like this, what it means is that it will hold this particular value. It will essentially hold the address of this PTR. Now the PTR itself will be in some location, right? So let's say this is the location of PTR and that is the location of var. Now what happens is, this address is stored inside this, and you have another thing called pointer to ptr, which will store this particular address. Now once you are accessing the value which is stored inside pointer to ptr, that is nothing but this particular value, right? Now the value inside this is nothing but an address, which is the address of this var. So that is why we were getting the address of this pointer, that is ptr, when we are doing star ptr. And then when we did star ptr, what happened is, it wanted the value which was pointed by the value which is inside this. So that is why it is called pointer to pointer. Now what is the value inside this? That is nothing but this particular value, which is ptr. So this is ptr, and since you have another star, it will go to the value which is pointed by this thing. What is the value pointed by this thing? It is nothing but this value. So it will take out this value and then put it on the screen. So that is why we were getting 20 when we did star pointed to ptr. Now you can even use pointers in functions. So let's say we created a function, void let's say swap numbers, which we did when we were discussing about call by reference and call by values. Now instead of call by reference, when we were doing call by reference, we were doing something like int a, int b, right? So we were passing this ampersand to mention that we are going to get an address. But to get a pointer, you can do the same thing. You can just put a star over here. And the way you swap numbers is we will have an int temp which is going to have the value of the first one. So value is accessed by star a, and we will change the value of a with b, and then star b equal to temp. And here, while calling this particular function, what we do is we can just pass the address directly. So let's say int a equal to 10 and b equal to 20. Now to pass this, what we do is we just call swap numbers ampersand a and then ampersand b. Why this ampersand? That is because this is a pointer and pointer needs addresses, not just values. And now if you try to print a and b onto the console, you will be seeing that they have indeed swapped over here. So now the value of a is 20 and then the value of b is 10. So this is another workaround for call by reference where you want to change the actual parameters. But we generally don't use such pointers. We generally use the call by reference method, which was directly passing address over here and then working with the addresses inside the function. Now, what is the relation between a pointer and an array? Remember that when I told we were passing array to a function, we are actually passing a pointer to the array. Now, what does pointer have to do with an array? So array is nothing but a collection, right? So this particular collection has a starting point, and that starting point is defined by the pointer which is going over there. So let's say we create an array int a equal to int a equal to, let's say, 1 2 3 4 5. This is one array. Now let's just say cout a, and what you will see is, okay, we don't need this, we'll just remove this. Now what you will see is this particular address. Now why did an address come when we are calling an array? That is because this first element, or if you just say a0 and then put an and over here, that is going to be the same thing as this thing. So let us just print both of them together so that we can compare. So cout a and then a new line, and is 0, right? So if you run this particular program, what you will be getting is these addresses which are essentially the same thing. So this particular a which you're referencing here is nothing but a pointer to the first element in the collection. So that is the reason when you pass an array to a function, it is essentially passing a pointer to the first element, and you can increment pointers, right? So once you increment a pointer, let's say some pointer int star ptr is going to be the first element in the array. So this is, you can do it either way. You can just pass in a, or you can even pass a0. Both of them mean the same thing, right? Now if I do ptr plus plus, or ptr plus equal to 1, or ptr equal to ptr plus 1, what happens is this will not increment the value over here, it will increment the address. Now the address incrementation totally depends on what data type you are using. So if it's an int, it will go forward by 4 bytes. So if it's a float, it will go forward by 4 bytes. If it's a character, it will go forward only by 1 byte. So it totally depends on what data type you are using. But if you're incrementing a pointer, the data doesn't change, but the pointer's location changes. Now if you try to print just being pointed by this particular pointer, then you will see that it is pointing to 2. That is because you are just incrementing the pointer from the first element to the second element. Now you can even run a loop through the pointer. So what you can do is, let's say, to access all the elements, what we were doing before is we were doing something like this: int I equal to 0, and I is less than the length, which is 5, I plus plus, and here we were doing cout ai and this, right? So we were doing something like this. Now let's see the pointer implementation, how to do this. So we have a pointer, so int star I equal to a, and then I will go till the length of this array. Now how do we determine the length? Now what you do is I is less than or equal to a plus 5. what you're doing is you're incrementing the pointer over here, not the value of array or the array. You're just incrementing the pointer, which is nothing but this pointer, plus 5 is nothing but till here. So what you're essentially going to get is the pointer or the address to this particular location, and that address you will compare with the address which you have right now. And if it goes till here, it needs to stop, so you can directly do I plus plus over here, and here you just need to put star I. So this is the pointer implementation of getting the elements from an array. Now if you run this, you will be getting the same thing, but here you have a weird value. Now why did that happen? That is because this particular value is the value stored in the collection outside the array. Now every memory location has some default value, and this is the value which is stored in the collection, which is just beside that. We just went one further, that is because I have put I is less than or equal to a plus 5. If I had put I is less than a plus 5, then it would have been correct, but what happened is, since I put I is less than or equal to a plus 5, it went to one location further. So this is the location which is just beside this collection, and that is why the value inside that location got printed, and this is some garbage value. It doesn't have any meaning, it's just there, right? So now since I changed this, if you now execute this, you will be getting the same output, right? So something like this. Now, another very important implementation of pointers is the void pointer. Now, let's say I create a integer pointer star ptr, and we'll have an integer variable, let's say I var equal to 10, and we make the pointer point to this particular I var by giving the address. Now, if I just do ptr, then I'll be getting the address of this particular I var, right? Now, let's say I create another variable called fvar, which is a float variable which stores some variable, right? 3.1415. Now, if I try to change the location of pointer, it won't permit me to do so. It says cannot convert float star to int star. That is because I had implemented the pointer as an integer. Now, to change such locations, what we do is we have a void pointer. Now, what void pointer does is it cannot print the value, but it can change the location. So this particular operation is permitted by void pointer. So if I now do ptr, and then we'll see two different addresses on our screen. So these are the two addresses. It's not separated by new line. Just do that, and we'll run it again. So here you can see there are two different addresses. That is, this is the address of this particular ivar, and this is the address of the float variable. Now, the only drawback is that you cannot get back the value. So if I do star ptr over here, you will see that it will put an error over here. It says that void star is not a pointer to object type. So if you just want to store the address of different variables or different types of variables, you can do that, but you cannot get the value. To get the value, it has to be the same data type as the data you are going to point to. So this is how we use pointers in C++. Now let's just quickly talk about how to implement such a dynamic collection which I just discussed before. So in C++ you have something called a STL. So STL is nothing but standard template library. Let me just write it down here. Standard template library. So what it has is it has previously implemented ready-made functions for you. So it has functions, it has classes, and we'll talk about what are classes and how to use this particular STL at a later stage. We'll just discuss how to create such dynamic containers or dynamic collections in our memory, just like what we had discussed before. So to do that in C++, there are two implementations. And these two implementations totally differ by the use cases. One is nothing but a vector, and the second one is the list. So previously we had discussed about this particular implementation which is called a list, right? So the one, let me just open the screen. So this is the one which we had just discussed, right? We have different memory locations randomly put in the memory, and then we will connect all these locations with a pointer like this. Now the difference between this implementation and the one we have over here is that this is called a single linked list, as I previously discussed, but this implementation which is there in the standard template library or the STL is nothing but a double linked list. What a double linked list basically means is that you have links from here to here too, so it is just like a forward link and a backward link. You have links in both directions. So let's say this link points to here, so you have another link which points from the previous element to the next element, like this also. So you can go either forward or backward as you wish. So this is how the list data type in STL is defined. So this is called a double linked list, or a DLL for short. So if you want to implement such data types in Scratch, we will discuss about how to do that in the next few videos. But for now, I had explained how this works to explain the importance of pointers, right? And the vector is nothing but a dynamic array. So what it has is a normal array-like structure. It will store data in continuous memory location just like an array, but what it does is it will have some extra spaces implemented. So it does some calculations and then creates extra spaces for future elements, and once this gets filled, it will search for another bigger sized location in the memory and then copy all the elements over here and then destroy this from the memory. So all this gets copied over here and then you destroy this completely. So this doesn't exist now, and this becomes our new vector, and this will keep changing, and this process will go on till you stop inserting elements inside the vector. Now when to use a list and then when to use a vector, so let us talk about that. Now vectors are used when you don't delete elements often. So in this implementation, let's say we delete some two elements from the middle. So let's just change the color, and we deleted these two elements, and then you have some ton of elements over here. Let's say you have 500 elements over here, and then you have, let's say, 10 elements over here. And let's just say that this is the size. Now if you want to delete these two elements, what you do is you create another memory location somewhere and you copy this. You just leave these two elements and then copy all these things again, then you destroy this memory location. So that's how vectors do it. And in list it's pretty simple, so let us just clear this. Now to do a deletion in a list, what you do is you directly just remove this link. That's it, this is gone. Now what you do is you just create another link directly over here, and the other link too in case of double linked list, and this will go in the memory. So once you're not using it, it's gone, right? It is completely destroyed from the memory. So what you need to do is you just need to change the links. So that is how simple it is to delete elements in list. So in case you have a problem where you want to delete elements often from the middle, that is more important, you need to implement list, right? So if you want to delete elements from the middle, or you are going to perform frequent deletions, then you need to use a list, or else vector is a better choice. Because in list, if you want to go to the third element, you need to traverse all this way, right? You need to find the first element, then the second element, and then the third element. But in case you are using a vector, what will happen is it's a continuous memory location like an array. So if you want to go to the third location, you just increment the pointer with 3 and then you'll get to the third location. That's how simple it is to access elements in a vector or an array. Both are almost same. So that's the thing, if you are using a vector, you need to use it when you're mostly going to access the data, right? And you need to use a list if you are going to perform frequent deletions. So these are the 2 points to remember, and to implement it, it's very simple. You just include the list first. So let's talk about the list. And so to create a list, what you do is you just put list, and then in pair of such angular braces, you put the data type what you want. So let's say integer list for now. So let's call it L. And then to add elements, you just say L dot push back, push underscore back, and then you put the elements. So push back, let's say 20, and then L dot push back 30. So by doing this, you will be pushing back all these elements. So you have created a list which has 3 elements, which look something like this. And then if you want to access the elements, it's a pretty clumsy way, but this is how you need to do it. What you do is you create a pointer for this list, and for creating a pointer for such STL data types, you have something called an iterator. So to do that, what you do is you create an iterator for this list. So you put this and then you put two such colons and you type iterator. So this is how you create an pointer for this list for any such data type which is inside STL. And to move this, you do the same thing. So IT will start from, let's say just I. It is going to start from the beginning. So L dot begin returns a pointer to the beginning, and then it has to go to the end. So I is not equal to L dot end. You can do that. So end will again return a pointer to the ending element, and then you can do I plus plus just like how we did with pointers. And then to get the data, you just do star I and then a space. So this will return us the data. So if you now run this, you will be getting the data which you entered. So 10, 20, 30 is the data. We will be looking how to implement this thing from scratch afterwards. But for now, this is how you implement in case you wanted to implement a dynamic list. And to implement a dynamic array, you need to import vector, and vector almost works like this, but you have some feasibility, right? You can work with this like an array. So vector int, let's say vec, and to add elements you do the same thing, vec dot push back and then add the elements. And to access the elements you do same thing like an array. So int I equal to 0, and then I is less than the size, which you can get by vec dot size, and then I plus plus, and you can directly access the elements just like you would do in an array. You put a square brace and then put in the index. So this is how you can access elements in a vector, and this will give you the same result. So that's how you use dynamic containers or dynamic collections in C++, and that's how pointers play a very important role in designing such containers. We will be talking about how to design our own data types and then go to design such collections at a later stage. In this video, we'll learn how to create our own data types using structures, but before that, let's first understand what object-oriented programming is. Now, object-oriented programming or object-oriented programming structure, as it's abbreviated as OOPS, it's nothing but a way of programming. So what we have been doing till now is called procedural programming, where you create procedures. Well, procedures are nothing but functions, and what we have been doing till now is we have been analyzing a problem. We have been breaking down the problem into a set of simpler problems, solving them, and then combining the result to give the output. Now, procedural programming works for almost in every problem, but when we want to generalize our solutions, procedural programming won't work. So let's take an example. Let's say I want to create a student registration program. Now, for student registration, I define a name, I define an age, I define arrays or let's say vectors when the user doesn't know how many records is going to enter, and then I will accept all the records and then save them. So that does the student registration process. Now let's say I want to create a program where it does student registration, but also it will give out some additional information. Let's say it's going to say who is the highest scorer of the class, right? Now what we do is we do all the same steps required for the student registration or the registration to happen, and then we write additional functions so that we can compute the highest score or whatever it is. Now to overcome this problem or to generalize this particular kind of problem solving methods, what we do is we create general objects. So objects are nothing but collections of similarly grouped features. Now here if you observe, student is an object, right? So student has all these features of registration, and then student has marks, age, name, and all the features which are required by a student. And now what you do is you create such an object, or you create a class where all the features are grouped together, and then you use that particular class whenever you want. So if you remember from our pointers video, we have been doing something like hash include vector, where we include our vector class. This is a class where you have all the features defined inside this. Now when you want to use it, you just create one variable of the vector, so you just say vector int vec. Now what we have done is we have created an object of this particular class. It's just like creating a variable or a memory location of this particular data type, but in object oriented programming we refer to them as objects and classes. Now what we do is, in case you want to add some item into this, you just say vector.pushback. So although you have so many methods inside this particular vector, but what you are interested in is just storing. So you just say pushback and then you just put the number you want to insert inside this. So this is how objects work. You don't know what is going on over here. You just know that if you do pushback, it's going to go inside the memory, and you've seen that. So there's a whole lot of code implemented behind this, but you can understand that this particular function is pretty much complicated to implement, and it has been implemented for us. You just need to use it. So you have a ready-made implementation, and you, whenever you want to use it, you just say dot push, and then you can get the function to work. So that's how object-oriented programming helps us to overcome such redundancy. And when we create objects, we generally generalize the object so that it can be used for any type of problem where it involves that particular object. So that's about object-oriented programming. Now there are some technical terms you need to understand. One is data encapsulation. The second one is abstraction or data abstraction, and then third one is polymorphism. We'll be talking about these things in great depth at a later stage, but for now you can understand encapsulation as combining the features. So when you combine all the features which are required by a particular object, that is known as encapsulation. And abstraction is you show only what is required. So here if you see, the pushback function is actually an implementation of abstraction. So you don't know how this works, but what you can do is you can just put in a number and then it goes and sits in the memory. And to use such a function, it is not required to know how it works, so that is abstraction. And polymorphism is nothing but able to use a same thing in different ways. We'll be talking about this at a later stage when we are discussing about classes, but for now this should do, and we'll now get to defining our own data types, or as an object oriented programming we should be calling them as classes. Well, classes and structures are actually different things in C++. Also, they both are literally the same thing. So in the implementation of classes and structures, you won't find any difference between them, but we'll just stick to the convention of using structures only to define smaller objects and then use classes to define somewhat bigger objects. Why these two things are there when these two things mean the same thing? Well, C was not an object-oriented programming language. When C was introduced, it did not have this kind of capability to create objects as I've just discussed before. So what it had is it had a capability to combine two or three data types and then store it as a collective data type. That's what it had, and that's what structure was for. So when C++ was introduced, it was made to be object-oriented programming language. So what they did is they just extended this implementation so that it could hold collections of data types, and also it could perform features which I just discussed before. It can hold functions related to that particular object, or it can undergo inheritance and all those things. We'll be discussing about that later. That is how structure was designed. But when programmers were shifting from C to C++, they did not like this idea of using structures in different ways. And moreover, many object-oriented programming languages which were introduced, they had the process known as classes. So for that, C++ introduced another thing called class, but this is just a history, it's just a convention, but you can use both of them in a similar way in C++, right? So now let's talk about structures, how to use them. Well, to create a structure, you just say struct and then the name of the structure, and we'll call this something, let's say student. Now this is a student class or structure, you can just call it whatever you want. Now this particular class, that is the student class or student structure, this can hold features. Now what all features does a student have? Let's say the student has a name, the student has an age, so int age. And what all can a student have? Let's say marks, so let's say vector int marks. Now this particular structure or this particular class is just like a data type. You can create variables from that. So let's say we want to create a student variable, you just say student and then let's say s1. Now you have created a student. If you want to assign a name, what you do is dot name and then you assign a name. So let's say Tony, and then to assign an age, it's the same way, age equal to 10. And then if you want to assign the marks, it's just like putting it into a vector. So s1 dot marks dot pushback, sorry, pushback 10, and then s1 dot marks dot pushback 20, and all those things. You can almost use it just like you're using, but the thing is these variables are dedicated only to this particular student or s1. If you create any other student, let's say s2, this is a completely different object and all these things don't work here. So if I just say cout s1 dot name, you should be getting Tony as your output. That's because s1's name is Tony. And now if you change this to s2, you will be seeing that it is blank. So as you see here, nothing has been printed. So that's how objects come handy. Now if you want to just use the name of the student, you can just use the name from here and then you just neglect all these things. You don't have to just define the name, define the age and everything. You will have this file somewhere, and then whenever you want to do it, you just say hash include and then student in double quotes. We will be seeing how to implement this in the next video, but you can have this in a different file and then you can include this like this, and then you don't need all these things. You can just say student s1 s2 and then s1 dot name equal to Tony, and this thing will work. So that's how you can define your own data type in structures, or as I told you, this is nothing but a class, and you can have functions associated with it too. So let's say I want to create a function which will give me the average marks of this particular student. So what I do is I will create a function just like I create normally. So void average, and this doesn't take in anything because everything is defined inside. And to work on this particular function, what I do is I just say int sum equal to 0 and then calculate the sum first. So for int I equal to 0, I'll less than this marks dot size, and now this marks are for the particular student. This is not the class marks, but it's for this whatever student I'm accessing. So that marks will be considered over here. And then I plus plus, what I do is sum equal to sum plus that marks I, and in the end I just return sum over total. Now the total is nothing but 3, total in the sense the total number of marks. So marks dot size will give me the total number of marks. Now here I can just call that function and get the marks. So if I just say s1 dot marks dot pushback something, so let's say 10, and then s1 dot marks dot pushback 20, s1 dot marks dot pushback 40, and now if I call s1 dot marks, sorry, s1 dot average, which was our function, now this should return us this average. Okay, that's because there's no student file. Okay, what does this say? Yeah, that's because I've put void over here, so int. And then now if we run this, we'll be getting 23 as our average marks. That's correct because what we have entered is 40, 20, 10, which is 70, and 70 over 3 is 23, so that's correct. So that's how you use objects in C++, and that's how you create your own data type using structures. And here if you see, this particular implementation is actually the example of abstraction. So here the user actually doesn't know what is the actual computation which is going on behind the screens, but he will be getting the average, and this is how you implement abstraction. And the whole thing is actually encapsulation. So here you have combined all the features. This average is a feature of a student, and the marks, age, name, all these things, these are just features of a student, and then you have combined all the features. So this whole thing is nothing but encapsulation. So in the next video, we'll be understanding how to use classes and when to use classes and structures. Well, you can use them interchangeably. There is no restriction on that. It's just by convention. As I told you before, classes and structures are literally the same thing in C++, but it's just that convention matters over here. When you're giving your code to somebody else to develop more, you need to strictly follow the conventions, right? In this video, we'll be looking at classes in C++, but before that, let's first discuss a small concept which I had missed in the previous video. That is how to use pointers when using such collective data types. Here, if you see, we have the student structure which we had defined in our previous video. I have just added one single function to print the details of a student, and here I have created a student with the name Tony, age 10, and then the marks of these things. Now if you want to create a pointer, it's just similar to the way you do for a primitive data type. You just put star ptr and then you put ptr equal to the address of the student. Now if you want to access a particular feature, because in primitive data types we did not have features, right? We just had data. So if you did star ptr, this was enough. But in case of an object, we have so many features. We have two functions and then we have three variables. How do we access these things separately? Well, star won't work here, and we have a special operator known as the arrow operator. Well, what this does, this basically allows us to access separate features of an object, and the way you define arrow operator is by using a minus sign and this greater than symbol together. So if you combine them, that looks like an arrow. So that's from where the name comes. Well, if you want to use it, you just say ptr, that is the name of the pointer, the arrow symbol, and then the feature you want to access. So let's say I want to access the name. So if I just put name and then execute this, I'll be getting a name over here. So age also works the same way. If I just put age and then try to execute this, I'll be getting the age. And if I want to access some function, let's say the average function, I can just do that from here. So if I put average and then call that function, I'll be getting the average over here. So that's how you use pointers. The only difference is that instead of star, you are now going to use this arrow symbol. And this is a very important concept, as we'll see in a minute. This we'll be using a lot when using classes. So now let's dive into classes. Well, the way you work with classes and structures remain the same. So if you want to change this definition to a class definition, you just remove the structure keyword and then put class over here. So this now becomes a class. Well, the dot operator and then the way you work with pointers, this arrow symbol, all these things remain the same. So you don't have to do anything. So now let's do something like student dot print details. Now if we try to execute this particular function, we will be getting an error. So let's see what that is. It says that this particular name is private. Well, if at all there is any difference between a class and structure, that is this thing. A structure is public in nature and then class is private. Well, this is not a big deal. We can change public to private and private to public. We'll just talk about that in a minute. But what is public and private? Well, in object oriented programming, when you're creating objects or when you're creating such collective data types, we don't want everything to be accessed by the outside agent or the user, let's say. So if we are creating a student data structure and the purpose of this particular data structure or this particular object is just to store the details and then show the details, then you don't want the user to manipulate the details, right? So if I give the access of this marks to the particular user, he can manipulate the values inside, right? So same with the name and age also. So if you don't want some of your features to be public in nature, that is you don't want some of the features to be accessible by the user, you can put them in the private section. So how do we put that? You just need to put private over here and put a colon over here. So in a class, everything by default is in this particular definition. So if you want to make a structure into a class, you just need to remove this class and put structure over here. Now this particular entity is just like a class. You will be getting the same error when you executed a class. And if you want to create a class into a structure, if you want to change a class into a structure, what you just need to do is you need to change everything to public. Now if you change it, you will be getting the output just like we got in case of a structure. So that's why I told there is no difference between a class and structure. Although we don't use such access specifiers, these are called access specifiers because they are specifying the access of these features, right? So we don't use them in structures. That's just by convention you can use them. There's no restriction on that, but we generally don't use them. We just use them with classes. So can you have multiple access specifier inside a class? Well, you can. So these just define different features to be either public, private. So there's one more thing called protected, which we won't be seeing in this particular video because we'll better understand it when discussing about inheritance. But for now, we'll just discuss about public and private. So as I told you, these things become private and I want only the print details function to be public, so I'll put public over here. So whatever is below private becomes private and whatever is below public becomes public in nature. Now I can access print details without any issues, but I cannot access all these things. Then how can I actually create an object with these features? That is, I want the object's name to be Tony, age to be 10 and marks to be these things. How do we do that if I don't have the access of this variable itself? Well, for that you can define another function in the public section. You can say something like void set detail, something like that. These are more specifically called setters. These are called setters, but setters are used only for a single variable. So if you want to assign variables at a time when creating the object itself, you generally use something called constructor. Well, constructor is basically a special function which is used to create the memory when you're creating an object of this type. So let's say you're creating an object of this class student, you need memory to hold these three variables. So constructor takes care of that particular memory requirement and you don't have to explicitly define a constructor, although you can. And many people use constructor to assign variables when you are declaring them. So in our case we are declaring these variables, right, which are private in nature. So in case you want to declare them while creating, you can either use a setter function or many people just use constructors for that. So the way you define constructor is it doesn't have a return type, so you just need to omit the return type. You should not give any return type, and then the name should be the same name as the student. So over here you have student as our class name, so that should be there, and then you will just define it just like a normal function, and here you can pass in parameters and all. You have different names for that. So if you have a normal constructor definition like this is called a general constructor, and then if you have parameters inside that, let's say string name and then int age, so this is called a parameterized constructor. There are different names, I encourage you to look that up, but for now we'll use this particular parameterized constructor, and here we'll pass in another variable, the marks variable. And now there is an issue. If you see the object's attribute or the object's feature called name is clashing with this particular name. Well, you can change it so that you don't have an issue like this. But as I told you when discussing the pointer just now, that's going to play a very important role in classes, and that is where this comes into play. This is basically pointer. it is called this pointer only. So if you just put this, you can see that it is bold. It indicates that it's a property of the compiler. It's a reserved keyword. This is basically a pointer which will point to the current object itself. So let's say I have 10 students and then I'm working on the seventh student. So if I use this pointer, then I will be accessing the seventh student details, not any other student details. So this basically points to the current object which is getting used, and then we use it just like we did in case of our pointers. So this and then this particular arrow symbol which is called the arrow operator, and then the variable name. So name equal to name, you could say this age equal to age, and then this marks equal to marks. Well, if you don't want to use this particular definition, you can always rename this and this won't be an issue. But just to explain the importance of this particular pointer and this arrow operator, I just took this particular example, but you're free to use whatever way is convenient for you. Many people tend to use this particular definition, and here when we are creating, you just need to pass in when creating itself. So here if you put parenthesis and then pass in your variables, so name equal to Tony, and then the age is something 10, and then the marks, well, you need to create another variable for marks, so marks, and we'll push back all these things inside this particular new variable. You don't need s over here because this is an independent variable. Now we just created a new variable in our memory, and here you just need to pass in marks. And now if you just remove all these things, this should work as expected. So if you now run this, you will be getting the output just like we got in the case of structures. And now you have successfully implemented an object oriented design. So something is private, something is public, you are not giving access to everything, and all these are basically features of object oriented programming. So now let us see another very important function, which is a special function called the destructor. Well, this is not used much, but since it's a part of object oriented programming, we'll discuss it quickly. It's basically the same thing as a constructor. It is defined by the compiler itself. It's a default thing. A destructor, what it does is it will scrape out the object from the memory. So if you're running out of scope, so let's say we had defined this object inside an if block. So once the block has been executed, that variable is out of the scope, right? So once anything gets out of the scope, it's going to be scraped out of the memory. So that's when a destructor is called. So if you want the destructor to do something else, you can just do that by putting this type symbol, and then you define the destructor with the same name as a class. And again, you don't put any return type for the destructor, and it does not even take any parameters. So you cannot pass any parameters to the destructor. You cannot call the destructor from anywhere. You can just see what it does. So if you just call this destructor, let's say I'm being scraped, something like that, you will be seeing this when the object gets out of the scope. So we'll just put something over here. If some condition 10 equal to 10, this is going to be true, so all these things will be executed. And over here we'll put something like done. We'll put a new line also so that we can differentiate. So if you now execute this, you will see all these details, and then it says I'm being scrapped and then done. That is because once the if block has been executed, that particular object has been removed out of the scope, that then it should be ready to be removed out of the memory too. So just remove that thing from the memory. That's why this message is printed, and then you have this done, which is outside the if block, which indicates that this has been scraped before coming over to the statement. So that's the use of destructor. If you want to see when the object is getting removed from the memory, you can use destructor. We will again talk about this when we are discussing about inheritance, but constructor is mostly used to actually pass in parameters when we are declaring a particular object, something like this. So now, how do most people use classes in C++? Well, mostly people don't use classes in the way we used over here. We wrote the class definition and the main function, everything in a single file, right? So people generally don't tend to do that. People generally use multiple files in their program. So you have one particular file only executing the main program, and then you have multiple objects, so you don't put all the objects in a single file. You create multiple files for holding the objects, and then if you want to use this particular class, let's say the student class, you just include it just like this particular vector. So what you do, include, and then you put the student over here, student dot h, that's an extension. We'll be saying how to create this, and here instead of angular braces you need to put this quotes. So this indicates that this is something from this particular directory and not from the compiler. So these things are available in the compiler, that's why we are putting this angular braces, and here you are putting this to indicate that this is from this particular directory or this particular project. So you have two files when declaring such classes. So what you do is you have one header file where you declare the skeleton of the class, and then you have one CPP file which is just like this one, which will hold the definition of this class. So how do you separate that? So let's say I want a particular function to be defined in a separate file. So let's just say this particular function called to be defined in a different file. So how do we do that? You just need to put a semicolon over here. So this is just like a function prototype which we had discussed, and let's assume that this is another file. So this class is in some other file. You just did something like hash include student.h, and then if you want to define this particular function, the way you do that is you just define this function normally as though this is just a normal function. It doesn't have anything to do with this class. You just define it. So let's say uh, I'm called and something like that. You just define it like this, and then over here to define that this particular function is specifically designed to this particular class, or this function should be available only to this particular class. What you do is you just put in this particular class name, and then you put two colons over here. So this will indicate that this particular function is to be used only with this class, that is the student class. Now you cannot use call directly, you need to call it using the student class. So if you want to use that, so you can say something like s dot called, and it will work normally. So that's okay. We don't have the student.h right now, so we don't need these things also. So if you run this, okay, there's another typo over here. Okay, so here you can see I'm called, that is from this particular function which we just defined, that this called function over here, and here this is the message from the destructor, that is I'm being scraped. So that's how we actually use classes, but this particular ID, which is the code blocks ID, provides a easier way to create classes. You don't have to define all this text. That is, you don't have to create two files and then put them. It will neatly organize everything and give it to you. So how do you use that? Well, you go to file, you go to new, and then you create a class over here. So you have class name. So you just give some name, let's say student, and then here in place of arguments you just leave it. So it has hash destructor, virtual destructor, all these things. You don't have to understand all these things right now, you can just ignore them, but we'll understand what all these things are in later videos. And now if you just click on create, you can see that the new class has been created. Do you want to add it to the current project? If you just say yes, and then you just put OK over here, and then you will see that in headers you will have an include folder inside which you will have student.h. So here if you see, it just has the definition. Let me just increase the font size. Here you can see it just has a definition. You don't need this. This is basically the virtual destructor. We'll talk about that later. And here you have a constructor, and you have protected and private. You don't need protected also. As I told you, we'll be discussing about that when we are discussing inheritance. And you have some special commands over here. So what this roughly means is that once a particular class has been included in the memory, and if it's again trying to include it, you don't do that, because we are using two files. So let's say I'm using a function from this particular file. So when I don't want this particular function to again include it, so here you can see hash include student.h. So when I'm doing it multiple times, I don't want this particular class to be loaded into my memory multiple times. So this particular guard block, as it's called, this is called a guard block. What this will do is it will take care of this particular issue. It won't allow this class to be included in the memory multiple times. And here you just declare the skeleton. So here if you see, if you want to create this particular class again, we'll just create a small version of that. So it will just have a age, let's say int age, and in public you will have a setter function. You will just say set age, or you can just directly use it inside over here. So int age you can just say, and private, I prefer private to be in the beginning, but it's up to you. The order doesn't matter. I just put private in the beginning and then public at the end, protected in the middle. So that's how I use classes, but it doesn't matter, you can use it the way you prefer. And now you just need to define this constructor in the student.cpp file. We don't need this virtual constructor, I just deleted that. And here you just define it normally. So age is something private, but you can access private variables inside a class. So you can say something like this age equal to age. And here if you want to use this class, let us just remove this class because I've already defined it. So remove this, and if you want to include that student class, you just say hash include and then student.h. And now all these things work fine. Well, we don't have everything over here, so we need to redefine it. So let's quickly do that. Student s10, and if you execute this, what do we have here? It says, yeah, because we forgot to put the parameter over here, it is int age. And see, we did not get any error. So that's how we generally use classes. If you want to create another class, go here, new, and then class, and you can create another class. So people generally tend to use classes like this. You have neatly structured thing over here. So you have a main.cpp over here, and here the student.cpp goes inside the source file, so that you don't get confused. So everything, the header files which I talked about, the student.h or anything class, header files are basically class name dot h, and all these things go inside this include folder, and the definition file, which is basically class name dot cpp, all those things go inside the source folder, and main file will be outside. And you can use that main file to execute the program. Everything starts from the main file, generally name that as main.cpp, where the execution starts. And we include all our objects like this using this particular syntax, that is, you pass in the class name dot h file using this particular codes. And the guard block which we just talked about, this one, this basically takes care of multiple allocations of memory of this particular class. So that's all about classes. In the next video, we'll make another one of our projects. So our previous project was the tic-tac-toe game. Well, we'll again make another game in the next video, because I think games are fun to make and then we can learn a lot from them. In this video, we'll be making our second programming project, which is going to be this, the snake game. So I'm sure everybody knows how to play this game. You have a snake which grows on eating the food, and the objective is to grow the snake as long as possible without hitting yourself or hitting one of the others. So if you do any of those, you lose this game. Well, there are different variations of this game. Some have teleportable walls, that is, if you go through this wall, you end up coming from there. And some versions even have obstacles in between them instead of this free space. But we're not going to do any of those. We are just going to stick to the simple version with four concrete walls and empty space in between, right? So let's get started. Let's create a new project. It's going to be a console application, and the language is C++. Project title, let's say snake, and these things remain as it is, right? And Now let's first start by defining the board. So if you remember from our previous project where we made our tic-tac-toe game, we had defined a 2D array or a matrix to hold the board, right? But here, if you see, you don't need that. Why? Well, in the previous game where we made the tic-tac-toe game, the board only had 9 elements, and we were concerned about all the 9 elements of the board, right? So we were concerned about what all the board contained. But here you don't have to actually be concerned about all the elements of the board. Here the board just acts as a background. The only things you are concerned about are the position of the snake, the position of the fruit, and the position of the wall. So other than that, you don't need to keep a track of other things. So here we are just going to print the board just like we print something on the console. So let's define a function for that. Let's say void board, and here we are going to draw the board. So let's first define the dimensions of the board, the width and height. So let's say the width is going to be somewhere around 50 characters. So since we are working on the console, you are going to see everything in terms of characters, or this is basically a substitute for pixels if you are familiar with graphics. And the height is going to be somewhere around, let's say, 25 characters. Now these two things are constant, right? So these won't change throughout the project. So if you want to make them as constant, so you can just say const over here. So this keyword will make these things as constants. And now I would like to introduce you the concepts of macros. So macros, let me write it down here. Macros, these are nothing but one-liner code, right? So let's say you want to define a function to calculate the square. So what you do typically is you write something like this, right? So int sq, and this will return x into x, right? So this is how you define a small function. But what you can do is, instead of defining it as a function, you can define it as a symbol. So when I mean symbol, what I mean is if I type that particular symbol, then this operation should be performed. So that is what a macro does. So the way you define macro is you put hash define and then you put the symbol. So let's say sq over here, and inside this whatever parameters you want to pass without any data type. So this is basically a symbol. And here you want to define the operations. So here our operation is x into x, so that is basically going to return as the square of a number. So here you don't have any assignment operators or return operators. All this means is whenever I say sq of x, it should do this particular operation. So if you say something like sq of 5, and here if you run this, you should be getting the output as 25. So that's how you use macros, and you can do the same with these two variables also. So the way you define it is hash define width is 50, and hash define height 25. So now whenever I say width, I mean 50, and whenever I say height, I mean 25. So now you can remove this, you don't need this anymore. So now the board is going to be two loops. The first loop or the outer loop is going to control the number of rows. So here the number of rows is defined by height, right? Because height is basically how down you go. So that is how many rows you have in your board. So I is less than the height of the board, and I plus plus, and inside this you will control the width. So let's say j equal to 0, j is less than the width, j plus plus, and inside this you are going to print something. So here if you observe this board, for every row there are two wall pieces, right? So every row starts with one wall and then ends with one wall. So since the default, you can subtract 2 here and then put those two characters. So you have one wall in the beginning of a row and one wall at the ending of a row, and then you go to the new line, and inside this, basically if the row number is 1 or the row number is height minus 1, that is if you are printing this row or this row, then you need to print all walls. So here we are just going to print out these hashes, or else you need to print out the empty space, which is basically this space, right? So now if you call your board function, that should print a board for us. So here we have the board. Now this board looks pretty squished to the left, so you can take care of that by adding a couple of tabs, and that will center the board. So now let's see how to animate things on the console. So if you're familiar with graphics, or even if you have heard about animation, you might know that animation is nothing but just fast moving pictures, right? So here if you want to animate something on the board, let's say you have some object on the board, then the way you animate is you will quickly move the position of that object and it will appear as moving. So to move something on the board or to place something on the board, you need to know about the coordinate system which the computer uses. So let's talk about that quickly. So you might have come across this Cartesian coordinate system in your math class, right? So you have a coordinate system where if you go right, the x coordinate increases, and if you go vertically upwards, your y coordinate increases. And this position, basically, which is the intersection of these two axis, this is the origin, which is defined by this 0 0 coordinate, right? So this is the coordinate system you all have come across in your math class. Now what happens in a computer is this origin is shifted to this top left corner. So let me just clear this thing. So in a computer, your axes are defined as follows. So if this is the top left corner of the screen, that is this position where I'm pointing my cursor, that position is basically your 0 0 position. So this is your origin in a computer, and as you go right, your x coordinate increases, and as you go down, your y coordinate increases. So basically your y axis is flipped in case of a computer and x remains the same. So as you go up, your y is decreasing, and as you go left, your x coordinate decreases. So that's how the coordinate system in a computer is defined. You can use this coordinate system to move objects in your screen or even place objects in your screen. So every object is defined by a x coordinate and y coordinate. So if you put some point here, so it has some x coordinate, that is how much it has moved from the origin in the horizontal direction, and some y coordinate, that is how much it has moved from the vertical direction, right? So this is how the coordinate system of a computer is defined, and we will be using this system to operate on our board, right? So let's define an arbitrary object somewhere. So let's say our int x, which is the x coordinate, is going to be somewhere around 10 characters, and y is also 10. So that means that this is 10 characters from the left and then 10 characters down. So it will be in some arbitrary position somewhere. Let's just see where it is. So if I print that particular object, that is pretty simple to print. So if the coordinates match, you are going to print that object. So how do you do that? Well, I is controlling the height, right? So height defines how deep you are on the board. So that is basically the y axis. So you need to compare I with y and j with x. So if these two coordinates are equal, then you can say that your object is at that particular position and you can print something. So let's go with this 0 for now. So that is going to be our object. Now if I try to print this board, you will be getting your object here. So and this is 10 characters from the left and 10 characters towards the bottom. But if you see, this position is exactly not as a square as expected. That is because in console the next line has some gap, if you see over here. So this gap is much bigger than this gap. That is why it doesn't end up as a square. But if you're using some graphics library, then this will work. So it will exactly be as a square. So it will end up somewhere over here. So this could be the 10 comma 10 point. But here, since we are working on the console, the y-axis is much wider, or I should say much deeper than the x-axis. So even when you animate your snake, it's going to move faster on the vertical direction than on the horizontal direction. That's actually not a logical error. That's because of the property of console. You cannot do anything about that, right? So if you're using any graphics library, then that problem won't be there. So now let's see how to animate this. Animating is very easy. You just need to move the board, right? So let's say I will create an infinite loop here, and inside this we'll first call the board, and every time this loop runs, we'll just increment the x coordinate. So when you increase the x coordinate from this coordinate system, your object is going to move towards the right. So now if you run this program, you should be getting some kind of movement. So here you can see that this O is moving towards the right, but you cannot actually see it as a movement. This is basically, it is just printing the board again and again. So if you have some way to update the board, then you can see the movement. So one way you can update is you can use your console command. So if I pull up my console over here, this is basically a PowerShell, but in Windows, or if you're using this code blocks in Windows, it's going to use your CMD as your default console, right? So in CMD, the command for clearing a screen is CLS. So if I type something over here and I type CLS, that thing is cleared, right? And if you're on Linux, the command for clearing is CLAR, and the way you pass in such shell commands or such console commands are, you include another library called CSTDLIB, which stands for C Standard Library. You might have come across this while making our tic-tac-toe game. This is the library which had our random function, and we will be using that random function in our code as well, right? So here, to send commands to the console, you use system, and inside this you write the command. So in my case, it is the Windows operating system, so I write CLS, and in case you're on Linux, you need to write clear, right? So let me just comment this thing. If you're on Linux, you need to write clear, and I forgot the semicolon. And now if I run this, I should be getting a movement, but if you see here, it kinds of flickers on my screen, right? So this board is getting updated, but it is annoying to see. So this you cannot actually control. So more technically, if you know about the FPS or the refresh rate, so you cannot control these things of a console. Console is not a property of the language or this ID, right? It is a property of the operating system. So you cannot control something from an external source which belongs to the operating system. So one way you can take care of this flickering is, instead of clearing the screen, this is happening because it is doing two processes, right? First it is clearing the screen, and then again it is drawing the board. So if you just overwrite the board as we used to do with our normal line. So if you remember from our escape sequences video, we had talked about an escape sequence called /r, right? So if you write something over here, let's say hello world, and here if I put /r and I type something else, so AS, then the first four characters, which are these four characters, are going to be replaced by the word AS. So now if I run this, I should be seeing ASO world. So that is because HELL has been replaced by this. That is because this /r will take the cursor from the end of the line and place it in the beginning. But we cannot use the /r over here. That is because we are using multiple lines, right? So you're printing around let's say 25 lines, because the height is 25, so you're printing 25 lines, and there is no escape sequence to get your cursor back a line. So /n will move your cursor down a line, but you cannot go up a line, right? So for that, I'm going to tell you a solution, but this is going to work only if you're on Windows. So let me write it down here. This is only for Windows, and if you're Linux, you need to find out a library which does that. So basically, what we're going to do is we're going to pick up this cursor from the end of the screen, and we are going to go all the way up to the origin and place it back. So if you do that, instead of clearing the screen, you're moving the cursor, and when you print your data again, it's going to be overwritten on the console. So it looks like it has been cleared, but actually it has been overwritten instead of clearing. So this solution, what I'm going to give you in this particular video, will work only if you're on Windows. So if you're on Linux, you need to find out some library which will do that for you, right? So if you're on Windows, you need to include a library called windows.s, which will basically allow you to control the cursor's position on your console. And here what you need to do is, instead of system clear, you can do set console cursor position, and here you need to give some handle, which is get std handle instead of std output handle. So if you don't understand what this means, it's okay. It's just, you can think of it as it's going to pick up the cursor from the end and it's going to put it back on the origin. And to put it back on the origin or any specific coordinate, you need to pass in a coordinate data structure. Well, coordinate is basically a simple data structure which is already defined in windows.h, and we will be using this. So if you're on Linux and you're using some other library to achieve this, you need to define this structure to follow along with this tutorial, which is basically a simple structure. It is something like int x and y. So this is the structure which is defined in Windows. So I'm not going to define this again. It's there in this windows.h, and that's what we are using over here to send the position to our handle, which will basically take the cursor from this position and then put it back to the origin. So the origin's coordinate are basically 0 0, so you need to pass that in. And now if you see, you won't have any flickering screen. You will have a neat animation going on your screen. So as you can see, there is no flickering, although you can see that cursor updates somewhere, but this is much better, right? Instead of the flickering screen. So again, this solution is only for Windows users. So if you're in Linux, you have some other libraries like you have N cursors and many other libraries. A simple Google search will get you what you want, right? Now, let us remove all these things. We have now understood how to do animation, and here what we are going to do is we are first going to define our snake. So go to File, New, and Class, and the name of the class is snake. And you can remove all these things, right? It doesn't really matter. You don't need destructor on all these things. We'll create if we want to, right? And here just click OK, and in snake.h we have this template code. So again, I prefer private to be on the top. So if you want that, you can follow this, or if you're okay with the structure it has given before, you can follow that too. It doesn't really matter. And here, first of all, we are going to decide what is going to be private and what is going to be public. So what are the features that we need our snake to have? First of all, it will have a position, right? The position of the head, to be precise. And next, it should have a length to define how long the snake is. And you also need a direction, and you also need a velocity, or you can say speed of the snake, so how fast it moves. So here, in case of velocity or speed, we are going to talk in terms of number of characters. So let me write it down here. That is basically, it is going to move 2 characters at a time, 3 characters at a time, and so on. So in case you're working with some graphics library, that's the same thing you do with pixels. So you say 3 pixels at a time or 5 pixels at a time. And since here we are on console, we are going to talk everything in terms of number of characters, right? So here, let me define the private variables. First thing is, you are having to have a position. So it's going to be quad position. So again, if you're on Linux, you need to define the structure. And for using this quad, you need to include windows.h, right? So this is because this is a separate file, right? Snake.h is a separate file. So even if you are included in main, you need to include it again, but you can exclude this over here, because once we actually include this file, you're going to include all these things. It doesn't matter even if you keep it twice, because of this guard block. As I had explained before, this guard block, what it does is it takes care of multiple initialization. So here, as I've already included windows.h, now when I do hash include snake.h, it will take care of the fact that I've already included windows.h, so I don't need to include it again. But here, if you want to use these things, you need to definitely specify that you're using windows.h, or else you cannot use this and it will throw you an error, right? And here you need a length of the snake, and you have a velocity, so int vel, and you have a direction, so let's say char direction. And in the public section, we need to define constructor first, and this is going to take a position, that is the initial position, and initial velocity for our snake. So let's define this constructor and snake.cpp. And here you need to again specify those things. So chord position and int velocity. And here you don't have to include windows.h. That is because again you are including snake.h, which comes with windows.h, so you don't have to include it again. And here you need to set the position and velocity. So since I'm using the same name for both the variables, I need to use this pointer. So if you are not using the same name, it's okay, but if you are using the same name, you need to use this pointer. And the velocity also goes in the same way. And initially the length is going to be 1, that is because you have one head, right? So without the length cannot be 0 because you always have a head for the snake. So the length is going to be 1 initially. And the direction, so the direction you can say something like none, right? Because the snake is not moving now. And we'll have a method to change the direction of the snake. So let's say uh, change dir, which will change the direction. It will take some direction to change it. And here let's define that method. It's void snake change dir, char dir. And what you need to do is direction equal to dir. Basically I'm just setting the direction of a snake. And for moving the snake, let's create a move method or move snake. Well, move is basically a defined method in C++, so it's not preferable to overwrite it. You can overwrite it, you can define something like this, but it's preferable not to overwrite any uh, default method. So let's say move snake, and this is not going to take any parameters because it's just going to perform something. So void snake move snake. And here what you need to do is you need to switch the direction. That is basically you need to move the snake in that particular direction. So switch direction. And here you need to put different cases. So in case it is going up, then what you need to do, refer to this coordinate system. You need to decrease the y coordinate. So what we're going to do is pos dot capital Y minus equal to the speed. So basically if I say that my snake is moving 2 characters per second or 2 characters per iteration, then I need to subtract those many characters, right, to move, to appear to be moving in that much speed. So that is why we are going to subtract the velocity over here, or speed, you can name it whatever you want. And here the break is mandatory. And will be true for all the 4 directions. So let me just copy it down 4 times. And it's going to be up, down, left and right. Right is you need to increase your velocity, left is you need to decrease your velocity, and for down you need to increase your velocity on the y coordinate. So this will move your snake in your preferred direction, and that should be it. So now you have a snake, you have initialized it with some initial position and velocity, and you have a method to change the direction of a snake, and now you even have a method to move the snake. And here, since we need the position of the snake to draw it on the board, you also need a method to get the position. So let's say quad get pos, which will return the position of the snake. And this is going to be return pos. And I forgot to mention snake here. This will be declared as a normal function. If I forgot to mention this basically means that this get pos function is related only to the snake class, right? I'm sure everybody knows this. And here we'll quickly define a prototype for that. It's quad get pos and done. So now you have 4 methods. Let's go over it quickly. One is a constructor which will initialize our variables. One is a method to change our direction. So change direction of the snake. And one is to move the snake in that particular direction. And one is to get the position of the snake, or I should say get the current position of the snake. So now let's use this thing in our main file. So you here, as I told you, you can remove this windows.h because it is going to be included with snake.h. And here let us first create a snake. So snake s, let's say snake. And inside this, let's say it's going to be initially in the middle of the board. So that's basically 50 by 2 and 25 by 2, or you can say width by 2 and height by 2. That makes more sense, right? So width over 2 and height over 2, that is basically the center of the board. And velocity, let's say it's going to be 1, that is one character at a time. And here, you instead of y and x, you need to capture the position of the snake. So chord snake pos, you can say, equal to snake dot get position. And here, instead of y, you need to say snake pos dot y, and instead of j, you need to say snake pos dot x. So far so good. We have created a snake which is going to be on the middle of the board and which is going to move at a speed of one character at a time. And here, let us just clear all these comments. And now let's see how to get input so that we can control the snake. So you need to move the snake only when you press something, right? So here, how do you capture that keystrokes? Well, you have a library to do that, so that is called Conio, or I should say console input output. And here you can just do the following. So if you say if kbhit, so kbhit stands for keyboard hit, so it will be true if you hit a key on your keyboard, not necessarily enter key. You can hit any key on your keyboard and this is going to evaluate to true. And to capture your key, you need to say get ch. So get ch will basically give you the key which you have just pressed. So we'll capture this, and instead of capturing this, we can switch this so that we don't have to write couple of if statements. We can just say switch get ch, which will basically give us the key, and here you can control it. So let's say up. So I'm not going to do it for the arrow keys because I don't really remember the ASCII values of the arrow keys. So if you want arrow keys, you need to give the ASCII value. So let's say 132 is the ASCII value of upper key. It is not the case, I'm just saying. But if 132 is the ASCII value for the up key, then you need to give something like this. But I'm just going to go with WASD for now. So case W, then what you need to do, you need to move the snake upwards, right? So snake dot change the up, sorry, u, and then break. And you need to do this for all the four directions. So control C, V, 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 W, A, S, D, and D is basically go to right, S is down, and this is left. So now this will move a snake in our preferred direction, and to move the snake, you just call snake.move snake, which will move a snake. And now if you run this, you will be getting a snake which can move on your command. So now you can see that it is not moving because initially we had set the snake's direction to be n, right? So we did not have any case which will move the position for n, so it doesn't move for any iteration. And now once I press W, you can see that it started moving up, A it started moving left, S it started moving down, and D it started moving to the right. So now I can control this little character and keeps moving, right? So that is how the snake game is defined. So once you press a key, it will keep moving in that particular direction until you change the direction. So this is what we needed, and we got a moving character on our board. So now let's see how to first generate the food and calculate the points, and then we'll talk about how to increase the snake's length once it eats the food, right? So now let us just close this and talk about the food. So again, you need to create another class for generating the food. So it's going to be, let's say, food, and again, you don't need the getter, setter, or the destructor. So create it, yes, okay, and here you have food.h, and again I don't need these things. So here in the private section, what we're going to do is we are going to have a position of the food, right? So that is mandatory. You cannot have any object without a position, right? So for the position, you again need to include windows. So windows.h, and it's going to be chord pos. And you do need a velocity. Well, you don't need anything else. You don't need velocity, you don't need any direction for that food. It's just going to be a point where if you go over to that point and then eat that food, you're just going to generate another food. So basically you don't need anything else. And in the public section we have a constructor. Basically, well, you don't have to pass anything to the constructor. It's basically going to initialize this position with some random value. But if you see this game, always this food starts at this particular position. If you want something like that, then you need to define a initial starting position. So as we did for our snakes, you need to do something like that, but we are going to go with random initialization right from the beginning itself. So again, for random function to work, you need to include cstdlib, and we are going to define a function called genFood. This is basically going to generate our food, and this is going to be a void. And we also need function to return us the position, so it's going to be get us. So this will return our position. So let's define these functions. Inside this, what we're going to do is just generate food. Right, first time it's just going to generate the food once you create it. And for generating the food, food gen food. And what this is going to do is it's just going to generate two different random numbers in some range. So if you remember the formula for generating a random numbers in the range, that is u to l, it was basically rand mod u minus l plus 1, u minus l plus 1 plus L. So this was the formula for generating a random number in a range. So here our upper limit is going to be, for the x-axis is going to be width, and the lower limit is 0, right? So here you just need to say rand mod and then u minus L plus 1 plus L. So for us, the u is basically width minus the lower limit. Now lower limit, if you keep 0, then the food will have a chance of getting generated on the walls of the board. So you don't want that to happen, so it's going to be 1 and plus 1, so these two cancel out. So you just need to say rand mod width and then plus L, which is 1. Again, for the y-axis, the upper limit is going to be height and the lower limit is again going to be 1. So this will generate a random position for our food, which will be on the board. And for getting position, it's very simple. You just need to say pod food get position. So we did not define that. Well, we did cod get position, and here you need to say return pos. So this will return the position of the current food. And that's it for food. So we need to include that also over here in our main file. So here we need to say hash include food.h, and here we don't need cstdlib again because we have defined it inside this food.h, so that gets included automatically. And here we need to create a food object. So below the snake, let's create a food. So it's going to be food. And as a constructor, it doesn't need anything, so you can just put it like this. And here we need to check whether the snake has eaten the food or not. So for that, what you can do is you can have a function inside the snake which will check whether its coordinates have matched the coordinates of food or not. So what you can do is you can, inside the snake.h, you can define another function called boolean, let's say eaten. This will basically say whether the food has been eaten by the snake or not. So you can just pass in some coordinates inside this, that is the coordinates of the food. So coordinate food, it's a food pos, and we'll define it inside snake.cpp. It's basically bool snake eaten, and this will return true if the coordinates match. So if I say if food pos, well, I did not capture it over here, so it's called food pos. And if food pos dot x is equal to pos dot x, and food pos dot y is equal to pos dot y, that is basically if the position of the head and position of the food are equal, then it means that the food has been eaten by the snake. So then you need to return true, else you just return false. So this means that if you eat the food, it will return true, and if it didn't eat, it will return false. And in main, you can use that over here. So if you can say snake dot eaten, and you can get the food's position. So food dot um, get pause, and this will give you the position of the food which you can pass into the snake. And if the snake has eaten, then you need to generate another food. So you can say food dot gen food, and you also need to increase the length. So you can say snake dot length. Well, length is a private variable, so let's say snake dot grow, and we'll define a function to grow the snake. So you can say void grow, and we define it as void snake grow, which is length plus plus, and this should grow our snake, and that should be it. So now you have the logic for eating a food and then growing the snake. Well, we are not going to see the snake grow, but it is just going to grow in numbers. We won't be seeing that visually. We'll see how to deal with showing that visually, right? And here we forgot to draw the food, so here you need to put that. Else if our I is equal to food pos dot y, and j is equal to food pos dot x. Well, I did not capture that, so quad food pos equal to food dot get pos. Then for food, let's say the star, right? The star works well. Now if you run this, we have an error. What does it say? It says that width and height were not declared in the scope. Now that is because in food.h we did not define the width and height, right? We had defined it in the main.cpp. So you need to copy these two lines here. So control C and put it inside food.h. That is because we are using those two, right? We're not we did not define it in food.h. That is why it was giving an error. And now if you run this, we have another. It says has no member y. That is because this is a capital Y. And here you have the snake and the food. So here you can see the food. So if I eat that food, it's going to generate another food in some random position. So you can see that generated over there. And here we did not write the logic for collision, so we'll take care of that afterwards. Well, it's going to be in the same places. That is because we did not seed the random function. So if you have seen the previous video where we made the tic-tac-toe game, you know what is seed is. Well, to seed the random function, what we're going to do here is we're just going to say in the main function. So to seed the random function, what we're going to do is hash include seed time, and here in the main function we'll say is and time null, right? So now when you run it, you will have a snake and food, and this food will be generated once you eat it. So here I ate that food. Now you can see that another one has been generated, and then another one has been generated. So we did not write the collision logic. So if you go through the wall, you won't come back, and that will take care now. So to do that, what we are going to do is we are going to write another function. So it's going to say pool collided, and it's property of the snake. So snake collided, and this is going to just return true or false. So this is going to return true if our position of x is less than, let's say, 1. So that is because at the 0th position you have the wall, right? So if it is less than 1, it means that you have crossed the position of 1, and you have crossed the wall. And in case your x is really greater than height, then it means the width, then it means that you have crossed the other wall also. And similarly for the y, you need to say it is less than 1, or position dot y is greater than the height, then you need to return true. It means that you have collided with a wall, or else you return false over here. So We forgot to define the prototype, so here it is going to be bool collided. And in main function, instead of true, we are just going to maintain a variable called game over, which will track whether the game is over or not. So in the beginning, game over is false, and while true, you will change it to while game over, or while not game over. You need to run all these things. And if the snake collided, so if the snake collided, then you will just say game over equal to true, and this will stop executing the loop, right? Now if you run this, we got an error. Does it say again the width and height are not defined in snake.h? So we need to copy those two things from here and put it over here, right? Now if you run this, you don't have any errors hopefully. And here you can see that the snake moves, and if I go and hit the wall, it ended the process. So now the game ends successfully once I hit a wall, and we have taken care of the food also. So I think that the video has become long enough. It has been an hour. So the next video we'll see how to increase the snake's length and show it visually. Well, we are increasing the snake's length over here, but we are not showing the increase in its body, right? So we are just moving the head and we are eating the food. The previous video we were making our second project, which was a snake game, and we made quite a progress, right? So let's see what we have made. We have made this board, and then we have updated the board without causing any flickering, and that's a great improvement. And we have also animated this character which can eat the food, and we have also written the logic for the food to appear at different random locations, right? In this video, we'll complete this game by adding the body for the snake. Well, you know that the snake is growing while eating the food, but it's just growing in numbers, right? We're not showing it visually. So we'll be showing that. And also before that, let's just fix some logical errors which were made. Right? So let's see what are those errors. So let's just try if one of the error pops up. Well, I'm turning unlucky, but just to save the time, I'm just ending this game here. And let's first talk about the most obvious logical error. So, in the definition of food, what we have said is once a food is created, I want a random location on the board which will be the location where our food is placed, right? That's what we said when we are calling this generate food function inside the constructor, right? But what is happening here if you run this program again and again? So let's run this once again. So here you will be seeing that the first food is over here, and if I close that, run that again, you will be seeing that the second time also the food is over there. But the consequent foods are getting randomized. So if you see the second food is somewhere over there, and if I start this game again and try to eat that, you see that the second food has been generated at some random location, right? The first one was somewhere over there. So to fix this, well, you can go with it. It's not actually an error. It is actually not what we wanted, right? It's basically what I did not want. But if you wanted that the first food should be generated like that, you can go ahead with this and skip this portion. But since we wanted to generate the food at a random position right from the beginning, what we are doing wrong is here first we are generating the food object and then we are setting the random function, right? So if we were introduced to the random function and the seeding function back in the tic-tac-toe video, right? So if you remember, the seeding function is a kind of controller to the random number generator. Well, the random number generator will generate some random number. It will do some calculation and give you a number when the program is loaded onto the memory, right? So if you want a different random number, what you need to do is you need to close everything and then open it again. Well, we don't want to do that, right? We want random numbers right when we are in the memory. So what we do is we change the seed. So seed is like a starting point of the algorithm, and what we do is we seed it with some number every time we want to generate a new number. So what is the thing which is changing constantly? Well, time is changing constantly. So what we do is we just seed it with the time. So this one will take the time. It will take the time as an integer, and then
make the random number generator start from that particular time. That is why you get different numbers after seeding it. But what is happening here is we are calling the random function before seeding it, right? For the first time. From the next time onwards, once the food is eaten, the logic is over here, right? Which is after the seeding function. That is why you are getting randomized locations for the consequent foods, but not for the first food. So to fix that, it is very simple. What you can do is you can get rid of the constructor. Well, I don't know why I defined this constructor. Well, basically, when we define a constructor, what we actually see is we need the constructor to do something which the default constructor, which a compiler will construct for this class, can't do, right? But what the default constructor does, it will basically create the memory required for this particular class, right? For loading this class onto the memory, you need some amount of memory which is calculated by the constructor. Well, we wanted the constructor to do something extra, that is called this function on the creation, and it did not work out as we expected. That is why we can just get rid of that constructor and then call the function manually. Well, if you want to keep the working of the program just like before, then you can skip this step. As I told you, it's just preference, right? I prefer that the uh, would be generated at a random location right from the starting. So you can go there, and after seeding the function, what we can do is we can now call the generate food method. So this is the one line which we wanted to skip by using a constructor, which was actually worthless, right? So creating a constructor was more good, and at least for this kind of a game where we want the first element to be randomized, so we basically get rid of the constructor, and that will solve the issue. Now, if you run this, you will be getting the foods at different locations. So one is being generated over here. Close that, open that again. Well, so the other one has been generated. Well, this is the problem actually which I wanted to show you in the beginning, right? Well, when I was eating the food, I actually knew that at some point this will happen. That is, we won't see any food on the food. That is a major logical issue with this program which we made in the previous video, and we'll be fixing that right now. So here, if you see, there is no food on the board, but actually it has been generated. We'll see why that happened. Okay, so close that, and now we fix the most obvious issue. Now let's go on to the issue which we just saw, that the food is not getting generated. Well, what we're doing in the generate food method, well, here we are saying that we want some random number in the range of 1 to with minus 1. Why? We told that the first character is basically reserved for the first wall, and the last character is reserved for the last wall. So basically you want numbers from 1 to with minus 1, leaving those two characters. It sounds reasonable, right? But if you work on the math, it is going to tell you a totally different story. So let's see what the math is. Let me pull up my paint over here. And now let's first talk about one of these. So width or height. Both of them are going to go with the same logic. So we can talk about only one of them, right? So here, let's say I draw the height. So what is the height? Height was something like 25, right? So the whole thing is actually 25 characters, right? And what we are saying that the first character and the last character are reserved for the walls. So from a computer's perspective, what are these numbers going to be? The computer starts counting from zero, right? So 25 characters is basically 0 to 24 for a computer. And what we are saying is we are saying that this 0 and this 24 is not required in our range. So basically we want numbers from 1 to 23. We don't want 0, we don't want the last character, which is 24, right? So this range becomes 1 to 23. Well, to get a number in this range, what you can do is plug it into the formula. So what is the formula for random number generation? It is, if you want a number from, sorry, L, that is the lower limit, to U, which is the upper limit, and lower limit is included and upper limit is not included, right? So you will be getting some numbers till U minus 1. So if you want numbers in this range, that is L inclusive and U not inclusive, you won't get the U. Then the formula is you need to plug in rand mod. It was U minus L plus 1
plus L, right? So this is the formula. You can plug it into this formula. You can even see logically. Well, basically both of them are going to give you the same result, and we'll just use the formula for simplicity purposes over here. What we can do is just plug it into this formula. So what it becomes, let me just write it as R. This is basically the random function R mod, and u is over here 24, right? Because we want 23 to be included, right? And in this formula, this particular u is not included in this random number generation. So we'll just increase this by one number, that is 24, and that will become 24 minus l plus 1, that is 1 plus 1. The lower limit is 1, which is included, that's why we don't have to do anything to it, and plus 1. So what this becomes is r mod 22 plus 1. And what is 22? It is basically 25 minus 3, right? So this is the number which we wanted to generate actually. But what we did is we basically went by our intuition and messed up the logic, right? So to correct this, what we need to do is using this particular formula, this becomes minus 3 and this will become plus 3, and the same will go with height also. Well, we talked about height, the same thing will go with the width also. So if you draw a similar kind of analogy, you will be seeing that the same logic will work for the width also, right? So let me just clear that, and here it is minus 3 and this is plus 1, right? Now this will fix the disappearance of the food. And there is another major flaw in our looping, right? So where are we looping? We are looping over here, right? The board where we are displaying. There is a major flaw in that. And believe me, if you have been able to identify that particular error, you are going to be a great programmer, right? So let's see what the error is. It is basically lying within the inner loop. What we're doing? Well, for the outer loop, it is pretty straightforward. We are going from I equal to 0 to I equal to height, which is basically how the computer sees numbers from 0 to n minus 1. And for the width, we are doing something different, right? So what we're doing here, we are saying that we are going from 0 to width minus 2, and we had a reason that these two characters, which are basically the walls, are constant for all the rows. So instead of including them inside the loop, why not just exclude them and run the loop only for the width minus 2 number of characters? So that's what we did, and that sounded reasonable. But here is the problem. What happens is, let's say my generated x-axis, which is basically the width, is going to be 28, right? Sorry, what is the maximum range? It is 50, right? And what you can do, if this is 50, the maximum number you can generate leaving 0 and 49 is 48, right? So this is the maximum number you can generate, and let's say that that is our x coordinate, that is the value of our width. Now what happens here? Well, if you see here, j is running from 0 2 width minus 2. What is width minus 2? It is basically 48, and it's not reaching 48, it's just going till 48, which means it's going till 47 only, right? Now if you see this, you don't have a way to actually display this coordinate in this loop at all, because it is out of the bounds of this particular loop. This loop will run only till 47, and you are asking it to show something which is on the 48th coordinate, which is not possible by this loop, right? So how do we fix this? Well, we can draw an analogy over here. So if you draw the coordinates with the j's perspective and the w's perspective, w is basically the original width of our board. If you see this, when w is 0, j is not at all defined. Why is that? Well, let me just clear this thing so that we can see it clearly. But this is the leftmost corner of our board, and this is 25, right? 25 characters or 25 pixels. And here what we are doing is, we are saying this is our character, the width character, and we are saying that the inner loop should run from 0 to 47, and we are including another character, and the total makes it 50, right? So 0 to 47 is 48 characters, plus 1 50, and this is the other one. Now what is happening is, let's say my coordinate is 0, right? Then
the x coordinate is 0, it basically means this particular position where the wall is there, right? But what is happening here? Our 0 is starting from one step to the right because of this particular looping and this particular character before the loop. So what is happening? Our loop, which is starting one step towards the right, and that is why we are missing out our coordinate. So what happens is if W, which is our original x-axis, is 0, J is not at all defined. It is not there at all. And when does J equal to 0 start? When width equal to 1, and so on. This will continue. When width equal to 48, J equal to 47, as we just saw, and width is 49, it is not present at all. Right? So this is the reason why we were not getting anything on the board. Not this is not the complete reason. The actual reason was because we were messing up the formula, the random number generation. But here, this is another one of the major reasons why we won't be getting even after fixing the random number generation. That is because if you create any foot at the extreme positions, that won't be visible to you at all. Right? So to fix this, what we can do is, while comparing the coordinates, we need to add 1 to this, right? So if 0 plus 1, well, we don't care about the 0 or the 49th coordinate, right? We don't want these two things because we're not going to generate food at those two things. They are walls, they are reserved for walls. So in this range 1 to 48, what you need to do, you need to compare only these things, right? You need to compare only these things, and to compare that, what we can do is we can add 1 to the j before comparing it with the x coordinate. So to fix this, what we're going to do here is, well, we need the canvas. Let me just clear this, and here in place of j, it's going to be j plus 1, and that should hopefully fix all the logical errors which are made. So save that, run that again, and here we have our first food. If you eat that, the second food is getting generated, and hopefully it should not stop generating. It should be generating till we play this game, and it should stay within the range of board, and it should be visible to the player, right? So well, if you see this is visible, and trust me, it's going to work, and there are no kind of mistakes in this program, and this is completely fixed now. Well, we'll fix one more thing, that is, if I go to this particular wall, I will crash before actually crashing. So if you see this, I have not yet crashed the wall, but it's in that I have crashed this wall. That means I need to go inside the wall. So to fix that, again, it's the coordinate issue and also a placement of more snakes. So let's first fix the coordinate issue. If we go there, snake dot collided will have already fixed it. Basically, what we did was we had put something like this, right? Position dot x is less than 1 and position dot x is greater than width minus 1. So going by the same logic, width minus 1 is going to be 49 because width is 50. So width minus 1 is going to be 49. So what you want something greater than 48, not 49. So it's going to be width minus 2, and that should fix the issue. And for the other wall, which I just showed you there, for the rightmost wall, what is happening is we are first drawing the board. We are actually changing the direction of the snake. We are moving the snake, and then we are checking whether it collided or not. Basically, this movement is not shown at all, right? This movement is not shown to the user. This movement should actually happen after this collision checks and all. So what you can do is you can just move this to the end, or you can even move it to the start. Doesn't matter. Basically, the board should be updated after the snake moves, not before the snake moves. That is what is happening over here. The board is actually getting updated before the snake moves. So that is why you're not seeing whether the snake has been collided or not. So you can just move this thing to the end or move this thing to the start. Basically, they both mean the same thing, right? So for the next loop, the starting point is going to be end of this loop. So they mean the same thing. So just move this to the end or start, whatever you wish. Right? Now this should fix that issue that you're not seeing the snake colliding, and now you should see that the snake actually collides with the wall before ending this game, right? So it went inside the wall and the game ended. And now everything is pretty much fixed. And now let's proceed to making the snake game a real snake game. What is that? We need to include the snake's body. We are just growing the snake, which is basically just increasing the length, right? So here you can see it's just increasing the length. So how can we store the snake's body? Well, what is a body? it's just a collection of body parts, and that collection must have triggered something inside you. Well, we are going to use something like an array, which is a collection, a vector, which is also a collection, which was seen in the pointers video, and the other thing is list, right? So these are three options available to us as of now, and we use one of this. Now let's analyze what we need to use over here. Right? So array, well, array needs to have a fixed size while defining. And how do we know the fixed size of the snake? Well, if a player like me is going to play, he's probably going to get defeated in, let's say, 5 or 10 points at all, right? Because I'm a very bad player, and maybe a pro player comes in and he can make a score as big as 1,000 or 10,000, right? Well, you cannot restrict the players, or you cannot estimate the player's capacity by just keeping a fixed number. What if the player is better than what you thought he should be, right? So here what you can do is, well, in this particular board you can actually fix it to some big number. So let's say the maximum number of characters possible is what? Well, here the width is, let's see that width is 50 and height is 25, right? So the maximum number of characters possible is this thing, 50 times 25, out of which you're using the borders. So that is the only number of characters. So if you make the snake as big as that, after that there is no possibility of winning, because the snake has to collide, right? Because the maximum free space has been used up. So basically it has to collide with one of the walls and you end the game. Well, that is a very cheap way. You don't have to do that. And while defining with graphics, we generally what we do is we'll take off such limitations, right? So that is why you have such teleportable walls and all to take care of this issue. But for this particular game, we won't be talking about the teleportable walls. Well, in the end, I will show you how to create teleportable walls if you want to. And here, basically, the array is a very bad option because you are restricting a player's capacity. And if you talk about vectors, well, it is dynamic, but again it is going to take up some extra space while defining. So if you remember how vector work, it first defines some amount of space, and once it gets filled up it will define a bigger space and then copy all the elements to this and get rid of this particular space. So this one could be used, this could work, but again there is some extra space which is getting wasted. So basically the best option here is going to be list. So if we remember from our video on the pointers where we first discussed when to use vectors versus when to use list, you saw that list can be used whenever you have a data structure where you won't be accessing the middle elements more frequently. You are just going to access the first and last element. And that is the case here also, right? You are not going to access the middle elements, which is basically these body parts. We are not going to access that. We are just only concerned about the head, which is on the front of the data structure, and the tail, right? So we will talk about how to actually manage the head and tail in a short while. But for now, the head is at the beginning and the tail is at the end, and we are only bothered about these two things. We're not bothered about the middle elements. Well, we are basically when we want to check the collision, we need to consider the middle elements also, but we can just do it in a progressive loop, right? So it basically doesn't make any difference, and we can't actually harness the advantage of being able to pick some random element from in between. Well, in a vector, we can do that very simply because it is a continuous collection. But in a list, if you remember, it was something like this, right? You have pointer, you have pointer to something, and then you have another pointer which points to this, and so on, right? So if you want to pick this thing, you need to travel all this way. But in a vector or in an array, you can just pick that up using the index. It is basically the starting position plus the number of steps you need to travel. So in this case, a list would be the best thing to implement, but to keep this tutorial simple, I'm using vectors for this particular demonstration. So I would totally encourage you to go with list, not with vectors, as we are going to see in this video. I'm just showing it with vectors because it's easier to relate than this, right? But once you're comfortable by implementing this particular project in a vector, please go on to try it with a list. List is the most preferred option for such games where you don't have to control the capacity of the user. Right? Vector is not going to control, but basically the extra space is an issue, right? We don't want that. So please try it with the list, and let's now move on to the logic of creating the body. Right, so let's just clear that. And how do we define the body? Well, it's really simple. So let's say I have two body parts, well, basically a tail and a head. I have this head over here, and the snake has to move to the right. So what can I do? Well, what if I just remove this tail and then put another head over here and make this as a tail? So for tail, let's just say this X mark over here that denotes a tail. Now, if you see that the snake has put one step to the right, right? And if I do that again, so I take out this tail, I include the head, and I make this head as the tail. Now the snake has moved again, and let's say we are eating the food at some location. So let's start with another snake. So this is the snake we have, and the food it is going to eat this particular food. So it has eaten. In the next iteration, what I will do is I won't take off this tail. Right? I will keep this tail, and this is what happen, right? So I add the head, I won't remove the tail, but I'll make this head as a tail, right? So now you have two tails and one head, and that basically looks like the snake has grown, right? From two body parts, it has grown to three body parts, and that's what we want, right? So this is the logic we are going to implement, and we are going to do that in vectors. Again, list is the most preferred option. Please try it with a list, not with a vector. After you're comfortable, basically. Right? So let's just go to our snake.h and quickly create a body definition. So we need vector obviously. So hash include vector. If you're going to do it with a list, you know, right? Hash include list. And well, since vector is a standard scope element, you need to specify the scope. So using namespace std, like we did in the main function. And here you can just say vector body, sorry, vector, and what is the data type? It's going to be coordinates, right? Basically, so chord and then body, and this defines the body of the vector. Now there are few changes we need to make. What is that? First of all, we need to include the head to the body once we create a new snake. So in this snake chord constructor, what we're going to do, we're just going to say body dot pushback, which is basically pushing back the elements inside a vector. And what we need to push back, we need to push back the position, which is basically the position of the head of the snake, right? We can just body dot push back that particular position. And while moving the snake, following that logic which we just discussed, what we're going to do is first we are pushing the head of the snake to the end of the list or end of the vector. So how we do that? Body dot push back the new position which has been updated after all these things, so new position. And now what we'll do is if the body size is greater than the length of the snake. What is the length of the snake? That is the thing we are growing when the snake is actually eating a food, right? So that is the thing we are manipulating over here. So this length integer, if the body is size, which is basically the number of elements in the vector, is greater than the length, then what you do, you just take out the element from the body. So how do you do that? You just say body dot, and if you're actually confused with what function you need to use, the best thing I would suggest is not just memorize the function but just use the resources. So you can just go to your web and then search something like cpp vectors documentation, and you'll get a lot of resources, and c++.com is the best one among them. Well, I feel that this is the best one where you can find short descriptions of all the functions, right? And here you should be saying some function like pop back. What does it say? It says that removes the last element in the vector, effectively reducing the container size by one. But we actually don't want this, right? Well, why is that? If you see, well, technically the tail should be at the end of the body, but if you look at the structure, what we're doing is we are actually pushing back the head one step to the right, right? So this is what pushback does. So basically our head is over here and our tail is over here. And what we need to do, we need to remove the first element. So how can we remove that? You can just check out the functions over here, but to save the time I'm just going to show you the function which is basically clear or arrays, right? So you will find this one. This is basically going to remove from the vector either a single element or a range of elements. Right? Here we just need to remove a single element. And the position is not an integer; it's a pointer. So here you can see it says the definitions: iterator position, and iterator first, and iterator last. Well, you can go with any of this. The only difference is that it has a constrainer, which you don't have to know at this stage, right? You can, well, you can just go and search what these two things are. Basically, they be the same thing. And how to use that? You can see an example over here. It says dot erase my vector dot begin plus 5. So plus 5 is basically going 5 steps away from the first element, which is basically the sixth element. And that's how you use this arrays function. He has also shown an example to delete a range. Well, we are not quite interested in erasing a range. We just want to erase a single element, which is going to be our first element, because our first element is the tail. And what we can do, we can just say my vector dot begin plus 0, that is stay at the first element, or you can just omit the 0 and just say my vector dot begin. That is going to erase the first element. So let's implement that. What we're going to say, we are going to say body dot erase, and what we're going to erase, we are going to erase the first element, which we can get by body dot begin. This is the pointer for the first position, right? So this will basically erase the first element from our list. And well, before proceeding, let's first see whether this is working or not, right? And we need to create another function. Well, let us keep this function for now and then create another function just in case something goes wrong. So vector, and it is going to be coordinate, right? You need a coordinate vector to be written. Well, basically we are going to return the snake's body. So snake, and then let's say get body, and inside this we can say return body. And in the snake.h you can just create that function definition, which is basically vector chord, sorry, what is that, get body, right? So now we have updated the snake's definition. Now we'll just update the board. And what we need, we first need a vector to capture the snake's body. So vector chord, let's say snake body equal to snake dot get body. And inside this, what we're going to do, well, just remove this else and we'll place this afterwards. What we're going to do is, inside the else, we are first going to loop through the snake's body and see whether any coordinate matches or not. So what we can do is, we can just say is body part, which will stay false in the beginning, right? We'll change that in the loop. Now what you can say is for int, well, I just used it, so k equal to 0, k is less than our body, which is snake body dot size, and k plus plus. What we're going to do here is, inside this loop, we'll say if ith coordinate, which is basically going to control the y coordinate, is equal to the snake body of the kth index dot x, sorry, dot y, and j plus 1, well, remember that's the logic we were missing up, equal to snake body dot, sorry, snake body of that particular index dot x. If these things match up, then what we need to do, you need to display a body part. So let's just go with this small o for now. This is our body part, and if body part becomes true, equal to true. And what else? Well, we don't want to run this thing, right? Because at an instant, a particular body part can stay only at a particular location. So if that location is occupied, it is pretty obvious that any other body part won't occupy that location. So you can safely break out of this loop. You can end this loop. And in the end, what you can say is, if it is not body part, if not body part, then obviously it is going to be just a empty space denoting the empty area, right? And here another thing is, here we are going to body dot size, but remember body includes the head, right? So what we can do is, we can just say body dot size minus 1, which will basically leave out the last element. And now this should work, and let's try to implement this. So F9, and here you can see that the snake has grown. So the other foot is over here. So well, I ate that, and the third food is over here. Well, you can see that the snake is growing, right? So here you have four body parts of the snake, and now if I eat that, here now you have five, right? So now we have a working snake game, right? So now you have a working snake game, and this works pretty fine, right? So now the you can see that the animation also works pretty fine. The body parts seem to follow the head and so on, right? So this concludes our game. Well, I promise you that we'll be seeing how to create a teleportable wall. And before that, if you want to show a score, that is also pretty simple. What you do is you just say here int score. Well, just keep it global so that you can use it on the board function also. So here you can just say int score, which is going to be 0 in the beginning, and well, you can just set this to 0 in case you want to say play again, something like that. What you can do is instead of main you can just say game, and this is going to be a void game. Well, I'm not going to do that. You can do that, right? So if I want to play again, you can ask a question, do you want to play again or not, something like that. And if I press yes, then you can call this function again, and then you can set this thing as 0. So core equal to 0 before the beginning of the new game. And here what you can do is you can just say score plus plus, very simple. And if you want to give 10 points or something like that, you can just do that score equal to score plus 10, or any shorthands if you know score plus equal to 10 or something like that. You can do that over here. And here, before starting to print out the board, what we can do is we can just say see out our score. So score is our score, current score, and just add a couple of new lines so that it looks neat. And that should take care. Well, I have one redundant function over here, that is this the snake pause, which is actually getting the position of the head, and we are also getting the position of the body, right? And we did not define the collision of the snake, right? So we'll do that, those things. First of all, let's just see whether this thing works or not. So now you have this particular snake, and I ate that, the score is 10. Now I ate that, score is 20. I hit that, score is 30, and so on. So it's working pretty fine, right? So you can close that. And to take care of the collision, well, you might have figured it out by now what we need to do. Well, what you need to do here is you need to say else, and you need to check whether it collided or not. How do you check that? Well, you don't need a else at all. You can directly check it inside a loop and then return it. So what you can do is for int I equal to 0, I is less than the body dot size. Well, it's inside the snake, so I don't have to call that. I can just say length minus 1 because I don't want the head, and it's going to be I plus plus, right? And what we need to check, if our snake's head is basically pos, right? So if pos dot x is equal to any of the snake body, well, it is not snake body, it's just body of I dot x, and the y coordinate is also same. Pos dot y is equal to bodies I dot y. If these two things match up, just say return true, yes you collided. If these two things don't satisfy in the end, just say return false. So this should take care of the collision. So let's just try that out. F9 to build and compile this, and here you have this snake and the food. And let's first go for our first food. We have grown, and the score is also increased. And the second food, but it's going to take a while if I go like that. It's just going one body part at a time. Right? So what I can do is I'll just right away collide. Well, how can I collide? Well, I'm moving left now, right? So if I just press right, I'm just going to collide with my neck. So basically I collided, and now you can see that the process has stopped. Basically our collision algorithm is working. So that basically ends this game. And if you want to make a teleportable wall, it's really simple. What you need to do is, I am sure many of you must have figured it out right now. Well, you just need to play with the coordinates. So if you see in the snake move snake, what you do is, if you want to change the location of the snake, you will just say here, if this particular thing, if position dot x is greater than the width minus 2, then what you do, you just say position dot x equal to 0. So simple. And again, what you do, if you say if position dot y, or sorry, position dot x is less than 1, then what you do, you just say position dot x equal to the width minus 3. Sorry about that. For random function, we need to use width minus 3 because for generating the random numbers in that range, so it's basically width minus 2. And this will make the side walls teleportable. So if you just save that, and now if you run this, you should be going through the side wall and coming from the other one. And now, if I go through my side wall, I should be appearing from the other wall. So you can see that it has been a kind of teleportation. Now, if I eat that, our tail will also follow our steps, right? So if you go from there, you appear from there, right? So it works both ways, right? So that is how you make teleportable walls. And once you get to know about file handling, basically how to write files, what you can do is you can even have a high score option. So you can write down a particular high score on the file. So let's say I open this game right now and I scored about 10 points and you scored about 1000 points. So that's pretty reasonable. I'm not a very good player, but yeah, so you score about 1000 points, and that is a high score, right? So here, if you run this program again, that high score gets lost. So instead of just writing it on the memory for that particular kind of run, what you can do is you can have a file where you can write down all your high scores, and then whenever you load this game, you load it along with the file. So inside that file, you have all the high score list, and if you want, you can just have names also. So some games provide that, right? So you have the name and then the high score. Something like that, you can design everything, and we'll come back to this while discussing files, right? So because traditionally what we do is we just write files about students and all those things, but we'll come back here and we'll try to work on this game more and try to create a file. And again, this is a totally working game, and if you want to implement this and if you're comfortable with implementing this with this kind of a vector, well, I have made some redundant functions. Like this is completely, sorry, this one is completely unnecessary because I'm getting the head along with the body. So you can take care of that, and again, I would advise you not to use a vector, use a list. And here, if you want to include another teleportable wall, there is this one. You can do that again with a similar kind of logic for y-axis, right? So you make basically all four of the walls teleportable. So I had actually implemented this game in Python, and if you use a graphics library, you will be getting results like that. So if we go to our Python one. So here I have my game. Well, it is basically written in two files. One has the classes and one has the script, and it has various images. So what I have is the snake in parts. So here you can see body horizontal, tail up, tail down. So whenever that snake is going in that particular direction, you show that image. And now, well, you can run this thing right over here. You can see this game. This is what you can make with a graphics library. Well, this is pretty fast, but this is what you can make with a graphics library, and you can see how smooth it is, and it doesn't have any kind of issues like moving down faster in the vertical direction, moving slower in the horizontal direction. It has kind of same speed because you can control it, right? You can basically control the number of pixels and all. And if you see, it is teleportable on both sides. If I go from the bottom, I end up from coming from the top, and if I go from the sides, I end up coming from there. So this is how you can implement your games, and this is basically the same logic which I've implemented, except that I have some additional functions handling the graphics of this game, right? Nothing more than that. It is basically the same exact logic which we have talked about in this console, but when you use a graphics library, you get results like that. So once you're comfortable with programming this particular game on the console, I would advise you to look up some graphics library which is available in C++. There are many, so see what you're comfortable with and try to implement such games on graphics. Even the tic-tac-toe game can be implemented on the graphics library, and that really looks good instead of the console, right? So, well, basically, what we are learning here is how to think, and console is the best way or the best platform to actually put down our ideas in a very fast way. Well, if I want to do the same thing in a graphics library, it will take a really long time. I need to initialize the graphics library. I need to do a lot of things before getting all these things, right? So if you're coming up with an idea, I would rather recommend you not to go to a graphics library, but first think and then put up a dirty kind of working prototype on your console, and then you can beautify it on the graphics library. Right? So that's it for this particular video. Hope you enjoyed this, and I encourage you to build up your own game by changing the laws and then making it faster on the X and slower on the Y or something like that. I did not do that. I just went with a very simple approach, but I'm sure you can do that. In this video, we will be talking about inheritance in C++. Well, inheritance in C++ or any programming language, it is no different from what we know about inheritance, right? So what do we know about inheritance? A predecessor shares some of his properties with his successor. So say a father has a green eye and maybe the son will also have a green eye because of inheritance of genes, right? So that is what we know about inheritance. Well, in programming too, there is no difference in the concept. There is a parent class and there are child classes which inherit some properties from the parent class. That is what inheritance means in programming, and we will see how to do that in C++. Now, why do we need inheritance? Well, say I have a class. So here I have an animal class. So I have some properties in the private section and I have some properties in the public section. And now I want to create 10 animals. Well, it's pretty easy, right? So since we know about arrays, what we can do is we'll just say animals or animal A10. We have created 10 animals. Now let's say I want to create 10 tigers and 10 dogs also. And they all have these similar properties. But the only difference is that a tiger will also have another method called roar. So something like this, void roar, which will print roaring on the console. And similarly, a dog will have bark, right? So how do we do that? Well, if you think you're copying the classes and then uh, creating two different classes for tiger and dog and then creating two different arrays in a similar way, you're not wrong. It will work. But an efficient way would be to inherit the properties from this animal class. Well, if you see tiger and dog, both are animals, right? So both have a species name, both have an age, both eat, both sleep. But the only difference is that a tiger roars and a dog barks. So if you can take advantage of all these properties from one class and add whatever extra features you want to add, then that solves the problem of creating a separate new class, right? So what I mean is, say I have a class tiger and then I have some method like public void roar, and then this is just going to print out roaring on the console. Now say I want this tiger to have all the properties of an animal. It should have a species name, it should have some age, and then it should eat, it should sleep, and all those things. So you can just copy it down, but an efficient way would be to inherit them. And how do we inherit something? Well, we'll just put a colon over here and then put public animal. And we'll talk about what this means, right? So for now, this is how we can inherit the properties of an animal. And now if you create a tiger, you will have the properties of the animal as well as the tiger. So I can do t.eat, which is basically defined in this animal class. It is not defined in this tiger class. And I can also do t.roar. That is also valid. And now if I run that, well, string does not name a type. Yeah, that's because I did not use using names with stdio above. Close that. And now here you can see eating and roaring. So eating is from this thing, from the animal class, and roaring is from the tiger class. Well, if you want to create a dog, it is very similar. You can just do class dog and then public animal. And here you can just say public void bark, which says barking on the console. Done, right? So now if you run this, well, I did not create a dog object, so you can do that from here. So dog d and d.eat, d.bark, because roar is for the tiger, right?
So you can say d.bark, and if you run this, you will get similar results. You will say eating and then barking. So that is the advantage of inheritance. You can take advantage of all the features which are defined in the parent class, or you have something called a base class. There are different names for this. So in some languages it's called super class, and then it's also called as a base class. It's called a parent class, and there are many names. And then this one also has similar names. So this is called a child class, and then this is called an inherited class or something like that, right? So basically we'll just stick with parent child because that fits the analogy, and that's how inheritance works in C++. It's that simple. And now we'll just talk about these things, and we'll also see how to take full advantage of inheritance in later videos, because it's not a one video topic. Inheritance is very vast, and then there are many advantages of inheritance. So we'll see what these things are in this video. We'll see how to do basic inheritance in this video, and then we'll see how to do multiple inheritance and all those kinds of complex stuff in later videos, right? So first of all, talking about this will specify where to inherit, and this class will specify from where to inherit. So this is to where and this is from where. So let me just write it down. This will specify where in tiger do I have to inherit, and the other one will say from where do I have to inherit. So these are the things we are specifying. What we are saying is you create a class tiger which will inherit all the properties which it can inherit. Well, there are some restrictions, we'll talk about that. But this statement, this particular line means that create a class tiger which will inherit whatever it can inherit from this class, which is animal, and put everything in the public section. So that is what it means. So public means it doesn't mean that everything it is going to inherit is going to go into the public. It means that whatever it inherits, just inherit as a structure. So if you see here, you have private and public, right? So when you're inheriting it as a public inheritance, what you're doing is you are just maintaining the structure. So a private anyway doesn't get inherited. So if you have anything else, that is going to go into that section, and public things will go into the public section. Well, you can do private here too. So you can do something like private. What this will mean is it doesn't maintain the structure. It will just put everything inside the private section. So everything it inherits go to the private section, and these methods are now not accessible from here. So now if I run this, okay, I inherited in the tiger class, so let's just make dog as private. And now if I try to run this, I'll be getting an error. Why? Because I have made it private inheritance. That means whatever I can inherit, I'll put everything in the private section. So something like this will be created inside the memory, and these two things will go inside here. So private doesn't get inherited. So let me write it down. It doesn't get inherited. So private members don't get inherited. They are private to that particular class. What gets inherited is public and protected. So remember protected from our video on classes. Well, we talked about protected very briefly over there because we told that protected is better understood in inheritance. So we'll talk about that now. Well, protected is basically when you have something which you don't want to share with the objects, but you want them to be inherited. So something like this. I don't want species and age to be accessed from objects of this class. If I create an animal object, I don't want the species and age to be accessed from that object, but I want those things to be inherited. So at that point of time, I will make these two things as protected members. So protected means I cannot access with an object, but I can inherit them. So what I can do here is instead of private, so let me just remove this. I can just protected here. So protected, and now actually these two things go inside tiger and dog. So if I do something like public here, well, as I told you, it maintains the structure, right? So if I do public here, and then I'll just create another method, right? So void set age, which will basically set the age. So int age, and then this age, you can see here age is actually coming here, which is basically not defined in this tiger class, but it got inherited from this protected class. Sorry, this animal class. So if I do this age equal to age, it is going to work. And what we can do here is I'll just say tiger t, and if I do t dot t dot set age to something like 10, and then we can also retrieve the age. So let's say int get age, return age. And if we try to print that age, so if I do cout t dot age, t dot get age, and if I look in the console, you will be seeing 10, which we have set here, and that age is actually derived from this animal class, right? And now if I try to create something like animal or even tiger, if I do tiger dot age, I won't be able to access it. So if I do t dot age equal to 10, I'll be getting an error. So it says, if you look in the debug console, it says that int animal age is protected. So that means that I cannot change that. It is like a private member to the objects, but it's like a public member for the inheritance. So that's what protected means. So this is for the private. So this I did not change this method. This is for the private thing. For protected, it means that it can be inherited but cannot be accessed by objects. Public means that it can be accessed by the objects as well as it can be inherited into other classes. So that's all about basic inheritance in C++. So again, as a recap, this will specify where to inherit. So if I do protected here, what is going to happen? If I do protected here, everything is going to go inside the protected function. So why do we want to do that? So let's say I want to create another thing like for now, let's say tiger baby. It's the baby of this tiger. So if I want to inherit something from this, I can do something like this, public tiger, which is completely allowed. Now what is happening? Something from here is going to get inherited inside the tiger, and something from tiger is going to get inherited inside this class, which is called tiger baby. And that is how inheritance works, and that's how it boosts your programming.
In this video, we'll be looking at the different types of inheritances we can perform in C++. So before beginning, I would like to kind of put a note here that whatever we are going to discuss today are not to be taken as the only things available for you, right? So these types of inheritances or frameworks, as I call them, these are to be used only to model your program. So there are many kinds of problems which cannot be directly solved using the 4 or 5 types of inheritances we are going to discuss today. So you need to kind of model the problem and use a combination of 1 or 2 and maybe sometimes even all 4 types of inheritances, and then create one, and actually that is mentioned as an inheritance, as a type of inheritance for you. So the point is, you need not remember all these things, but as a computer programmer, you're supposed to know that these things exist, these frameworks exist. These are nothing but just to help you model your program, and not to be used directly, but to be used along with proper planning and then kind of modeling of your problem. So the inheritance problem has been there for decades, and it's not completely solved even now. There's no kind of hard and fast rule to say that this particular inheritance model will do better than that, or for this particular problem only this model will work. There's nothing like that. You can try with different models of inheritances. You can try to combine 1 or 2 types and then come up with your own custom type and all those things. So these are just like a starting point for modeling your problems, right? So with that, let's get started. So here I have pulled up a website which is studenttonight.com. So what we are going to do from this website is we are just going to refer the names from here and then the images. So here they have beautifully provided kind of images here to visualize how the inheritance would look like, and then we'll implement that in code, and we'll use the same notation here. As here you can see they have used A as a superclass, basically, which is the parent class, and B is the subclass, which is the child class. So we'll use the same naming in our code too, so that you can relate with this, right? So let's get into it one by one. So the first type of inheritance is single inheritance, which I'm sure everybody is familiar by now. So we have been doing this in the past video, which is nothing but you have one single parent and one single child. So to implement it quickly, let's just create a class A, and we'll keep this simple. We'll just have a constructor and destructor, right? So to create a constructor, you just put a function definition just like that without any return type, and then inside this you can pass in parameters, but for now I'm just keeping it empty. So here we'll just say constructing A, right? We'll see in a moment why we are defining these constructors, right? So we again need a destructor. So for destructor, what you need to do is put a tied symbol before the constructor and define the constructor as it is. But here the only difference between a constructor and destructor is that destructor is meant only to destroy the object, right? It is only meant for destructing the object when it gets out of the scope, so it doesn't take any arguments. So you cannot pass anything here, unlike in constructor. You could do something like int a in a constructor, it is allowed, but in destructor it is not, right? This is just to kind of debug your program when your object is getting out of the scope and all, right? So here we'll just say destructing a, and that makes a. Now let's create another class similar to this, class B. So copy that, paste that, and we just need to replace it. So replace all A with B, and you need to match case from the cursor, right? So replace that. You don't need to replace these things, you need to replace these things. Well, now we have another class ready. Now to inherit A inside B, I hope you remember that you just need to put a colon and then the access specifier where you want to inherit inside B. We'll keep it public, and you are going to specify which class you are going to inherit from, which is A in our case. So A, right? So here we have a single inheritance as shown in this picture, right? So you have one parent class which is getting inherited into a child class. So here you can see parent class is A, and A is getting inherited inside B. So now if you create an object of class B, so if I say B obj, obj stands for object, so and run this thing. So well, I did not put any new lines here, so just put that so that we can differentiate the output and kind of run through what it actually means, right? So after putting the new line, you have this output, and let's break it down, right? So first you have constructing A and then constructing B. So if you observe here, we're not constructing A at all, right? But why is this statement coming? This statement should only come when I create an object of A, right? And here I'm again destructing A, which I did not even create. So what is happening here? Well, object creation is called instantiation, right? So it's called something called instantiation. So what it means is you're going to create a virtual object. It doesn't actually exist. It's actually not a physical object. It doesn't exist in the memory. What it means is, since I'm inheriting from A, for a computer, inheritance means you need something from A inside class B, and everything is not defined inside class B. So in our case, there's nothing special about A and B, right? So A just has a constructor and destructor, and B also has a constructor and destructor, and practically there's nothing to inherit from A. But for a computer, it doesn't look at those things. It just knows that it needs to inherit from A inside B. So assuming that A has something which B doesn't, it first creates a kind of instance of an class instead of the parent class, which in our case is A, and then it will pass on those properties to class B. That is why in the console, when you're creating an object B, you're seeing constructing A first here. That is because since A is the parent class, it assumes that there is something important inside the parent class which is not there in the child class. So that is why you are inheriting, right? That's the main purpose of inheritance. That is why the compiler is built to do that. So first it will construct A, then it will construct B, and while destructing, it will destruct in the reverse order, right? So construction happens from A to B, that is parent to child, and destruction happens from B to A, that is child to parent. And this will continue for any level of inheritance. We'll just see what levels are, right? So this is basically the simple inheritance or the single level inheritance in C++, right? Now let's move on. You have multiple inheritance. Multiple inheritance basically means that you have multiple parents for a single child. So here it has demonstrated with 2, but there you can have, as you have mentioned here, you have classes which can inherit from more than 2 classes also, right? It totally depends upon your problem. Now to do that, it's almost similar. You just need to take this out. You need to duplicate this class B. So take this, copy that, and replace this thing. So you need to replace B with C. So replace, yes, and well, you can do this manually, right? Now I have a class C and also an object of class C, and to inherit multiple classes, what you need to do is just put a comma, right? So if you just put something like public A, this is just single level inheritance. Basically what it means is A is the parent, C is the child, and C as a child is inheriting everything from parent A, right? That is that. And for B, you just put a comma and then put the access specifier. I'm just going to keep it public here. You can do protected or private as per your problem, but for now let's just keep it simple. We'll just use public for all our inheritances, right? So public A, public B. Now you have multi-level inheritance, multiple inheritance, right? And now if you run this, you have this kind of output. Now the thing to be noted here is it's almost similar, right? So first A is constructed, B is constructed, then C is constructed. C is basically the actual class which we are working upon, and then the destruction is just the reverse order of construction. The thing to be noted here is if you change the order of inheritance over here, it will be affecting the order of creation also. So here I am first inheriting A, then inheriting B. It reads from left to right. So basically first I'm inheriting A, then I'm inheriting B. Now if I change this order, if I make this B, and if I change this as A, and now if I run this, that order will be swapped there too. So if you see here, first it has constructed B, that is because it is appearing here first, and then A is constructed, then C, and basically this order is just reversed while destruction, right? So destruction follows that same procedure. In the order construction happens, destruction happens in the reverse order, right? So that is about multiple inheritance. This order matters, and you can have as many classes as you want inside this particular class. You can inherit from multiple parent classes, right? So if you had more another class, so say public some D and private E, all this is possible. Basically it will just construct the classes in this order. First B will be constructed, A will be constructed, D will be constructed, E will be constructed, then C will be constructed, right? So that is about multiple inheritance. Now we can move on. Just take out this website, and here you have something called hierarchical inheritance. So in multiple inheritance you had multiple parents, in hierarchical you have multiple children. So that is the difference between multiple and hierarchical. You have one single parent, and that single parent is inherited by multiple children. So we have already worked upon one of the examples on this particular hierarchical inheritance structure. That is when we were discussing about the animal class. So if you remember, we had a class animal, and both classes like the tiger class and the dog class inherited from the animal class. So that was an example of hierarchical inheritance. So to do that, here we can just put something like public A and public A. So here you can see that A is the parent class, B and C both are children of A, so both are inheriting A. So this is basically an example of hierarchical inheritance. And it's basically, if you just create an object of C, it's just going to look like simple inheritance or single inheritance, because if you just remove this B from here, what you just have a parent class, and then you have child class which is inheriting from the parent class, which is nothing but an example of single level inheritance. So basically it works in the same way. So now if I run this, it will output something similar to single level inheritance. You just see the parent class constructed, the child class, and the destruction in the reverse order, right? So that is about hierarchical inheritance. And now the other thing is multi-level inheritance. Now the difference between multi-level and multiple inheritance is that in multiple you have multiple parents, but in multi-level you have a tree kind of structure. So a multi-level basically is kind of more generally used inheritance framework, because this basically transits from a more generic class to a more specific class. So what I mean by that, so let's say an example for a generic class could be animal. So animal is more generic. I could mean any animal by just saying animal, right? So if I have class animal and then I want to be somewhat more specific, so I mean I'll just increase my specificity level, and let's say I have a class dog. So now I'm inheriting from animal inside dog. So here, if you see the chart here, you have A, which is animal, and then B could be dog. So now I am inheriting the properties of animal inside class dog. And if I want to be even more specific, like choose some breed of dog, for example, so that could be C. So basically, you are moving from a more generic class of objects to a more specific class of objects. So that is why multi-level inheritance is basically used mostly, but as I told you, it doesn't have to be. It totally depends upon your problem, right? So let's quickly implement this. So the way you implement is, you have A, B is inheriting from A, then C will inherit from B. So this is multiple, right? Multi-level is you have two or more parents and the child will inherit from them. And in multi-level you have a tree kind of structure, right? So now if you run this, you will get a similar output for what you saw in multiple. Basically the order matters here. So first the parent is constructed, then the B is basically the child of A, then C, which is nothing but a child of B, and then the destruction will happen in the reverse order, right? So that is about multi-level inheritance. And then in the end you have something called hybrid inheritance. So hybrid inheritance is nothing special. It's just it's just kind of combination of all these kinds of inheritance. Here it is just said that it's a combination of hierarchical and multi-level. What I'm saying is it doesn't have to be. So this particular framework, it doesn't have to look so neat. So here you have two classes just directly inheriting from A, and then you have one single class inheriting from B and C also. So it doesn't really have to be in such a clean format. It totally depends upon the problem, on the way you are going to solve your problem. So hierarchical, the hybrid inheritance or the virtual inheritance basically means that you are going to create a custom model, custom inheritance type by using these four types. So the single, multiple, multi-level, and then hierarchical. You're just going to use a combination of these types and then create a custom model which may look like this. So here if you see, if you just close this D part, what you have here is hierarchical, and then here you have multiple, right? So that is basically the gist of hybrid inheritance. And now in hybrid inheritance, I just remembered by looking at this figure. Actually this figure is an example of a very famous problem called the diamond problem. So it's a very famous problem in inheritance. Basically the structure looks like a diamond, right? So here it is basically not drawn in that way. So if we just open up Paint, and what you have is you have a parent class. Okay, so A for example, you have multiple inheritances like this. So you have B and then you have C. So this example is from here, the hierarchical inheritance, right? So okay, where is that? Yeah, so this example is from the hierarchical inheritance where you have a single parent and you have multiple children. Then what I'm going to do is combine these two children to another kind of child, which is D. And what is this example from? So if we just remove these things, don't consider this, just consider BC and then you have D. It is basically an example of this thing, right? Multiple inheritance. So here you have a hierarchy and then here you have multiple, and this structure which looks like a diamond is a very famous problem because this doesn't know from where it should inherit. So see, if you're taking this particular path, so from A to B, B to D, then you know that you just need to inherit A. But if you're taking this part, because it is also a part of the parent, right? So C should also be inherited, and for C, A should also be inherited. So the problem is, should this inheritance happen? Because it's already happened, right? In case of B. So if you just search for that, you will have a more concrete explanation of that. So diamond problem. Okay, it's basically, it's not a language dependent problem. It's the problem of multiple inheritance. Okay, so here you will find a more clearer example. So basically it says the same thing which I said here. So name and age needed only once. That is basically the person class should be created only once. But if I'm taking this path, I will be creating this, but since this class which is faculty is also an parent of TA which also has to be created, so should I include the person class again or not? So that is the main question, and we will be solving that by using something called abstract classes. So here you will be seeing some examples of that used here, the abstract class methods. But since we did not discuss it till now, I'm not going to go into detail right now. We'll be going into detail in the next video. But this is the problem. You can read this to get some more insight into this. And that's it for types of inheritance in C++. In this video, we'll solve the diamond problem which we discussed in the previous video. So if you remember that, I had referred you this particular website where the diamond problem is beautifully illustrated. So the diamond problem is, you have a base class or a parent class from which multiple classes are getting inherited, and then you have another child class which are using the inherited classes as the parent classes. So let's quickly create a program version of this. So let's say class A, and we'll again keep this simple. So we'll just say we'll just have a constructor and destructor as we had in the previous example. So you have constructing A, and you have a destructor which says destructing A, and we need to create another class B. So create that, and we need to change the A to B. So the A is going to change into B. So replace and we again paste that, change the occurrences of A into C now. So replace A with C. So done, and again create another class which is going to be D, right? So because we need 4 classes, right? Let me just quickly show you that picture. So this class is being referred to as A. You have B and C, 2 more classes which are going to be inheriting from A, and then you have another class called C which will inherit from both B and C. Sorry, this class will be called D, which is going to inherit from both B and C. Alright, so this is going to be D, so replace that with D and done. So now let's make the inheritances quickly. So class B, as I told you, is going to inherit from A. Class C is also going to inherit from A. If you remember, this inheritance is nothing but hierarchical inheritance, and now we are going to inherit from both B and C, which is nothing but multiple inheritance. So public B and public C, right? And now we'll create an object of D and we'll see what exactly the problem is. So D, say obj, and now if you compile this, what do you have? Okay, I again forgot to put those new lines. Keep forgetting that. So /n over here and over here. Well, now if you run this particular program, what do you have? You have constructing A, constructing B, constructing A, constructing C, and then constructing D. And that makes sense, right? Because we are first inheriting from B and B is in turn inheriting from A. So first B is going to be created, which basically means that A is first going to be created, then B, and that is going to get inherited into D. Then you have C, which again inherits from A. So first A is created and then C is created, and then you have created the D, right? Now the problem is, if I try to touch A, from which path should I go? So I mean, we'll just quickly draw that. So go to the paint here, and we have A. You have two classes, B and C, like this. And then you have combination of these two classes, which is basically the class D. So this is D. Now if I create D in this path or in this path, if I start creating that, I'm again going to create A indefinitely, right? So as you saw in that output, we had created A 2 times. So here you can see constructing A once and constructing A the second time. So we need to avoid that because say I want to access some properties of A, right? And B must have modified the properties of A. We don't know, right? So suppose there's something called X here, some variable, and B, what it did is it made X to 20 and C made X to 30. Just take this as an example. Now at this level it's okay, just forget about the D for a moment. For this level it's okay, they're two separate children and they're doing whatever they want with the inherited properties. Now the problem comes when D has to access X. Should it follow this point which is X equal to 20, or should it follow this path which says X equal to 30? What it should do? So to demonstrate that, let's just create a kind of public variable, just name it X, so int X, right, for now. And here well, we don't have to do anything. We can just try to do something like, since it's just public and we are just doing public inheritance, we could do something like obj.x equal to 10. I could do that, right? This is perfectly normal. Now if I try to run this, I get an error. What does it say? It says request for member X is ambiguous. Why is it ambiguous? That's the same thing I just told. It's ambiguous because it doesn't know what to do. So even if I try to change it over here, or as I explained it in the picture, if I try to change it in one of the inherited classes, if I just change it in one of the inherited classes, so if I just keep it X equal to 30 here and just leave it, then also it's going to be a problem because it doesn't know whether to keep it the same or to change it, right? So this is the main problem, which is called the diamond problem. The thing is, it doesn't know which path to take. Should it change X through B, or should it change X through C, or basically should it change the X over here or not? should two copies be created of X, which will lead to ambiguity. And well, if you don't create X at all, then there is no ambiguity, right? But again, why are you inheriting? You are inheriting something because you want those properties inside the child, right? If the parent doesn't have anything useful for the child to inherit, there's no point in inheritance at all, right? So this problem has to be solved. And how do you solve that? You solve that using something called virtual inheritance. So what does that do? Well, if you see here, what we're doing, we're just creating two copies of A, right? So what virtual inheritance does is, while inheriting into these two classes, I know that these two classes are going to be a parent of some other class. So now my solution to this is, I'll keep this virtual. That is, even if I create multiple copies, they will be pointing to the same object or the same instance which has been created in a memory. So while creating a memory map for D, say I first create A through B. So A has been created once, right? Now if I create it through C, since I already have A will not be created. That is what is the advantage of having virtual inheritances. So to do that, what we do here is, instead of directly inheriting A, we just do something like virtual public A, and we'll talk more about this virtual keyword, right? For now, just keep it like this. So you have virtual public A, which is basically a virtual inheritance, and then you have virtual public A over here. Now, as I told you, A will not be recreated again and again. So if you have 10 classes like this, if you just stop at those classes, if I just access B and C, there's no problem. The problem arises only when I want to go up a level, right? So I want to directly access the X of A. If I had some X of B over here, and if I try to access that, I won't be having a problem because B is a direct parent, or C is also a direct parent of D. But A is basically one level higher, right? So that is where the problem arises, and this is how you solve the problem. You just virtually inherit those classes. So now if I now run this, you wouldn't be getting an error, and it does run successfully. And here you see A has been created, then B, then without creation of A, it has directly created C. Why is that? That's because while creating C, it already saw that there exists a copy of A. That is why it is not creating A again. If it changes order, first the A class for C will be created, and then B will be created without A. Now if I change this, now if I run this, you can see here AC, and this A is because of this inheritance, and since it's virtual, it knows that there should exist only one copy of this particular instance. That is why while creating B, it will see this statement and then look up that memory map and then find out that A has already been inherited, so it won't inherit A again, and this operation is totally valid. So that's how you solve the diamond problem. And about this virtual classes, this virtual keyword, what it does is, it will take care of the fact that there exists only one particular copy. That is what virtual means. So for something called abstract classes, which we are going to discuss in the next video, the abstract classes are basically a kind of base for creating newer classes. Now the abstract classes need not be kind of virtual, right? So see, virtual methods or virtual inheritances, these are useful only when you need a single kind of copy of the property. So say I have a constructor A over here, and if I override this constructor over here, just saying, so instead of B, if I just say A, this is also particularly valid, right? So I'm just rewriting that function over here. Now I can access this A through a method which we'll discuss afterwards, right? So we can access the methods of the parent class, or methods or variables or anything of the parent class through a method. We do have a possibility for that. Now the point of virtual keyword is, you shouldn't have multiple copies. So basically this is creating multiple copies. So through B, if I'm accessing A, it should be printing constructing B, but through A, if accessing this particular constructor, it should say constructing A. So basically there are two copies of the same function. This is called overloading, and we'll talk about this in the next video also, right? So for this particular issue, virtual keyword is there, which basically means that you can have only one particular copy. You cannot have overloading and all. And so in abstract classes, what you have is, if you need only one feature, one copy of that particular feature, you will make it virtual, so that in the inherited class where you have that virtual function inherited, you need to define that function indefinitely inside that class. So in virtual classes, what you do is you just create a virtual method and then leave that. You don't define that virtual method. So in the inherited class, what you do is you inherit that method and then you need to define that method indefinitely. If you don't define it, you will get an error. Alright, so that solves a problem of maintaining multiple properties, and we generally don't actually want multiple properties of the same thing unless in really rare cases, right? So in rare cases, are you going to access the properties of A and B through D? So it's very rare that you're going to access this, but in case you want to access it, this is the solution. You need to make it virtual, right? In this video, we'll talk about overloading and overriding in C++. So let me just write it down here. It's overloading and overriding. Alright. So let's first talk about functions for a moment, right? So when we learn functions, we told that functions are nothing but a piece of code to be executed separately, so that your program can be broken down into a set of functions which will do the work, and then all the results can be integrated together to solve the problem, right? So now let's say you want a function which can do multiple things. That is not possible, right? When we define a function, if we are defining a function, we need to be sure that we pass the same number of arguments or the same kind of arguments to the function to make it work. So let's say I do something like int add, which is going to take in two integers, so int a and int b, and what it will do, it will just return a plus b. Now I can use this function without any problem, and I can even pass integers over here, right? Sorry, I can even pass characters over here, because as you know, characters are nothing but integers behind the scenes. They have their ASCII values, and when you pass a character as an integer, it is considered as the character's ASCII value, right? So basically I can pass integers and characters and floats too, because as you know, because of the typecasting, the floats will be converted to integers and the operation will perform. But what about strings? I cannot add two strings using this function, right? So if I use this function, I can only add two numbers or two characters and get back an integer. I cannot add two strings using this function. It will give me an error, right? So how do we go about solving problems where you want to solve problems using the same function signature? You don't want to write multiple different functions for the same thing, but all the functions are actually similar in nature. That means that these functions can be grouped together. So that's when overloading comes into the picture. So what you do is you keep the signature same, all right? You keep that same, but you can alter the parameters over here and redefine the function. And when you compile the program, the compiler will see the inputs which you are giving, the parameters, and then it will use the suitable function definition for that parameter. All right. So for an example, let's quickly write a small program. So let's write a function to determine whether something, a given input, is a palindrome or not. All right. So if you don't know what a palindrome is nothing but anything which can be read the same way from right to left or left to right. So if you take a word as madam, so madam, if you read it from left to right or right to left, it still remains the same, right? So these kinds of things are called palindromes. It is the same with numbers too. If I do 1001, this is also a palindrome, right? Now our problem is to write a function so that the function can identify palindromes in both strings and numbers. All right. So this is our task. So how do we go about this? Well, writing for strings is pretty easy, right? So let us first write a definition for that function. So let's say bool, because we are going to return a true or false, and it's called palindrome, and it will take a string. So let's call it str for now, right? And to compare palindrome, what we need to do is we need to well, if you think about it, the logic is very simple. I will uh, leave it to you to come up with different methods to solve this particular problem, but for now let's go with the simpler methods, right? So what we can do is we can just iterate over the strings and go on comparing the first and last character of the string. Another way to do this is to reverse a string and then compare it. Well, the first way is more efficient, but I want to take this opportunity to show you that string data type has a lots of methods in it, and one of the method is a reverse, right? So basically what we are doing, we are just, when we are comparing whether our input is a palindrome or not, what we are doing is we are checking whether the number or the string, even if it is reversed, reads the same thing or not, right? That is, if it reads the same thing, it's a palindrome. If it doesn't, it is not a palindrome. So to do that, what we can do is this string class or the string data type does have lots of methods with it. So if you check for string reverse in C++, you do have a function to reverse a string, right? So basically you can do it manually as shown here. You can use a for loop, or you even have a function to reverse a string. All right. So once again, I'm just searching for that. Yeah, this one. So here if you see, you can directly reverse this using this kind of a method, right? So I'll just copy this thing so that I don't have to write it again, but basically this is the way you can reverse a string. And as I told you, the other way would be to just compare the first and last characters and so on, right? So you compare the 0 and the last character, 1 and the last but one character, 2 and the last but two character, and so on. So if you just compare that, that will be more efficient. So yeah, so we can just copy this and paste it over here so that we get the reverse of the string. And what I can do is I can just compare whether the string and reverse are equal or not. So if the string is equal to the reverse, then well, I just need to return true, else return false. So let's quickly try some examples here. So see out, let's say palindrome of madam. All right. And yeah, this method won't I mean allow you to compare strings with different cases, right? So if I do something like madam, this won't be considered as a palindrome. All right, so I'm not taking that edge case for now. So let's just try to keep this simple, but you're open to try out all the edge cases and then come up with a very efficient algorithm to find out whether a string is a palindrome or not. All right, so the purpose of this video is not to explain you how to get a palindrome, but it's basically to explain you overloading or overriding, which we'll do in a moment. All right, so for now this is our program, and if we run this using control F9, what does it say? Palindrome is not declared in the scope. Okay, I have written palindrome, so palindrome. So here you get 1, right? So 1 is basically true and 0 is false, so you know that, right? So now here if I try something else, so let's just try the casing one. So as I told you, this should not be a palindrome compared by this method, right? So we are not comparing cases here. Sorry, we are comparing different cases here. So small m is different from capital M, right? So this will not be a palindrome to the compiler. So it will say it's not a palindrome, so you get a 0 over here, which is false, right? So we have written a string palindrome, but what if I pass in a number over here? So something like 1001. If I run this, I'll be getting an error. It says could not convert this from into a string. So this whole thing is nothing but a string. All right. So to to make this function work even for strings, either what I can either do is I can just say palindrome string and then define an entirely different method for integer palindrome, or what I can do is I can just say bool palindrome. So notice that the signature is same, the return type and the name of the function is same, but here I'm just going to say int10. All right. So here I'm keeping the integer, and to find the reverse of an integer you have a small logic. So I'm not going to go through the logic. Basically what you do is you have a multiple, or very well we can just copy and paste that logic from here since we're not discussing about palindrome. So let's say int palindrome C plus plus. Why do I keep writing palindrome over here? So yeah. So this is what you do. So basically the same thing is going on over here. What this program does is it will find the reverse of the number using this logic. So basically reverse of a number is nothing but you extract every number is basically the remainder. When you divide that number by 10, the r is nothing but the last digit. All right, so n mod 10, as I told you over here, if I do mod 10, it will basically give me the last number. And sorry about that. And here what you're doing is you're just adding that last number by a multiple of 10. So what basically happens is you have 1, and when you store it, what you do is you just store it as 0 into 10 plus 1. So basically you first have sum equal to 0, like this, sum or anything, reverse number, anything you can call that, it will be 0. And you what you do is 0 into 10 plus 1, and you put it inside the reverse number. So basically now this has become 1, right? 0 into 10 is 0 plus 1 is 1. Now what you do is you divide this by 10. So 1001 by 10, which is basically 100. So next again you run this loop. So you do this reverse equal to reverse into 10 plus the last digit. So let's call this last digit. So this is what you do every time. All right. So now what you do, 1 into 10, which is 10, plus the last digit is 0, so you get 10 here. So this is how you reverse the number. So let's quickly write that. I thought of copying it, but since I explained it, it's very simple. So int reverse equal to 0, what you have is, while the number exists, well, we cannot directly use the number, so you need to store the number somewhere for later comparison, right? So we'll just say int num equal to n, we'll store a copy of that. And while n, that means while the number is not 0, so as I told you, in C++ the booleans and integers are related, right? So any number except 0 is true, 0 is false, so it will run until n becomes 0. So till then what to do is we'll say int the last digit equal to the number mod 10. This will give you the last digit. And what you need to do, you need to say reverse equal to the reverse into 10, previous value of reverse into 10 plus the last digit, and the number will become 1/10 of itself. So number equal to number by 10, right? So this is what we'll be doing. And let's just print out the reverse for now. All right, so let's just print out the reverse number so that we are sure that it's working, and we'll just return something. So we'll just return true for now. All right, so now if you see, if I run this program, I did not specify any different name for this, right? So basically both these functions have the same name, but the parameters are different. So when a compiler will see this, it will see that I'm using an integer, so automatically it will understand that I am calling this function. All right, so if I pass in a string here, it will automatically call this function. But here, since we have overloaded this function, this process is known as overloading basically. All right, so overloading is nothing but you just take the same function, you don't change any word in that, I mean any signature in that. So the signature remains the same, you cannot change this return type, but you can change the number of variables and the variables nature itself. So I can even add number of variables over here, it doesn't matter. All right, so if I do that, and now if I run this, if I now compile and run this, I'll be getting 1001, that is the reverse number and then the 1. So if you're confused, let me just add a new line over here and we'll run this again. And here you can see the reverse is 1001, which is what we required, and the true part which came from this statement. All right, so now since we have the reverse, it's pretty straightforward, just like this one, right? So you can just do something like if the number which we saved, this one, is equal to the reverse number, then it's basically a palindrome, so return true, else return false. So even if you write else, it doesn't matter, because if this is true, it will directly return it. So I'm skipping the else part, so return false over here, and this should do, right? So now if you run this program, what you have is a palindrome checker for both strings and integers. So I can even pass integers over here, and I can even pass strings over here. So let's say Malayalam. All right, so this is also a palindrome, so let's check whether the spelling is right or not. Yalam, yeah, perfect. So now if I run this, I'll get 1 over here, and if I try to run something else, I won't be getting perfect result. So if I do that, and if I run this, I'll be getting 0. Or even if I pass in numbers over here, so if I do that, this one, so this is not a palindrome. If I run this, I'll be getting 0. So yeah, this is the use of overloading. When you have a same function, I mean the same function signature, but you want to use it for different kinds of variables and different number of variables. This is how you can use the same function to achieve what you want, right? So here the advantage is that we are not maintaining multiple copies of the same function, but what we are essentially doing is we are maintaining multiple signatures of the same function. So this whole thing is called a signature, and the return type and this should not change. All right, so only the parameter list can change, so this one will only be maintained separately, and these two function definitions will be maintained. The advantage is that you don't have to remember or give, informative big names to different functions. So well, I don't have to worry about overloading. If I'm doing something like this is for string, like this palindrome str and palindrome int, if I'm doing something like this, I don't even have to worry about overloading. But basically the whole point of overloading is that you can have a single function doing multiple things. That is the idea of overloading. And when is this useful? It is useful when we are doing inheritance, and at that time this thing is called overloading, right? So basically these two are the same thing. All right, overloading or overriding just mean that you are using the same function with different parameter lists and different definitions. All right, but overriding is used when you're overloading a function in different classes. When you overload a function from a base class inside a child class, that is known as overriding. And if you overload the same function inside the base class itself, that is overloading. So that is the only difference between overloading and overriding, or else both are the same concept. So to demonstrate overriding, you can just use this one. So what I can do is I can say class say A for now, and this is going to be a public definition so that I can inherit it, and I can just push all these things inside this A, right? And yeah, take care of the indentation over here, and we'll maintain another class B, and inside this I'll just pass these things again. So public, and pass it over here. Right now, if I do a public inheritance over here, what will happen is, as you know, this palindrome will get inherited inside here, but since I'm doing this, it will get overridden. All right. So this method won't act as a string palindrome checker for class B, but it will act as a integer palindrome checker inside class B. So for an object of class B, if you call object.palindrome, if I do something like let's say obj equal, sorry, b obj, all right, this is a new object of class B, and if I do obj dot palindrome, all right, so if I do this, it will only be valid for an integer palindrome. All right, so if I not do that, you will be getting 0 over here. Of course it's not a palindrome, but if I do that and run this, I'll be getting an error. It says it is not integer. So to take care of this issue, there's a method to actually use the functions of the superclass. Superclass is basically the parent class, which I'll talk about in a later video, because that is something very important and we will be using that very much while using abstract classes. So basically all this overloading and overriding, all these concepts come into play when we are using abstract classes. Well, this is not limited only to the functions. You can even overload the constructors also if you want to. So that is the scope of overloading and overriding. In the previous video, we discussed about overloading and overriding, and in this video, we'll talk about abstraction. All right. So, first of all, why do we need abstraction, or what is an abstract class basically? Well, abstract classes are nothing but just a normal class with at least one of the methods as a pure virtual function. Now, what does this mean? It means that a pure virtual function is nothing but a function without any definition. It's just a signature. So why do we need an abstract class when we can just create a normal base class and do the inheritance like this? Well, when you have a very big class or very big networks of classes where you're using multiple methods of inheritances and all these things, what happens is you at some point you forget the structure of the class. Like, let's say we take this function as an example. You're using the palindrome function, and these two methods, just let's just suppose that these two methods are not methods of the string, but you have written these methods inside this base class, which is class A. And now while inheriting, you're just overriding the palindrome class. Now let's say I want to access the string class from class B, because I'm not going to, I don't know that there exists a class A, which is the base class of uh, this class B. I just know that I created a method from class B, because this definition won't be visible to me, right? So as I told you, we will be writing these class definitions inside different files. So when I use that function, when I use that class to create an object, so what I'll be seeing is this thing. So from here, I cannot make out what is the base class or what is the super class or what is a parent class and all these things, right? So what I can tell is this function, I cannot even tell whether this function overrides something or not. For me, this is a completely new class. But inside, let's say you're just overriding this function, and suppose you forget to override these two functions, which may be a dependency. For right now, it is not a dependency at all. But let's say that while overriding, you do need these two functions, not necessary for the palindrome function, but for some other function. These two functions, r_begin and r_end, are written by you inside the base class, and they are necessary for the overrided function to perform. So in that case, you are going to get an error and you need to figure out what happened, right? So for this particular problem, for this problem where you forget the structure of the class, at some point abstract classes are introduced. So abstract classes, what they do is they have a tendency to just create function signatures. They don't implement the functions, they just create function signatures, so that when you get the functions, you need to write them, you need to define them indefinitely. You can't skip the definition. So that kind of function is called a pure virtual function. Well, virtual we did here, care of in while discussing the diamond problem, right? So the virtual keyword, what it does is it will take care of the fact that there exists only one instance of a class if multiple instances are coming. So a virtual function will also do the same thing, a pure virtual function, but the only difference is that every time you implement it, it will be considered as a new function. It won't be considered as something coming from the base class, right? So let's see how to implement that. What you do is you just write the function definition. So let's say int test, it can be anything, right? So int a and b for now. And what I'm going to do is to make this pure virtual and to make this whole class as an abstract class, I'll just do virtual int test equal to 0. And this statement, there's two extra statements, will make this function as a pure virtual function and the whole class as an abstract class. Now what is the result of this? Now if I try to run this, I'll be getting an error. What does the error say? It's at the creation of the object from class B, it says that it cannot declare a variable of an abstract type. Now, what is the abstract type? Abstract type was A because B does not have any pure virtual functions. But still, B is considered abstract because this thing is getting inherited directly. So I need to define this. I'm forced to define this function inside class B while I'm shipping this class so that I maintain the structure. Now, let's say palindrome depends on this test, right? So palindrome depends on this test function, and it is very necessary for me to, if I'm overriding this palindrome function inside the child class, it is very much required to override this test function also inside the inherited class or the child class. So in that kind of a situation, you maintain virtual classes, you maintain pure virtual functions, and you maintain abstract classes. And when you inherit, you can just define that function just like that. So it's basically the same definition, you just need to say int a and b. So these things are already there in b, and you can do something like return a plus b, a simple function. Now, since I've defined this function, I'm not going to get that error. So now if I run this, it will run smoothly and I'm getting one, that is from this palindrome check which we performed in the last video, right? Now, the other thing is that what if we want to access the functions, the defined functions from the superclass, that is the parent class. So now I do have the function for the palindrome check for numbers. Now if I pass in a string here, it is not supposed to work because string is something which is getting inherited from parent class. So if I do this, I'm not going to get a perfect output, I'm going to get an error. So to solve that, what you can do is to access something from the parent class, you just put the parent name and the scope operator. So this two colons are called a scope operator, and if you combine it with the base class, you will be getting the output run from the function which is inside the base class. Now this will run without any errors. Now if I try to run this, I'll be getting one over here. That is because of this one, right? So that's because of this little addition over here, which will make it work for the base classes too. So now if you try to do this for test, so let's say a test, and I do 1 2. So because test will take two numbers, right? Int a, int b. Now if I try to run this, what will I get? I get an error and it says undefined reference to this function. What it means is that this function does not exist in class A. That is because we declared it as a pure virtual function. So once you inherit it, it has to be defined inside the child classes, or else the child classes are also going to be considered as abstract classes. And once you implement that function inside the child class, they can be used just like that. So if I just do object.test, which will basically call this function from class B, which does have a definition for test. If I now try to run this code, I'll be getting the output and it returned 3, which is basically 1 plus 2, right? So that is about abstraction and pure virtual functions. So basically this whole concept will be used only if required. All right, this is not a day-to-day used concept, the abstraction and pure virtual functions. They're not used generally. They're used very rarely when you have a situation where you need to do something like this, or else a simple inheritance will do the job, or not even inheritance, a very simple class can also do the job for you. So these are highly advanced concepts which you may use or may not use in your whole career, but it is always a good thing to know that these exist in case you come across a situation where you need to implement something like this. So with that, let's end this video, and in the next video we'll move away from these class object concepts, and we'll do something exciting. We'll learn how to interact with files on our hard drive using the file stream, and with that we can also explore more about the vastness of object oriented programming paradigm. Well, as I told you, object oriented programming is a paradigm, it's a style. It totally depends upon the problem whether you need to use object oriented programming or not. This is not a part of C++, but this is a part of programming itself. So with that, let's close the object oriented programming for now. Let's deviate from that, and let's talk more about general programming, dealing with files, how to read files, how to write to files, and all these things. In this video we'll see how to handle files using C++. Now, what is file handling? Why do we need to handle files? Well, whenever we are running a program, if we are taking some input from the user, or let's say we are even generating something which is really important, and we need to store those things, like let's say in our snake game, when we made that, we had no provision to give a high score, right? Because every time you run the game, the score starts from zero, and there's no way to know what was the highest score made till date using this game, right? So to counter such problems where you need to store data to a hard disk, not in the RAM, because whatever you're doing in the program in its runtime, it's everything is getting into the RAM, right? Nothing is going to be stored onto the disk, but you do need something on the disk so that whenever you uh, want the data back, whenever you want to read the data back, you have a way to read it back. You don't have to, again ask the user to enter everything, or miss out some important things and all those things. That is why we actually handle files. We write files to store data so that it will be useful in the long term. Now, everything in C++, as we know, runs on streams. So whatever we are doing with the operating system, with the hardware, everything runs on stream. So you're already familiar with one of the stream known as IO stream, right? Input output stream, which allows you to access your keyboard and mouse using C++. Now, for files, you have another stream similar to this IO stream, which is known as the file stream. So, what will file stream allow you to do? It will allow you to access the hard disk of the computer so that you can write files there. So, you can write many types of files using file stream, which we'll be discussing in a later video. But today we will start with something really simple, which is nothing but the ASCII files. ASCII files are nothing but what you see every day, the .txt files, right? So we'll be writing ASCII files today using file stream. So let's quickly import that, hash include fstream, and here in fstream you have a class called fstreams, right? So fstream is a class, and there are two other classes. So let's quickly talk about them. One is known as the ofstream and one is known as the ifstream. Now, what is fstream? Fstream is nothing but a class. It will allow you to create a file object with which you can write files, right? But ofstream and ifstreams are nothing but inherited classes. So these are nothing but children of this parent class, and the use of them is pretty straightforward. Ofstream is nothing but the output file stream. So you use this whenever you want to write out files, and ifstream is nothing but the input file stream, which you will use when you want to read files, when you want to take input from the file, right? So these are the two classes. Well, these are useful for fast things, because in the f stream, what you need to do is you need to provide something known as flags. So let me just write it down here. You have something known as flag, which you need to provide to the fstream class to read to get a particular functionality of the file. So when you want to read in a file, you put a particular flag. When you want to write out a file, you put a particular flag, and all those things. We will be talking about that later, but today we will be seeing one of such flags. So basically all these flags start with something like iOS. You have two colons, and then you have a string over here. So we'll be talking about this flag today, which is iOS app, which is nothing but appending flag, and we'll see what append means in a short while, right? So this is about the classes. This is just an overview. We'll dig deep into it in the future videos, but today we'll see how to quickly write a file, how to read a file, and what are the different ways to read from a file, right? So let's start with writing out to a file. So for that, what we need to do is create an object of OF stream, output file stream. So OF stream, and our object is going to be file, right? Now to open a file, what you can do is you can just say file.open, and inside this you can pass in the file's name. So I'm just going to do test.txt. Well, this file doesn't exist. I'll just explain you in a moment what this does. But basically, for now, you can say that this file doesn't exist on my computer. It will be created by this OFStream class. Now you can either use this method, the dot open method, or what you can do is you can directly call the constructor. So you can just uh, use this constructor. You can just pass in the name of the file over here, and that will do the same job as file.open. So this is about opening a file. Opening is nothing but if that file exists on your hard drive, what it'll do is it will just load it into the RAM. So whatever changes you make to that file, everything will be affecting the original file in the hard disk, and once you close it, it will be removed from the RAM. So that's how OF stream works. And another important thing is you need to always close the file. So once you open a file, it's really important that you close the file. Well, this should be in the last technically, but I'm just putting this right now so that you guys remember that whenever you open a file, you always close the file. This is a must, right? So it won't affect your program much, but what it's going to do is it's going to clean up the RAM. So you don't want your files dangling around in the RAM, right? So if you forget to close this file, it will be present in the RAM, and it will be removed only when you restart your computer. So that is the reason it's always better to close a file once you open it. And that's about creating a file or opening a file. So if this file exists, if this exists, where does this file go? It just goes in the same directory as this main file. So I have this project saved in my desktop. So if I go to my desktop and open that project, it's YouTube. So here you can see main.cpp, and well, I had created this file before, so let me just remove that. So here you have main.cpp, right? So this is the directory where the file is going to come. Now if I just run this program, if I just run this, I'll be getting a successful run, and if I go there, I'll be seeing test.txt over here. So this has been created right now once I run this program, and it will be created whenever you run this program. Basically what happens is even if it exists, it will just overwrite everything in that file. So if I write something over here, so if I write something like this is a test, save that, close that, and again run this. So if I just run this again, go back here, open up test, and you can see it's blank, it's gone, right? So that is what happens when you open a file. I'll tell you how to save the previous contents, but for now let's just talk about creating a file. What happens is even if it exists, it will be overwritten and a new file will be created in the same name, right? And it's just like you're just deleting it and creating it again with the same name. And it will be always created in the same directory from where you run the program. So since I'm running it from main.cpp, so here I'm at main.cpp, I'm running it from here, it's creating in this directory. And if you go to bin debug, here you will have the exe file, right? So I've told you how to distribute your programs. So this exe file will be created every time you compile your program. And if I now double click on this, the test.txt will be created in this directory. Now this is different from this one, right? So When I run main.cpp, it will be created in this directory. When I run this debug, it will be created in this directory. So basically, if you don't provide directory, what is going to happen is it's just going to create it in the same directory. And if you want to create it in some other location, so let's say let's create it inside this obj. So here you have a folder called debug, right? So I'll create one over here. So you'll just need to provide this folder's name. So all you need to do here is I'll just say obj slash test.txt, and if I run this, and I'll be getting it over here. So obj test.txt, right? So that's how you create files in different locations. And whatever it suggests is that you don't worry much about the locations. You just create the files and then move it to wherever you want, right? That's going to be really easy. So that's one way, or else you can just create it in the exact location you want and work with them. It's up to you. But for now, this is how you create a file. And now let's see how to write to the file. We have opened this in OFStream mode, right? So you can write to this file. So how do I write this? Well, how do I write something to the console? You do something like this, right? So cr, this is a test. This is how you write to the console. And let's say new line, and this is on another line. This is how you write to the console. And if I run this, what I'll be getting is I'll be getting those lines onto my console. Now, the way you write to a file is really simple. What you need to do is you just need to remove this C out and place file over here. So that's how you write something to the file. This operator is all that matters, because both of them are streams, right? And this is nothing but a stream operator, this output stream operator. That is why what you can do is you can just use this operator to write something to the file. And now I just close this file. If I run this, I'll be creating a file of the name test.txt inside obj. Well, I did not remove this. Well, basically it will be created inside obj, and you will have these contents. So if I go here, so this is not the file, so here you can see it's empty. It's inside obj, and here you have test, which has those contents. So this is how you write the file, right? So this is how simple it is to write to a file. You just use the stream operator to write to the file, and you must have guessed it, reading a file is almost similar. So now let's move on to reading files. I'll just delete this. I don't want my structure of the project to be messed up, so we'll just keep this inside the same directory. And now to read from a file, what I can do, well, before going to reading from a file, let's talk about appending to a file. What is appending? Well, if I not change this content, it will be overwritten, right? So you just seen that whenever I use OFStream, our file will be deleted and a new file will be created in its place with the same name, right? So if I now remove this, so let's say I remove this, so this is on another line, is the only content. If I now run this, I'll be getting that thing inside this file test.txt, which has only one line. Now how do I add something to this? I cannot add something, right? So if I just remove this and I add something else over here, so if I just remove this, I just keep this, the word this over here, and I run this, you know that it's just going to be overwritten over here, everything else would be gone. I just have this over here now. Now how do I tackle this? Well, there is a flag, as I told you in the beginning, it's the appending flag. How to add flag is that you just put a comma in the constructor or in the open statement. So if you are using the function to open it, you just do the same thing over here. So you just do test.txt, put a comma and write whatever I'm going to write here, right? So here what I'm going to do is add the appending flag. So iOS, these two colons, and then you do app, which will enable the file in append mode. So what happens is that it is not going to whitewash the file, the things are going to remain, but whatever I'm going to add now are also going to be written over there. Now if I do something like this is some new content being added, and just to differentiate, let's keep it on a new line, because if you don't keep it on a new line, it just works like cout operator, right? If you don't keep a new line, it's just going to write it beside that. So that's the thing. So if I just write this, save this, run this, build and run this, sorry. And now if I go to my test.txt, so that is the file I've been writing to, right? So if I now open this, here you can see that the new content has been added and the old one is being preserved. So that is about appending files. And now let's talk about reading from a file. Well, to read from a file, it's almost straightforward. What you need to do is just remove OF stream and replace it to IF stream. So IF stream is nothing but input file stream. And how do you read from the console? You do this, right? So you have variable called string s, and you just read from the console like this. And to read from a file, just replace scene with file, and that's going to allow you to read the file. And now since I have a string here, what is going to happen is it's going to read word by word. Now if I do cout s, I'll be getting the first word. So what is the first word over here? In my file, the first word is this, right? So I'll be getting this over here. So if I run this, I'll be getting this. And now if I change this to a character, if I do char, and now if I run this, I'll be getting the first characters, which is T, right? Now, how do I read the whole file? So basically what happens is that whenever you write a file, whenever you do file.close, what's going to happen is that the newly added content, after that, at the end of the file, you have a special character which is not visible, known as the end of the file character, or the EOF. So EOF is nothing but end of file, and this is a character. And while this is not reached, we can just keep on looping. So what we'll do is we'll run a loop, and after every time we get a character, we'll check whether it is the end of the file character or not. Once you reach the end of the file character, you'll just terminate the loop. So how do I do that? It's really simple. I just do, well, let's just keep a string variable on the outside of the loop so that we don't create it every time. So here what I'm going to do is while, let me just put it on new line, while file.eof. So while file.eof has not been reached, so for that I need to put not. So while not file.eof, while not file.eof has been reached, what I can do is I'll just read the word inside string, and I'll just print out the string on a new line. Right, straightforward. Now if I now run this, what I'll be getting is I'll be getting all the words. So this is some new content being added. So all these other words in my file. So that's how I get word by word. If I need character by character, it's almost the same thing. I just change this to char, run this again, and I'll be getting every character in my file. So this is how you read character by character. And if you want to read line by line, it's a little bit different. You don't read to the end of the file. What you will do is you'll just read the lines one by one and read till you reach the end of the file. So what you do is, I'll just show you, it's just string s, and here what I do is get line from the file inside s, and while you can get the line, if you don't get the line, it's going to return false. If you can get the line, it's going to return true, and I don't need this operator too. So I'll just remove that, and now if I run this, I'll be getting the lines. So this is some new content added, and then a new line. That's because of this one, right? So here you can see it's just reading line by line. So if I want to stop at somewhere, so basically what this does is it's called a delimiter. So what it does is you have a line, right? So you have this line and you have this line. So how is it stored in the memory? You have this special character which you know about, right? This is the slash n. So this is how it's going to be stored. So this, when this character is reached, it will consider this whole sequence as a new line. But what if you want to consider this? So if I just put this character in between, I want to consider this one as in one line and this whole thing as another line. So that can also be done using the delimiter. So what you do is you just put a delimiter, like I just put a space over here. So that's going to be considered as the delimiter for stopping when and considering the whole sequence as a line. Basically the default is that slash n, because that's what you consider a line, right? So whatever, if you write something like this and then you move to the next line, so when you press enter, that slash n is getting added. So that is what you consider as a new line. But basically if you want to consider something else as a new line, this is how you do it. And now if you just run this, I'll be getting every word. That is because after every word I've given a space, right? So, and this is the delimiter I've given. And if I put something else which is not there, so if I put this thing, it is not there in my file, right? So that character is not there anywhere. So the whole thing is just going to be considered as a sequence. Now if I run this, here you can see the whole thing has been considered as one single line, right? So that's how you can read from files, you can write to files, and it's all about the text file. So you can do many operations, like you can read, you can count how many words are there, or what you can do is you can read the files and see if some data is getting stored over there, or some specific word is appearing in that file or not. So all these things you can do. Let's quickly write a small program to do that. What you can do is, I'll just say of stream file dot close. Never forget these two things. When you open a file, you need to close it. And let's say we'll just say that cout enter your name, and I'll get a name here. So string name, C name. So this is just like, I'm just showing you how you can use the files. This is just a simple example. And here I will do another thing like cout enter your age, and I'll just say int age, C in age. And now what I'll do is, I have already opened the file, right? So let me just move this down here. I don't want to put this file in the memory right now. So once I have all this information entered, I'll open the file. I will write this information to the file. How do I write it? I'll just say a name and a name, new line. It's just like the cout operator, right? I hope that you're getting the similarity over here. And then it's age, and then the age. That's it. I'll just do file.close, and well, I did not give any name to the file, so let's say details.txt. I'll use this name. I'll build and run this. I'll be getting, what is your name? It's Tony. What's your age? I'll say, okay, it's too much. Let's say 12, and I enter that. I run that program. Now I go here, I have this details.txt. I open that, and here I have my details. So whenever I need this information again, I'll be having that information, and I can just read from this. Well, basically for these kinds of information, these are nothing but details, right? So you have name, Tony, age, stuff, and something like that. So you can maintain a table like that. So will that kind of stuff, that this is just to store text data, this is just to store ASCII data. There's actually another way, another better way to store information like this. It's nothing like SQL. If you're familiar with SQL is nothing but a database language. But for now, what we can do is, we have something called binary files. So what you can do is, you have something called .dat files, where you can write classes. Now why do we need to write a class? Well, all these things, if you want, you can just create a class, and then you can assign particular variables for that. Once you have a object of that class, you can directly write that object inside the .dat file, and you can access them. This details thing, that's how people do it, because it's really easy to access in that way. Because once you have this one line, you need to strip that line, you need to get that last character and all those things. So that kind of things won't be necessary, right? So that is the only reason people use .dat files, because once you have a class, once you read it inside a class, you can just do well, it's just like you have something like %p, and once I read this inside this, what I'll do is, I'll just do p dot name. I'll get the name, p dot age, I'll get the age, and something like that. So p dot age will give me the age. So that's how people do it, and we'll see how to do that. Hey guys, welcome to Programming Knowledge. In this video, we'll see how to deal with binary files using C++. Now, binary files are something which are different. They are not as simple as ASCII files. So in the previous video, we saw how to deal with ASCII files. So basically, what are ASCII files? ASCII files are nothing but the files which you see, right? So whatever you can see on your computer using some application or the other. So using Notepad, or using something like this code blocks editor or something. If you can see the file, if you can read the contents of a file, then it's ASCII. If you cannot, then it's something else, and that is binary file, right? So here, if you see this main.cpp, I can read this using any notepad or something, and I see all these contents, right? But if I go and open up something, so let's say I open up a game. So here I have the Watch Dogs 2 game open, and if I go to this folder, I see a lot of files here with extension .dat and .fat, right? So these are all the extensions which are commonly used for binary files, so .bin, .dat, and all these things. So what happens is you cannot read things which are inside this thing, right? So if I do, even if I force to open this using my notepad, so if I do something like notepad comment.dat, so I will be seeing lots of characters, but none of them will make any sense to me, right? So let's just wait for a moment. It's going to load everything, and here you see there are so many characters which doesn't make any sense. So I do have some ASCII characters over here, so basically just /39 something like that. So maybe these are some escape sequences or something, but basically the whole file, almost 99% of the file is data which you cannot understand. So that is why you use binary files. You don't use it to save your data from somewhere, but basically what happens is this dat file or bin file, whatever, they contain objects. They do not contain plain data, they contain objects. So if you remember, so if I write something over here, so whatever I write here, these are all characters, right? So you know that. And now if I write any number over here, this is not a number. So that's what I wanted to tell here. But if I write something over here, if I write this number inside a .txt file, it is not stored as a number, but it is stored as a character list, or you can just call it a string. It's just stored as a string. It is not a number, but I want to store it as a number, right? I want to store it as an actual object. How do I do that? So that is when binary files come into play, right? So now in this video, we'll just see how to basically read and write a binary file. It's a very big topic, so we'll be dividing it into videos, and in the upcoming video, we'll see how to do operations using binary files. But in this video, we'll just understand what binary files are and how to write them, how to read from them, right? So let's start. Firstly, reading and writing are almost same. The constructors are almost same, right? So use OFStream, IStream, all these things. The difference comes when you are using the methods and the way you operate the files, right? So let's see how to do that. So OFStream file, and I'm using the constructor to open the file. So let's say test.dat. So this is basically a common extension for binary file. You can use .bin or something like that. And yeah, one more thing I wanted to mention here is that this extension doesn't matter, right? So even if you use .txt, it's going to work, but basically it is recommended that you use extensions which convey the nature of the file. So what I mean is, if I go back here inside this game folder, mm, yeah, let's go to this folder. You see lots of these DLL files, right? So if you see these DLL files, you see this gear kind of icon, right? So that is basically because the Windows operating system knows that this is a DLL file. It knows how to interpret that. So for DLL file, it has assigned this kind of icon. So that's why it's showing you. For images, it must have assigned some kind of icon, and for C++, it must have assign some kind of icon, and so on, right? So basically these file icons are dependent on the type of extension you give it. It's not dependent on the data, right? So the extension is for the operating system to identify the kind of file and to give it a suitable icon. But even if you mess up the extensions, it doesn't really matter, right? Because the way the computer is going to store the data is controlled by the data itself and not by the extension. So even if you put .txt for a binary file or .bin for an ASCII file, it doesn't really matter. You can still operate on those two files in their native way, right? So we'll see that. So for now, let's go with the recommended way. So test.bin, and here, if you just leave it like this, it's going to be interpreted as an ASCII file. As I told you, extension doesn't matter, but here you need to put it as iOS binary to interpret this file as a binary file, right? So this will open this file in binary mode, and of course it's in output stream mode, so I can write to this file. And another thing, I need to close this. So all these things are the same thing which I mentioned in the previous video. You open a file, you close the file, and in between, whatever you do, that will depend on different file types. And ASCII files, we saw how to write. We just do this. The most simplest way to write to ASCII file, you just do this. You write all your data here. You just put this operator. What it will do is it will direct everything inside this file, and it won't store it as a specific object. It will store everything as a string. So if I do this, this will go and sit as a string, right? Now, to write an integer, let's say we create an integer int p equal to some 1023. So this is our integer, and I want to write this integer to this test.bin. How do I write this? Well, the way you write it is file.write. So this is a method, and here you have two parameters. So one is const cat type star and this thing, and another thing is the stream size. So let's see what they are, right? So basically what happens is, in binary files you convert your data into strings of bytes, and the way you do that is you go to the address. So if you remember, the address is given by AND, right? So this ampersand symbol will give you the address. So AND P is my address of P. I'll take this address, convert it into a character string, right? So a string, you can, this string is a class, but character is a data type. So basically what I'll do is this is a character array which is nothing but a string. So basically this is equal to a string, right? So this is almost equal to a string, but string has some additional functionalities. It is a class in C++. You don't have a string data type in C++. But anyway, you just convert this into a character array because it's the primitive data type, and you take the pointer of the first element and you give it to the writing object. So this thing, it has file pointers inside that, and we'll go and see, we'll explore file pointers in more depth in the upcoming video. But for this video, you have file pointers which will take the pointer of this first object. And in the second thing, where in the second argument where you mentioned the stream size, so if you remember, you had two arguments here, right? The first one was this thing. The second one is basically the stream size, which will tell the pointers how many bytes of data to take. So here you have a memory, right? So if I just open up my paint, and I have this whole memory. So this is all my memory I have in my computer. So let's say 16 GB or 32 GB, whatever it is I have. I specify the first, so let's say the integer is stored in this 4 bytes. I know that integer size is 4 bytes, right? So let's just consider a realistic scenario. So I have 4 bytes over here. What I will do is, if I do and p, sorry, what's happening here? Undo. So here I have this and p, which is this thing, which will give me the address of the first point, right? So this is what the AND operator does. It will give me the address in hexadecimal format. I'll take that, give it to the file pointer, and say that I, from this address, read 4 bytes of data. So what it will do, it will take this, it will read 4 bytes of data from here, and it will store that data inside the file. So that's how it works. So if I do 10 bytes, it will do the 4 bytes, and whatever is remaining, it will read from that too and try to store it. And it, it messes up the data, right? So that's how you store files here. You read 4 bytes, you read the size of the object, the you take an instance of the object, read the size, and then save this memory thing inside a file. So that's how binary files work. You directly don't write data, you go to the address, you take 4 bytes or whatever the size of the object is, you take those things, convert it to bytes, and then write it, store it, right? So that's what we're going to do here. So here what you need to do is, first of all, get the address, so which is given by ampersand p, which will give you the address, convert it to a character array, and here I need to specify the number of bytes. So it's just 4. I can just write 4, or if you are not sure, just use the size of operator, right? So size of p, right? This will write this thing, this 1023, as a number inside my file known as test.bin. So now let me just run this thing. I did not get any errors, and let me just open up my folder, and here you see test.bin. And if I now go and look at the properties, it is exactly 4 bytes, right? So 4 bytes is because one integer is 4 bytes, you know that. Now if I try to open this, if I try to open this using some notepad or something, so let's just use notepad here. Notepad test.bin, enter. So here you see some weird character, right? So this is some character, but it's not 10. What did I write? 1023. It's not 1023, right? So that is how you write binary files. They are files, they are written there, but you cannot see them. They are written as objects. If you want to write two numbers, that's the same thing. If you just write this, and I have another integer q which is 102, let's just keep it as 1000. I do the same thing again, right? CV, and instead of P I just write Q, right? Run this, it's written. I go back here. Okay, why am I closing this again and again? Just open and keep this, right? So here I have test.bin. Go and look at the properties. It is 8 bytes because two integers, right? So that's how you write binary files. And for now, we are not going to write multiple objects because it's a little bit different how you iterate over objects. So we'll see that in the next video. But for now, we'll just stick with one object, right? So you just write one object, run this, and it again, as you know, I'm not using any appending, right? So I'm not using iOS append. So it will just write it from the beginning. So if I go and look at it over here, it's 4 bytes. Now, the other thing is reading from this binary file. How do I read this? It's really similar. Just replace this with ifstream and take out this definition. Let's say int. Let's just keep it int p for now. This is read, and these things remain the same. So what does this say? You read something to this address. It is not from this address this time. It is to this address. And how much should I read? I should read this much bytes, right? So I know it's kind of confusing, but you need to get used to it while dealing with binary files. So basically everything runs on sizes and this byte strings. So here what you're saying, you are giving the address and you're saying read to this address, and how much should I read? I should read these many bytes, right? And after that you can just close the file and you can even see what is the thing over here. So if I do the value in p is, and I just show p, and if I do this in the beginning I won't say anything. So if I just copy this, and as soon as I create a variable, if I do this, so I'll just do value in p before reading is, and value in p after reading is, right? So if I do this and if I run this program now, if I run this, so here if you see the value in p before reading is this big number, which is completely it is garbage, right? So it doesn't have any sense. But the value in p after reading is 1023, which we stored in the file before, right? So why this happened? This is because the if you take those 4 bytes before reading in this location, and if you convert it to an integer, this is the number you will get. So it doesn't have any meaning, it's just a number, right? So yeah, that's all it is. And here this 1023 is after taking the bytes from the file, converting it to an integer and giving it to this location. So that's about reading from binary files. And the other thing is I mentioned about the extensions, right? So if I do something like text.txt and I put this iOS binary flag, and if I try to read something from that, so I'll just comment this thing out. So edit comment this, right? And here I just commented this section, and if I open a file of that name test.txt and I write something, so in p equal to 10, and I write file dot write char star and p size of p, and I close the file. and I run this program, right? It ran without any failures. And if I go here, I will have a test.txt file. So if you look at this, this is a txt file, so it can be opened with notepad. But if I try to open this thing using a notepad, right? So if I try to open this thing using a notepad, I'll again see well, there is a character here which you cannot see, but so basically what happens is the computer will try to interpret the data every time you open it, but basically sometimes the character which it interprets is something which you can see, and sometimes there are some characters which you cannot see. So this is one of the examples where you cannot see the character, but there is a character here which has been interpreted, right? So that is what happens when you mess up the file types. You can see that the extension here is of a notepad, right? So if I use .txt, I'll get this extension, but if I use .bin, it doesn't know, so it just gives me this kind of extension. But if you see here, the icon which has been generated is of a notepad, right? A .txt file, a text file. But if I open it, it's actually a binary file. I cannot see anything over here. So that's why I told the file extension doesn't really matter. You can change the file extension, and it's the same thing while reading too. So even if I put .txt over here and I try to read this as a .txt file, that will also work. So if I just copy this selection, uncomment this, and I try to run this. So here if you see the value of p before reading is this number which is garbage, and the value of p after reading is 10, which I stored just now, right? So that is the reason for using .bin, .dat or all these things. That the only reason is that it is for for the operating system to show you the correct file icon, right? So if you mess up the extension, don't worry, it will work as long as this thing is there, because if you take out this, it's not going to interpret anything. So this will now be interpreted as a ASCII file, and if you try reading and writing from this file, it will fail because everything is in binary format, right? So that's about simple reading and writing of binary files. In the next video, we'll definitely see how to do operations on binary files, but basically it is not restricted to integers only, right? So I just wanted to show that. So if you just create a class, let's just create a quick class now, student, right? And we'll just put everything in public section. You have a name, sorry, age, you have a name, and let's say you have a roll number, and here you create a constructor of student, and you just put age, name, role, and well, because these two variables are same, I need to use the this pointer. I'm sure you remember that. And this dot name equal to name, and this dot roll number, well, I need not use that, but still it just looks nice, right? So it is uniform over here, right? So that does it. Now if I want to write this thing to a student file, what I will do here is I will create an OF stream with the name of the file as student. Let's say student data.dat or .bin. Let's go with .bin, we already saw that, right? And here I need to put the flag as binary, so I use binary. And after that is done, now I need to create a new student, so student s, and I can just pass in the age, roll number and all these things. So age, name, something, and roll number which is 1, let's keep it 1. And to write this thing to this file, I just do the same thing which I did before. So file.write, what do we need to do? It is char star. It just becomes by hearted, right? So if you do this a couple of times, you'll just type it out without much thinking, but basically the meaning is the thing which I explained before. You're just converting the address into a character array. So char star and s, size of s, the 4 characters, so a b c d. I just close this file.close, and now I run this thing. I get an error. What does it say? Expected this before. Okay, I wrote this as Python. Sorry, I need to specify the data type over here. right? So okay, this is good. Run this again, get which is these are considered as pointers. Why is that? Okay, let's just do that. Oh yeah, that's because this is a pointer, right? So I totally forgot. Sorry about this. I've been coding in other languages lately, so I completely lost the touch of 3++. But sorry. Well, I'm sure you won't run into these kinds of errors, right? So yeah, very well. It worked here. And if you go to that location where you stored the files, so here you have student data.bin. So here you have 32 bytes. Basically, you just store data like that. And now if you try to open this thing, so if you now try to open this thing, you won't see anything. Well, I'm just saying that again and again, but basically, this is to uh, make you familiar with binary files so that you don't run into an issue when you don't see anything over there. So this is what you see, but abcd is a string, that's why you're seeing string, but other things are all numbers and bytes, that's why you're not seeing anything, you're just seeing just weird characters over here, right? So that's how you write to binary file. You write data into binary file. To read it from a binary file, you just it's the same thing as you did with an integer, just that this is nothing but not a common object, but it's something which is made by you. It's a user defined object. So do that. It is file.read. This is ifstream, right? Do that. And you can always show these things, right? So see out s dot name, new line, s dot age, new line, s dot roll number, right? Run this. I get another error. What does it say? Okay, that's because I don't have this kind of thing. I don't have this constructor. I'll just define an empty constructor then, right? You can have as many constructors as you want. This is just overloading, right? So I'm sure you remember that. So do that. Run this, and here you have some errors over here, but basically the string is a class, that's why I had to use this is not a it's not a data type as such, right? String is something which has been made on top of characters, so you need to use characters. The string is actually a class. I thought we'll talk about this later, but after seeing this, I think that we need to discuss about the string class very soon. But basically, string is a class, it's not a data type, so it doesn't work like other data types. That's why you're seeing this thing. But basically, if you use characters, if you use character arrays or something like that, that will work, right? So instead of name, I'll just do something like char star, right? And here char star, and again you need to use string methods. Like you have a string class here, hash include c string. So you have this class, you need to use this class, right, to copy name and all these things. So strings are something, it's a whole different topic, we'll talk about that. It's not as simple as just defining it as a string, but basically you have a whole set of operations on a string. But if you do that, this is how you store data inside a file. So that's why you got this 32 bytes and all those things. I thought I need not tell that right now, but yeah, in the next video we'll discuss about that, and also we'll discuss about how to um, read, how to search, how to write multiple records and do all these things, how to delete things and all these things, right? So binary files not about uh, direct ASCII value writing. It's not really simple as just writing something as we did in the previous video. It deals with pointers, it deals with memory addresses and all these things. So if you're not comfortable, watch this video couple of times and then try this on your own so that you get familiar with this statement. So this statement you need to understand, because in the next video when we talk about the file pointers, this thing is going to be really important. So make sure that you understand this before going on to the next video. So hey guys, welcome to Programming Knowledge. In this video we'll be dealing with the CRUD operations in C++. So if you are a web developer, you might be already familiar with this term CRUD. which just stands for create, read, update, and delete. Right. So these are the operations you do on a database. Right. So now, what does this have to do? What does database have to do with binary files? Well, if you see in the last video, I just talked about how we use binary files, right? So binary files, we write objects inside binary files. And what is a database? Database is nothing but a collection of records, right? So how does those two relate? So let's say I have a database of employees. So they might have an ID, name, and what else, they might have an address, phone number, etc, etc, all this information, and then you just store it as a table. So 2, 3, 4, and so on. So ID number 1, all the information, 2, all the information, 3, all the information, 4, all the information, and so on. So this is what a database would look like. And what we're doing in binary files, we're doing the same thing. We're just making new employees. So employee 1 is basically all this information, employee 2 is all this information, and employee 2 is an object, employee 3 is an object which has all this information, and then we're just writing this object. So basically you can think of binary files as nothing but a database, right? So if we are making a database, it should be able to do all these operations. It should be able to do CRUD operations, which is nothing but these things: create, read, update, and delete. And well, update and delete will also include searching a record, right? So how will you update without searching, right? So these operations are something which are really important if you are maintaining a database. So database, you can just, if not a very technical database, you can just think of database as just a collection of records. That's it, right? So to do that, in this video we'll see how to do these operations on a database. And before that, we need to know how a binary file stores data, right? We already know that binary file just stores everything in binary format, but we need to know how it actually stores, right? So let's say I have these 4 records, the same thing, and it is not stored in such a neat table format. What it does is it just dumps all the data in one single line. So you just get 1 all the data, 2 all the data, 3 all the data, 4 all the data, and whatever you have. If you have 100 data, you just get all the 100 things in one single line. So that's how binary files work. And now let's say I want to do operations on this third record. So I want to update or delete or something, or I want to insert a new record in between these 2 records or something like that. If I want to do any operation of that kind, I need to first find this record. So how am I going to find? I need to move to this record, right? So for that, you have something known as file pointers. So just write it down here. You have file pointers which are get and put. So get and put are 2 pointers. Well, both are exactly the same thing. So if you talk about a file pointer, it's just like cursor. So if you think about this whole thing as a file in the memory, this cursor which is blinking over here, that is the file pointer. And get and put are exactly the same thing. Like the task may be different, but basically the pointer is the same. So when you use a get pointer, you actually use it when you want to read data, and put is when you want to write data. And if you are doing both, it doesn't really matter whether you use get or put. It's just for convention, right? So get is used with ifstream. Why? Because ifstream just opens a file in read mode, and put works with ofstream because it opens a file in write mode. So these are the 2 pointers, and you have functions to use these pointers, right? So you have this tell function and then a seek function, because we just need these 2 information. So whenever we're working with a cursor, what do we need? I just want to know where this cursor is blinking, and I want to move this cursor to some place, right? So I have these 2 functions, and they're the variations. So tell G is for the get pointer, tell P is for the put pointer. Similarly, you have seek G is for the get pointer, and seek P is for the put pointer. And what tell does, it will just tell you where the cursor is, and seek will move the cursor for you. So you can just pass in like 10 bytes, and it will move the cursor 10 bytes, right? So that is all about the file pointers, and we'll be using this in code, which will be more clarifying for you, because these things are something which you need to understand when you are working with binary files. So that is why in the previous video I told that we need to understand how that read and write statement works, that syntax, you remember that, right? So char star, address of object, and then size of object. Now these things are basically interacting with these functions inside, right? So this whole thing tells that I need to write this whole array of bytes, and this is the crucial thing which tells how many bytes to write. So if you say if let's say my file is over here and I use write method, what it will do is it will just write down, and then it will seek the pointer to, let's say, 10 bytes forward, or whatever the size of the object is. So I am here, I write a new object, I write everything, and then get the cursor and put it over here for the next record to write. So that's how file pointers work, and we'll see how to use that in a short while. So well, we have already run create and read, so we'll do update and delete in this video. And just for a boost, I just have created a very simple class. So I have this employee class which all the attributes are public. So I have id, name, address, and then I have a simple constructor which does nothing. So this just to initialize an object, and this is one useful constructor to actually create an object without assigning one by one, right? And I have this info method so that I can just see what this object is, so what are these things, so it will be useful while reading the object, right? So this is the class, and to write this class, as I told you in the previous video, we could not use string, right? Because when we use string, we could not write properly. It's because string is a class, it's not a data type. So what you need to do here is, I'll tell you what to do here, but we'll talk about strings in a later video. But for now, the fix is that first of all, let's talk about the reason. The reason that writing produced some garbage inside that particular file is because string is a class, and you cannot write objects inside objects. So what you need to do is you need to change this to something which is primitive. So you have primitive data types as float, double, and you have integer, long, char. All these are bool. All these are primitive data types, right? So you can write all these things inside a binary file, but you cannot write a class. So well, you can write a class, but the class should consist of primitive data types. It should not consist of some other classes, right? So that is not allowed in C++. So to do that, what you do here is you change this to primitive data types. Now, what is a string? String is nothing but a collection of characters. So what you can tell is string is nothing but a character array. So let's say name is of 30 characters long. So this just like just name it, and if you know SQL, this is the same thing as doing something like varchar, right? So you have something called varchar which does the same thing. You just specify the number of characters you give, and this will create a character field for you. This is basically SQL, so don't well, if you don't know about this, don't worry. But basically the same thing you're going to do over here too. The only reason we use string is because when the string class makes it easy to handle these operations. So I'll just talk about what it is, but basically string class will allow you to work with strings really easily, right? So that's one thing. But for writing you need primitive data type, so we're going to use arrays, right? So address of 50 characters, and now I can just say string name and string address. And now to actually copy the string inside the character array, what I'm going to do here is I am going to include one other header file which is known as cstring. So what this has is, this has lots of functions dealing with the string operations, right, which are not included directly. So if you talk about this, so if I want to copy this name inside this particular array, what I have to do is I need to run a loop, get one character, and paste one inside that. So that is not required. You could just use a function called strcpy, which will just copy a string, right? So strcpy, this takes the source, this destination, which is name, and then the source. And source here is a string. It's what requires is a const char, right? Const char star. So you can just char star is nothing but you can just think of it as an array, right? So because see, we talked about this when we are talking about the arrays in the in our previous videos. When we talked about arrays, we saw that if you declare a pointer to an array, it will point to the first element. So if you are declaring a pointer, it's as good as you are just saying that this is the first element of an array. So that's why generally people use pointers to specify the arrays whenever you are dealing with variable sized arrays, because if we don't know the length of the array, it's really easy to just show that this is the first element and then go these many bytes to get all the elements. So that's how we work generally, right? So that is one thing. And here, to get the character representation, what you do is you have function called .c underscore str. What this will do is it will give the C string representation of this string. So as I told you, string is a class, so this is an object, and there is a method inside the string class which is C underscore str, which will give you an array of these characters. So that's how you copy a name, copy a string in primitive data types, right? So same thing goes with address. So address, and then you have addr dot C underscore string. So that will copy the things, and that should do it. So now you have successfully changed this thing, and you can just try it out. So employee A, and let's say ID1, name Tony, address NYC, and you can go with well, let's go with Captain America now. So Steve, and then let's say Brooklyn. So you have these two objects created, and let's just make sure that everything is working fine. So yeah, there's no error, so everything worked fine. Now let's go with the creation part. So let's quickly create function for that. Void create. What you need an employee object. Create is nothing but write, so it's just create or write. It's just called create because you create a new record, right? So basically it's just, you can think of it as writing something inside a file. So employee obj, what you do, you just open a file in OFC mode, right? And let's say details or that. How do you open it? You open it in binary mode. And here what you do, f.write, the syntax, the most important one, character and obj, size of obj, and then you close the file. So that should write an object, right? So now you can just say create A, create B, and if I just run this, I have created this file, and you can just go and check in your directory. You will have this details.dat file, right? Now moving on, let's go to the read operation. Well, these are the things you already know, so it's just going to be quick, right? So yeah, just you don't take anything because you're going to read the entire document. So just say ifstream file, which is details.dat iOS binary, and you need an object of employee, so employee obj, and then while you can read, so after read character and obj, size of obj, you just say obj.info. So this is the reason I had this method defined over here, right? So yeah, after that, what to do, you just close the file. So now I have already created these two things. Well, one thing I forgot to do is I had to create it in append mode, right? Because once I close the file and once I again open it without the iOS append, it's just going to replace the thing. So I forgot about that. So you need to add the iOS append file, because you don't want to just keep on creating new ones and just keep deleting the old ones, right? So that is one thing. So just create these two things. I'll just run this again. Well, now it would have appended there, so I'll just delete this and run this again. Run it. I have created two new employees. I can just comment these things out now. I can just do read, run this. I'll be getting those two things. So ID1, name Tony, address is this, ID2, and all the information, right? So we did CR. Now U and D are remaining. So U is basically, what you do is you need to update. And how do you update? You first need to search for something. So first of all, we need to make sure that we have a unique identifier for every object. So this, if you are talking in the language of database, this is known as a primary key, right? So you have a primary key which is unique to identify an object, because take in this case you have just name and address, right? So name can be same, addresses can be same, but the ID cannot be same. ID is unique. So here the primary key for our class is ID, and that's how you choose a primary key. Primary key should be unique, and that goes same with databases and also this one, right? But here we're just hard coding that ID is what we want, right? So in update I'm just going to take in the ID which I want to search, and then what I want to update. So well, you can update a whole object, that's also possible, but since well, I did not write a copy constructor over here, let's just keep it simple. Like, the concept remains the same, right? The concept remains exactly the same. The only difference being that you just update a whole object instead of updating a part of the object. I'm just going to update the address of the object, so I just say string addr, right? And here, now what I'm going to do here is I want to open the file in read and write mode simultaneously. Why? Because once I get to an object, I need to, first of all, I need to search for a particular object which involves reading the object, right? Which I like, let's say I have these two records. First of all, I need to search whether this record is what I want. So let's say I want to update this employee 2, and I want to update this address. So first of all, I need to read through the entire records I have. I want to first of all find out whether this thing exists or not, and then if this exists, what I'll do is I'll just go back a record and then overwrite it. So that's how it works. You have A, B, C, D, E, 5 records in a line, as I told you. What I'll do is first read A, check it, it's not the thing I want to update. Right. Check B, it's not the thing I want to update. Let's say I want to update C, I'll read C, I'll check it, it's the thing I want to update. I'll go back, update C with the new record. So C becomes F, and then break out of the loop or even go ahead. So it basically depends on the operation you want to do. So let's say I want to update all the addresses of people whose names start with S, something like that. So that kind of thing you don't break out of the loop, but if you just want to update a unique thing, you just do that. You just break out of the loop because it's not worth going forward, right? So that was a quick explanation of how update works. So first of all, we need a boolean variable which is false in the beginning, right? And I will just return this boolean variable so that we know whether an update worked successfully or not. And what else you need? You need to open a file in both read and write mode simultaneously, because as I told you, you need to search and then you need to write. So this is fstream details.dat, and here you need to pass the file. So ios in, ios out, and also ios binary, right? So I opened this file in both read and write mode, and then in the binary flag, right? And other thing is I need a temporary employee object so that I could just put it in the memory and read the information inside that class, right? Now what I do, I just do the same thing as reading a file. So f.read char star and obj, size of obj. Now inside this, what we're going to do here is, first of all, I need to search, right? So this is a searching part. So if the ID which I'm searching for, well, if the object which we read with the ID of that object, whether it's equal to the ID which we are searching for or not, that's what we need to check, and that is searching. So if it is equal, we perform the operation, else we don't, we just move on, right? So let's say it is equal, we got the object. What we need to do, first of all, we need to say that we found the object, so it is true. And then what we do, we just update whatever we want to update. So here in this case, I'm just updating the address. So strcpy string copy obj address, and then the new address I just specified. So addr dot c underscore str. right? So I do that, and then where do I have to write this? I need to rewrite this, right? I need to overwrite. So now if I just do dot write, so if I just do f dot write, the same thing, cache star object, size of object. I could write a macro for this. I'm just writing it again and again, right? So yeah, anyway, if I just do that, what will happen is, let's say I wrote A, B, C, D, E. I want to change E. So first I read A, checked A, read B, checked B, read C, checked C, and I want to change C. And now if I try to update C, what will happen is, if I just write, I'll just overwrite D. That's what is going to happen now. That's because I'm not gone backwards, right? So what happens here is that I'm just overwriting the next record, not the record I'm at. So I need to go back that record. How do I go back? Remember the file pointers we talked about in the beginning? I have them. No, I deleted those comments, but basically all this get and put pointers, right? So what you do is, you take the pointer, take the put pointer backwards. How much backwards? First of all, get the position where it is. So tell the position and go back. How many bytes should you go back? Just go back those many bytes which this object occupies, so size of obj. From where you need to go, you need to travel that position from the beginning of the file. So that will take care of the movement. So what will happen is, what you're saying in this line essentially is, let's say I'm at this position. I'll just say tell G is something minus the size of object, so minus here, from where? From the beginning. So from here I'll just go to this much positions, right? So that is how this CP works, and you just write out that object, and here in the end you can just return that object, so return found, so that you know that you have found something or not. And well, you can also break out of this loop. That's also possible. You can do that. So first we'll just read it, right? We'll first read the initial data. I'll just remove these things. Read the initial data. We have these data. We'll just change this address. So what I'll do is, I'll just say update id to, and then address to, let's say Baker Street. I'm just changing the address over here. I'll do that, run this, and it works successfully. Well, I did not show it over here, so I'll just do C out. That will also work. I'll get a 1 or 0, right? So here I got 1. That's because this ID exists. If I do something with where this ID does not exist, I'll get a 0, and I'll show the message to the user that hey, the ID you're searching for doesn't exist in my database. Create a new ID, something like that. So we updated that. Now what we're going to do here is read again. Do that. What do I get? See, the address has been changed, and this is not from the update thing, right? So it has been changed directly inside the file. So that's how you update things inside a binary file. So the same way you could also update the whole object, right? But I did not do that here because I need to create another file and it take time. But I encourage you to try it on your own. So instead of string, you just have a whole new employee object, and here you just, instead of copying that, you just create a copy constructor over here. So I think you all know what a copy constructor is, and you just need to define a copy constructor so that these IDs get copied, and then you just paste, and then you just do the same thing. You just go back and then write out the new modified object, right? So that's about updation, and now comes the deletion, which is a little bit different. So this is delete, and again this also involves searching, so let's just say pool delete. Well, delete is a keyword, we'll just keep it as del, and then you have a ID. Now what you're going to do here is, we will first the process remains the same. You first search for the object, so these things remain the same. You just copy and paste this thing. Instead of f stream, you could just say if stream, because it's just going to read it. Right, and here I'm just going to search for that file. So the whole thing you will just copy and paste. Well, you don't need the whole thing. The inside is going to change, the if condition is going to change, and then you just say return font. Right now, how are we going to delete something? Well, we cannot directly delete from a file, just like what we do. Like, let's say I want to delete this. If I just press backspace, this line goes away. But this action cannot be performed using C++ binary file objects. You don't have a delete method inside the object. So how do you delete it? Well, the way you delete it is you just create a copy of this, whatever database you have, all the records. You just create a copy, but you don't include the thing which you want to delete, right? So well, I'll just explain you it again. So if I have A B C D E, and let's say I want to delete T, so how do I delete it? I create another file called temp. So this is all inside our details.dat file. So these are the contents. So in temp file I want to delete T, so I'll just copy A B C E, right? So if you see here, I skip D because that's the thing I wanted to delete, and then now I have successfully deleted. Now what I'll do is I'll delete this file and rename this as details, right? So if I do that, it will look like I have deleted this thing. So that's how you delete files in C++, or delete records in C++. And to do that, you need another library, which is standard input output, because you're going to work with the standard stuff inside the hard disk. You want to rename, remove, and all those things. So those things are available in the standard input output file, right? So here what I'm going to do here is I'm going to create a new file which is called ofstream. And then this is a temporary file, and this is just going to be some temp.dat. I'll do the same thing, iOS binary. And here what I'll do is, if the ID matches, what I'm going to do here is I'll just, well, if the ID does not match, well, if the ID matches, we don't have to do anything, we'll just skip that. But if the ID does not match, what we'll do here is well, you don't even need this found equal to false. You don't have to search for this. If you think about it, you're just trying to delete something which does not exist. So basically you just skip it. If it does not exist, you're not going to delete anything. So yeah, you can skip that. This found can be skipped, it's not required. And this return statement too, it's not required. Now if it is not equal, what you're going to do, you're just going to say temp.write, that whole thing. So same thing, char star obj, size of obj, you write that. That's it. That's how you delete a file. Now you have written that. Now what you're going to do is just close those both files. Temp to close. Now you just remove details.dat, and then you rename temp.dat to details.dat. That's it. See how simple it is to delete something. It's just a workaround. You don't have a delete method in binary files, and this is how you delete it. You just create a copy without this record which you want to delete, and then you just rename it in the end, right? So if let's say I want to delete this, first of all read that, delete ID number 1, and then read again. Do that. If I just run this thing, well, everything came at once because there's no new line. But yeah, if I just comment these two things out, because it's already deleted, you don't have that. So if I just do read, you will be seeing that I just have ID number 2, I don't have ID number 1, right? So that's how you do the CRUD operations in C++. You have create, read, update, and delete. Delete is something which is kind of different. You just create a new file with all the data except the thing you want to delete. And update is you write it, you read the object, you find the object where you want to read, and then you update it, go back a record, and then overwrite it. So that's how updation works, and it's the only place where you're going to need to use input and output at the same time, right? and other things are pretty normal. The create and read or something which is we already know about, and this is how you do the CRUD operations in C++. So that's it in this video, and in the next video we'll move forward, and then we'll first talk about things like static, which will make this will id independent of initialization. That means I could, if I want to, I could just say 1 1. So what it will do is it will just delete all the ones. If this loop runs, it will just delete all the ones, right? If I just print id 1. So I don't want this to happen. I want the id to be generated on its own. So how to do that, that we'll see in the next video, and also we'll talk a little bit about the string class, because slowly we'll understand how to work with the string class. So this is one function you learned today, and this is one header file which you learned today, C string, which basically contains all the functions we need for string. So you have lots of functions in that. So you have strcpy, which is for copy. You have this compare, so cmp is for compare, cmpi is for comparing without the case comparison. That is, it doesn't ignore the case of the strings, right? And then you have all these functions. So strcat is for concatenating strings. Basically, why we use string class is because we want to directly use operator. So let's say I have string a and then b. I could do something like a equal to b using the string class, but this is not possible when using something like a primitive data type. If I use array or something, I cannot do this, right? I need to compare character by character. So these things are the reasons why we use string. But when you're dealing with something where you want to write into the files or something like that, you do have to use the primitive data, right? Hey guys, welcome to Programming Knowledge. In the previous video, we saw how to do file operations in binary files using C++. You can also call it CRUD operations. So we saw that by taking an example of an employee class, right? So that class had an ID attribute which we used to identify each employee uniquely, and we were performing our operations on that. So the problem is that in that particular program, the ID was not being generated automatically. It was unique because I kept it unique, right? When we were writing the program, we had to keep it unique so that there were no conflicts in that program. But what happens is that generally you don't want to do it on a very large scale, because you may forget what was the last ID, or you may forget something else, right? So it's best that these kinds of things be automated. And how do we automate that thing? Well, you can use a global variable, that's a solution. But the best solution is to maintain something known as a static variable. And that's what we'll be talking about now. So, well, static variable is nothing but that variable gets created and will stay until the program's life cycle ends. So, what do I mean by that? Let's say I have a function here. So this is some function, and I have say three variables inside this, and I even have some other variables. So let's say de over here. Now what happens is that this main function is going to run indefinitely, right? So I'll be creating these two variables on start of this program, and let's say I even have some global variables. So let's say G and H are global variables, right? So let's say these two are the global variables. These three are the uh, function variables of this particular function called func, and this two are the variables which are there inside the main function. Now what happens is that once I run this program, first these two variables will be created, and then because main will run indefinitely, these two will also be created. And since I did not call this function, these variables won't be created, right? So now there's sometimes we do need variables to be created and stay even after their role ends. Or let's say we want a variable which acts like a global variable, but it is not a global variable because it's not useful anywhere else. So this kinds of requirements generally arises when you're using recursive functions. So let's say I create a function for calculating sum of numbers from 1 to n, which calculates it recursively. So let's quickly make a definition for that. So max, um, well, we'll just take the maximum element of an array. It's not sum of n numbers. Let's say the maximum element of an array. So you could just say max element, which takes an array and it takes an index so that it can recursively do that, right? Recursively calculate the maximum element which is present inside the array. So now what happens is that, let's say I maintain a variable called max. Well, max is a keyword, so let's say underscore max, which is basically in the beginning it's int min. So if you do int min, you're basically getting the least value an integer can hold. So sorry, minus int min is same as int max. You will do either way. Sorry for confusing you on that, but basically int max and int min are the extremes you can store inside an integer, right? So now I get this maximum element, and now let's say I recursively find out the maximum element inside this array by using this index. Now what happens is that I don't want to create this maximum element again and again. So one solution is to keep a global maximum element. So I could just do int max over here, and I could start out with this. Well, I could just start out with this over here. So I could just say int max, and every time this function recurses, I can just update this maximum element so that I can get this maximum element inside this array. Well, it's not going to be int max technically, it's going to be int min, because I'm taking the maximum element. If you are taking the minimum element, it should have been int max, right? So anyway, well, we are going to just follow this logic, but the problem here is that this max is actually accessible by any function and any class which is inside this program, right? And we don't want that because we're not going to use max anywhere else except this function. So the solution for such kinds of problem is to use something known as static variables, and that's what we're going to discuss today. So let me just quickly clean this. So using namespace standard int main, right? So the way we use static variables inside functions are like this. So you say int maximum element of an array and you pass in an index, and then instead of declaring it as int, you just say static int max, and it's going to be the minimum value, right? So now what happens is that if this max has not been initialized, it will be initialized with this int min, which is the minimum value an integer can hold. And then subsequently it will be updated. Well, the same variable will be updated even if it recurs through the function. So let's say we'll just quickly write this function. So what's the base case? Base case is when index equal to 0, right? So when index equal to 0, you just update max. So max becomes well, we can just use a ternary operator here. So array of 0 is greater than the current max, then max becomes array of 0, else it just stays, right? And then you just return the maximum. And then since this is a base case, or else what you do is you just do the same operation with the current index. So max equal to the array of let's say index minus 1. Well, I took 0 over here, so I'll be starting with the last index, right? So index n or n minus 1, right? So array of index is greater than the max. Then you just say array of index or else the max. And then what you do is you recurse through the same function. So max element of the same array at the index minus 1. And in the end, you just return the maximum element. So this function is quite clear as a recursive function. The only difference being that instead of declaring this max as a global variable, we have declared it kind of inside the function, but a variable will be created in the global scope, but we cannot access it. We can only access it inside this function. Now, if you just want to test this out, you can just create an array. Um, you can just call it 1, 2, 3, 4, 5. And then, well, this is quite obvious. Let's say 40, 10 over here. And then you could just say max element of this array and start with index 4. Or, well, you can just take
take out the size from here, but since I mentioned index, it's just the last index, right? I'm going backwards. So if I do this, run this particular program, I'll be getting the maximum element as 10, which is correct one. So that's how we use static variables. The main thing is that we don't want to create it as global. That is because we don't want this variable to be accessed by everything. But at the same time, it should act like a global. It should not change, right? So if I just remove the static, well, the result is quite obvious because every time this function recurses, you'll be creating a new max, right? So if I just run this, you'll see that I've been creating a new max every time. And once I reach 5, max is basically the fifth element. That's because this at the last iteration, what happens is that I'm just reassigning max to int min. So 5 is basically the maximum element possible, right? So that is something which we don't want. We want to store the maximum of the previous array elements also. So in that cases, you just need to make it as static and use it. Well, static variables inside functions are not really exciting. We generally use static in case of classes. And that's because we don't have to create an object of a class, or we don't have to create an instance of a class to use those static members or member functions. So let's quickly see how to do that. Let's take the case of the employee, right? So let's put everything as public for now, right? So now what we're going to do here is I'm going to say static int id, and I cannot actually assign it over here. I'll be getting an error. So if I try to do that, so let's say employee A, right? If I try to run that, I'll be getting an error. That's because I cannot uh, initialize a static member right inside the definition of a class. I need to do it outside. So how do I do that? I just need to do something like int employee ID equal to whatever ID you want to start with. So let's say I want to start with 1, right? Or you can just start with 0, and in the constructor you can increment this ID. So we'll create the ID, we'll keep the ID private so that you don't get into issues. Or well, it doesn't really matter, right? You can keep it anywhere. So for this demonstration, I'll just keep it private because we are just going to have this ID as static and no other members for this example, right? So you can just play around with this, but basically the concept remains the same. It's a global variable, but not completely global. It's just it acts like a global variable, but only for that scope, right? So now you have the static ID. Well, it's static int ID, and then in the public section, I'm just going to define a constructor employee, right, which will auto increment this ID. So that's what we wanted, right? We don't want to set the ID again and again. So I just say ID plus plus, right? And I can also keep a public variable which is going to be the ID, right? ID of this current instance. So I could just say int emp ID. Now what's the difference between these two things? This is basically a global ID which will keep incrementing itself, but this is going to be the ID of my employee which is using, like basically the particular instance which we are targeting. So there I can just do employee ID equal to the ID which we incremented. So that actually s- solves our problem of having to manually increment these IDs, right? And we also have initialized the static variable. Now what I can do is I could just create A, B, C, D, and if I do let's say B dot employee ID, right? And let's say D dot employee ID. Now if I run this, I get 2 and 4, but I do not assign any employee IDs over there, right? So basically, I auto incremented the IDs. Now every employee I create will be uniquely identified, and if you want to see how many employees I created, you can just access this variable, right? Since this is private, I would have kept it public. Well, generally we don't keep such things as public. We don't want to give it access, right? So well, you can just do a small function, so get count, right? And get count is basically going to return you the ID. So it's going to be void, or I could just return that. So int get count, which is basically return the ID. And I could just say cout get count. Sorry, I could just say a dot get count, right? And I'll just keep a new line here for separation. And if I run this, I'll be getting 2, 4, and 4. That's basically the 4 employees we created, right? If I create another one, I'll be getting 5 there. So if I just say A, B, C, D, E, and well, I need to stop this, run it again. So here you can see 2, 4, and 5, which is basically the number of employees. But this isn't very intuitive, right? You're just saying A dot get count. A dot get count doesn't mean anything. Get count is basically for the employee class, not for the object, not for A particularly, right? So the way we can do that is we can also make this function as static. So how do we do that? We just say static int get count. And now what you can do here is instead of accessing it to A, you can just do employee and then the scope resolution operator and get count. Now, what this means is that how many employee objects have I created? Just get me the count of that. And this is more intuitive than actually calling get count like that, right? So generally, whenever we want to use static variables or whenever we want to view static variables, you generally put it as static functions because they belong to the class, not the function. Sorry, not the instance, right? So if you see get count is actually a function which belongs to employee class, not to A or not to B or not to D particularly. So now if I run this, I'll be getting the same output. So 2, 4 and number of employees I have created is 5, and you could use it in the other way if you wanted to. So I could just say, let's say p dot get count. So this will also work, right? You could access static variables directly, but this is not generally recommended as this is not very intuitive, right? So that's about static variables. In the next video, we'll do something exciting. We'll talk about generics, right? We'll talk about templates and how we can make generic functions so that we don't have to override them again and again. So if you remember about the vector, right? So if I do hash include vector, and here if I do something like vector, and then I need to put int over here. So this kind of thing, that's basically because I have only one vector class, but I can use it for any data type I want. So if I want it for string, I could just do string over here. So we'll see how to do this thing for our own class. And that's all for this video. So in the next video, we'll see how to do all these things, and it's going to be really exciting from now on, right? So yeah, that's all for this video. Thanks for watching. Happy coding.